Hello everyone. Welcome to another show. This time I am doing KCET 1984 to 2025 application of derivatives. 42 years PYQs I'm covering of application of derivatives chapter. Okay. So quite important chapter CET point of view. For our new viewers, I have done previously KCET 1984 to 2025 of differentiation chapter. Okay, along with concepts. Here also I'll be doing along with the concepts. And many more videos are uploaded connected to J mains, PYQs. Also synopsis of limits chapter are done. Also touch NCERT second PU. Okay, first PU also I'm going to upload more videos in the coming days, and synopsis of all the chapters will be covered one by one. NCERT exercise of both first PU and second PU also will be done. Okay, and even the PYQs from 1984 to 2025 of all the chapters will be uploaded. Okay, please subscribe to my channel Abhiram's Maths Marathon. It is, and also I'll be doing J mains also PYQs. Synopsis for separately I'll do for both KCET and JE, that also is there. Okay, even NCERT exemplar book problems I'll be solving chapter wise. Okay, with this we'll start application of derivatives, and one important thing to be noted in this chapter is from 1984 onwards the CET started, right? So earlier in the syllabus we had the topics like tangent and normal, okay, angle between the two curves. Okay, then we had subtangent and subnormal. These are the deleted topics from this chapter. So we can see quite a less number of questions in this chapter. Okay, at present we have derivative as a rate measure, increasing and decreasing functions, and maxima and minima. Only three topics. And one more topic was there prior to 2 years back. We had syllabus reduction, correct? So in the year 2023. Before that, in the NCERT syllabus, we had tangent normal was there, and one more topic was there that's called errors and approximations we call. Even that topic is deleted. Okay, NCERT syllabus was introduced in our state since 2012. Before that we had state syllabus, Karnataka state syllabus. There we had tangent and normal, angle between the two curves, and we had subtangent and subnormal before that. Okay, before the introduction of NCERT syllabus, okay, to our Karnataka state board, we had Karnataka state board syllabus. Okay, there we didn't have any prescribed textbook, correct, for PU studies. During that time we were referring many other books. During that time we had the 5 topics included during that time was tangent, normal, angle between the two curves, increasing and decreasing function, subtangent, subnormal, and maxima and minima. These were the 5 topics. Once the NCERT syllabus was introduced, during that time we had increasing and decreasing function, rate measure, tangent, normal, errors and approximations, maxima and minima. At present, errors and approximation and tangent normals are deleted. 2 of them are deleted. At present, we have only 3. Okay, restricted to only 3 topics: increasing and decreasing function, derivative as a rate measure, maxima and minima. Only 3 topics are there. So this is a number of questions asked from various years are given. From 1984 you can see only one question, because other topics were there, as I told you, that are not included. Okay, I have included only 3 topics. Okay, rate measure, increasing and decreasing function, maxima and minima. Only 3 topics are included. So other things are not included in this. Okay, the number of questions against a year. 1984 only one question. 1985 it is, you can't see any questions from these 3 topics. Of course other topics questions were asked, like subtangent, subnormal, tangent, normal, angle between the curves. I have not included those things. 87 one question, 88 one question, 1989 2 questions, 1992 questions, 91 3, 92 3, 93 3, 94 one question, 1995 one question, 1996 3 questions, 1997 one question, 1998 one question, 1999 one question, 2000 one question, 2001 one question, 2002 3 questions, 2003 2 questions, 2004 one question, 2005 one question, 2006 one question, 2007 one question, 2008 2 questions, 2009 2 questions, 2010 2 questions, 2011 one question, 2012 4 questions, 2013 2 questions, 2014 2 questions, 2015, one question. 2016, two questions. 2017, two questions. 2018, three questions. 2019, two questions. 2020, one question. 2021, two questions. 2022, two questions. 2023, four questions. 2024, four questions. 2025, three questions. So, in the past few years, from 2023 onwards, I can tell the questions were asked only from three topics. Okay. Of course, yeah, 2023, the syllabus was full syllabus was there, NCERT. After that, 2024 and 25 reduced syllabus. Okay, 20% were deleted. But still, in 2023, four questions were asked. No, luckily, or it is like coincidence, or purposely, the question was asked only from three topics: rate measure, increasing and decreasing, maxima, minima. No questions were asked from tangent, normal, and approximations. Okay, so 2023 to 2025, I can tell on average 3 to 4 questions the weightage of this chapter. Okay, but still we can't give guarantee for CET exams how many questions do appear every year. It fluctuates, more or less 3 to 4 questions we can tell. Okay, so we'll begin the questions now with rate measure. Along with solving the problems, I'll be explaining the concepts too. That's the advantage of listening to this session. Okay. So, derivative as a rate measure. We know that dy by dx is the rate of change of y with respect to x. Derivative indicates the rate of change of one quantity with respect to another quantity. Correct? Dy by dx is rate of change of y with respect to x. So, similarly, given the various notations, dr by dt means what? Rate of change of the radius with respect to time. dA by dt indicates rate of change of area with respect to time. dV by dt is rate of change of volume with respect to time. ds by dt is rate of change of surface area with respect to time. So rate of change of one quantity with respect to another. A table is given for your information. So derivative indicates what? dr by dt means what? Rate of change of r with respect to t. R is usually radius. dV by dt, rate of change of volume with respect to t. T is the time. Okay. So this is for your information. A basic idea is given here. So what is derivative? Idea is given to you. And you know the list of formulae. All these things you need to learn. Okay. Area of circle, pi r square. Correct. Circumference of circle is 2 pi r. One of the important things to be noted here is if you differentiate the area of the circle now with respect to radius, I'm going to get circumference. Correct. If you differentiate area of the circle with respect to radius, what I'm going to get is the circumference. dA by dr. If I want to show you the steps. Area of circle is pi r square, right? Area of the circle is pi r square. If you differentiate with respect to r, what I'm going to get? dA by dr. dA by dr. Constant into variable. Constant keep as it is. Derivative of r square is 2r. That is 2 pi r, correct? 2 pi r is nothing but the circumference. So rate of change of area of the circle with respect to radius is nothing but the circumference. And also, I can ask you to find rate of change of area of circle with respect to circumference. That also you can find out, like how you do parametric differentiation. Like that I'm going to do. dA by dc, suppose you want. dA by dc could be written as dA by dc is equal to dA by dr divided by dc by dr. dA by dr divided by dc by dr. dA by dr is how much? 2 pi r, correct? dA by dr, rate of change of area of circle with respect to radius is 2 pi r. Rate of change of circumference with respect to r. Circumference is 2 pi r. If you differentiate with respect to r, I'm going to get 2 pi, correct? 2 pi into 1, 2 pi. So 2 pi is going to cancel. What I'm getting is r. So rate of change of area of circle with respect to circumference is nothing but the radius of the circle. Correct. Next we have list of formula. Continue. Volume of sphere 4 by 3 pi r cube. Surface area of the sphere 4 pi r square. Here also you can note down that if you differentiate the volume of sphere with respect to radius, I am going to get the surface area of the sphere. dV by dr is equal to surface area for a sphere. If you want to show that also. Volume of sphere is 4 by 3 pi r cube. Correct. Volume of sphere is 4 by 3 pi r cube. R is the radius. You find out dV by dr. Rate of change of volume with respect to radius. 4 by 3 pi is constant. Derivative of r cube is 3r square. Correct. So what I'm going to get? 3 cancels. We get 4 pi r square. 4 pi r square is nothing but the surface area of the sphere. Surface area of the sphere. So rate of change of area of the circle with respect to radius gives circumference. Rate of change of volume of sphere with respect to radius gives surface area of the sphere. Also, I can find dV by ds in this case. Once in CET 2017, I think the question was asked. Also, it is found in NCERT exam that book, finding dV by ds for a sphere. dV by ds, rate of change of volume of sphere with respect to surface area. We can write this as dV by dr by ds by dr. dV by dr divided by ds by dr. dV by dr is what? dV by dr is 4 pi r square, correct? Differentiating volume of sphere we got. If you differentiate the surface area with respect to radius, I'm going to get 8 pi r, correct? 4 pi into derivative of r square, 2r, 8 pi r. So here pi is going to cancel. What I'm going to get is r by 2. R by 2. dV by ds is r by 2. So you can remember this. Even for volume of cube and surface area of the cube, we can do like this. Volume of cube is x cube. Surface area of the cube is 6x square. If you differentiate volume of the cube with respect to x, we get 3x square. 3x square is nothing but half of the surface area. Surface area of the cube is 6x square. Half of the surface area is 3x square. Half of the surface area of the cube is going to be dV by dx. And also we can find dV by ds in this case. We'll get dV by ds, we'll find out, we'll get x by 4. Okay, that is shown here as a separate note I have given here. Okay, it's quite useful in this. For a circle, whatever I told just now, for a circle, rate of change of area of circle with respect to radius is circumference, and rate of change of area of circle with respect to circumference is radius. dA by dc is radius. And for a sphere, rate of change of volume with respect to radius is surface area. Correct? dV by dr is surface area. And if you find out dV by ds, it is going to be r by 2 as I proved. And for a cube, if you find out rate of change of volume with respect to x, what I am going to get is half of the surface area. dV by dx, half of the surface area. And if you find out dV by ds, I am going to get x by 4. Okay, instantly you can get all those things. If you forget also, no problem, just given the information. Okay, if you can remember, you can answer instantly, in no time you can answer. If you don't remember, if you can't remember, you can derive there itself, doesn't take much time. Okay, so I don't insist you to remember this, I insist only which is possible to remember. Okay, because you are writing the exam in 1 hour 20 minutes, correct? 80 minutes exam, KCET exam, 1 hour 20 minutes you are going to get. Okay, and you're studying for 2 years and you have to remember everything, correct? Everything has to be filled in your mind and go and write the exam. So everything can't remember. What you learned in 2 years is quite heavy, correct? You're writing the exam in 1 hour 20 minutes. There is no time to think also, correct? That much level preparation should be there. Then only it's possible to crack all the questions. Otherwise, you'll be shortage of time. You'll be running out of time. That is damn sure. Okay. So various formulas, list of formulas, you can go through. Area of rectangle, x into y, length into breadth, perimeter of the rectangle 2 times x plus y, area of the square is x square, diagonal of the square is root 2x, perimeter of the square is 4x, where x is the side, volume of cube x cube, surface area of the cube is 6x square, diagonal of the cube is root 3x, correct, where x is the edge of the cube. Area of equilateral triangle root 3 by 4x square, height of the equilateral triangle is root 3 by 2 into x, where x is the side of the equilateral triangle, correct. Volume of right circular cone 1 by 3 pi r square h, total surface area of the cone is pi r square plus pi rl, lateral surface area of the cone is pi rl, correct. Volume of cylinder is pi r square h, correct. Total surface area of the cylinder, of a closed cylinder, is 2 pi r into r plus h. Curved surface area of the lateral surface area of the cylinder is 2 pi RH, correct? All those formulas you must learn. Hope I told everything, correct? So, all the formulas you need to learn, okay? Please make a note of these formulas. If you learn all these formulas, it becomes easy to solve the problems. Okay, so we shall take the problems one by one. Other than these things, in rate measure, you got to study about the velocity and acceleration, 2 things, and also marginal revenue and marginal cost as found in the NCERT textbook. So far, it is not asked in the KCET exams. Marginal revenue and marginal cost connected to economics, correct? It's a commerce kind of. So even there also we need a rate measure, correct? So, and velocity and acceleration, and beyond that we need to know what is angular velocity and angular acceleration. One such question was asked in KCET 2021. Connected to angular velocity. Angular velocity is rate of change of angular displacement. Angular acceleration is rate of change of angular velocity. Correct? So all those things I am going to explain. First we'll work out the problems based on this. Then we'll go to problems connected to velocity and acceleration. Okay, so we'll take the first question now. This is already explained to you. So the first question comes here. Okay, this question is almost found, I think, in the NCERT exercise, miscellaneous exercise, old example. Almost same type of question or exactly same might be present. A circular plate is there of radius 5 centimeter is heated due to its expansion. Radius increases at the rate of 0.05 centimeter per second. R denotes the radius. I won't write all those sentences. So dr by dt is given. Rate of change of radius is given. Rate of change of radius is given to be equal to 0.05 centimeter per second. And the rate at which area is increasing, you have to find out. When the radius is 5.2 centimeter, so dA by dt you have to find out. Rate of change of area of the circle, you have to find out when the radius is 5.2 centimeter. When the radius is 5.2 centimeter, at that instant you need to find dA by dt. dA by dt. This problem is connected to circular plate. That's the most important. You have to identify what is the geometrical figure given, whether it's a circle problem or a equilateral triangle problem or a spherical problem or a cylinder problem or a cone problem. First you have to identify that. So this question is clearly based on the circular plate dimension, right? So it's connected to circle. So I'll start with area of circle. Area of circle we know pi r square. Differentiate with respect to time. Want to find dA by dt. R is given, dr by dt is given. Substitute, get the value. Substitute, get the answer. Area of the circle is A equal to pi r square. Differentiate with respect to t. dA by dt. I would write all the sentences here. dA by dt is equal to constant into variable, constant keep as it is, derivative of r square, 2r into dr by dt. Differentiating with respect to time. So what we get? 2 pi into radius is given to be equal to 5.2 and dr by dt is 0.05. Correct? 5.2 into 2. Correct? That becomes 10.4. 10.4. This is 10.4 into 0.05. That comes to 0.52. 0.52 pi. 0.52 pi centimeter square per second. Centimeter square per second. Question asked in the year 2023. Okay. It's quite simple one. 0.52 is the answer. 0.52 pi centimeter square per second. Otherwise you can multiply. 5 into 2 is 10. This you can write 5 into 10 to the power minus 2. Correct? If you want, you can write this as 5 into 10 to the power minus 2. 5 into 2 is 10. 10 into 5.2. 10 into 5.2 is 52. 52 into 10 to the power minus 2 is 0.52. So 0.52 pi. Like that you can do the calculation. Doesn't take much time. Hardly 20 seconds enough to crack this question. Move on to the next one. Question number 2. A particle moves along the curve. Equation of ellipse is given. When the rate of change of abscissa is 4 times that of its ordinate, the quadrant in which the particle lies. In which quadrant the particle lies, you have to find out. Various options are given. Once again, 2023 question. Okay. So particle moves along this curve. The curve is nothing but the equation of ellipse. So differentiate this equation with respect to time. Differentiate with respect to time. And use the condition. Rate of change of abscissa. Abscissa means x. Ordinate is y. According to the question given, dx by dt is equal to 4 times dy by dt. Correct? Rate of change of abscissa is equal to 4 times that of ordinate, dy by dt. dx by dt is 4 times dy by dt. Equation of ellipse, differentiate with respect to time. Given equation, also given the equation of ellipse. X square by 4, correct? X square by 4, I'll write it as, x square by 16, sorry. X square by 16, I'll write it as 1 by 16 into x square. I'll write in the form of constant into variable, okay? Y square by 4, I'll write 1 by 4 into y square. 1 by 4 into y square is equal to 1. Differentiate with respect to time. Differentiate with respect to time. What do you get? Constant into variable. Constant keep as it is. Derivative of x square is 2x into dx by dt. Here again, constant into variable. Constant keep as it is. Derivative of y square, 2y into dy by dt. Correct? And derivative of constant is 0. Derivative of constant is 0. So from this we can write 2 by 16 is 1 by 8. I can cancel 2 1s are 2 8s are. So you get x by 8 into dx by dt, x by 8 into dx by dt is equal to 2 ones are 2 fours are 1 by 2. I'll get shift it to right hand side, that is minus y by 2 minus y by 2 dy by dt. I'll substitute 4 times dx by dt. The next step I'll substitute. This is called star is equal to, correct, 2 ones are 2 twos are cancel, y by 2 taken to that side minus y by 2 dy by dt minus y by 2 into, what is the dy by dt here? Dy by dt can substitute dx by dt by 4, correct? Dx by dt divided by 4 I'll substitute. Dx by dt divided by 4. So that left hand side we have x by 8 into dx by dt using star, or else you can substitute for dx by dt 4 times dy by dt. Anything is possible, both one and the same. 4 into 2 is 8, 8 cancels, dx by dt cancels. What I'm getting is x equal to minus y, correct, or y is equal to minus x, or y is equal to minus x. So this is the equation of straight line passing through the origin which bisects the second and fourth quadrant. Y equal to x is straight line passing through the origin bisects the first and third quadrant. Y equal to x is like this. Y equal to x is bisects the first and third quadrant. This is y equal to x. Y is equal to x bisects the first and third quadrant. But here I am getting y equal to minus x, right? Y is equal to minus x. Y is equal to minus x like this. Straight line passing through the origin which bisects the second and fourth quadrant. Correct? Bisects the second and fourth quadrant. So the points on the curve will satisfy the equation y equal to minus x. Means all the points will lie on the line y equal to minus x. So y equal to minus x lies either in the second or in the fourth. Correct? Second or fourth quadrant. So you can write second or fourth quadrant. Option C is the answer. Points will lie on the line y equal to minus x, because using the given condition and solving the equation, I mean differentiating with respect to time and using the given condition, I got the equation like this. So the particle moves along the curve will satisfy this in order to satisfy that condition, y equal to minus x. So y equal to minus x lies either in the second quadrant or in the fourth quadrant. So particle lies is in the second quadrant or in the fourth quadrant. Hope you understand. Similar type of question is there. A particle problem is there in the NCERT book, correct? 6y is equal to x cube plus 2, correct? Given. So it was a 5-mark question earlier. Nowadays they don't ask 5-mark question for board exams from rate measure topic. Earlier they were asking a 5 marks question from rate measure topic. There is one question in the NCERT book itself, exercise 6.1. Particle moves along the curve 6y is equal to x cube plus 8 such that abscissa is increasing 8 times y coordinate, something like that, correct? So 8 times or 6 times something. Similar type of question it is based on NCERT only, correct? Move on to the next one. Sides of an equilateral triangle are increasing at the rate of 4 cm per second. Rate at which area is increasing when the side is 14 cm. And one more thing, I have slightly modified the options, okay, not taken exactly, because sometimes in papers, no, we can find the errors. So the mistakes was found in some papers. So what I done is I corrected the options and given, okay. So that is also the point to be noted. So I have made the options correctly so that we get the answer, okay. So sides, the question on equilateral triangle. Let x be the side of an equilateral triangle. What is given? The sides of the equilateral triangle are increasing at the rate of, so dx by dt is given. Dx by dt, rate of change of x with respect to time is given. 4 centimeter per second. Rate at which area is increasing, you have to find out. dA by dt. dA by dt. dA by dt you have to find out. When you have to find out when the side is 14 centimeter. Side is represented by x. When x is equal to 14 centimeter, I need to find dA by dt. So start with area of equilateral triangle. What is the area of equilateral triangle? Root 3 by 4 x square, correct? Area of an equilateral triangle is root 3 by 4 x square. Differentiate this with respect to time. What do you get? dA by dt. dA by dt is equal to root 3 by 4. Constant keep as it is. Derivative of x square is 2x into dx by dt. I am differentiating with respect to time, correct? So this will be equal to root 3 by 2. 2 ones are 2 twos are cancels. Root 3 by 2 into x is 14 and dx by dt is 4, correct? So you can cancel. 2 ones are 2 sevens are 7 into 4 is 28. 28 root 3 centimeter square per second. Option B is the answer. Okay, simple question, straightforward question. Just you must know the formula for area of equilateral triangle. Root 3 by 4 into x square. X represents the side of the equilateral triangle. Differentiate with respect to t. Constant into variable. Constant keep as it is. Derivative of x square. 2x dx by dt. Substitute the value of x and substitute the value of dx by dt. 7 into 4 is 28 into root 3. 28 root 3 centimeter per second. Move on to the next one. Question number 4. Rate of change of volume of sphere with respect to surface area when the radius is 4 centimeter. dV by ds. For a sphere, dV by ds is r by 2. I told the shortcut method. 4 by 2 over. Answer. 2 is answer. In 5 seconds, you can crack the question. Already I told this, correct? dV by ds. Rate of change of volume with respect to surface area for a sphere is r by 2. R is 4. 4 by 2, 2. R is 4. 4 by 2 is equal to 2. Already shown here, correct? Previous slide. dV by ds. Rate of change of volume with respect to sphere is r by 2. Correct? R is 4. 4 by 2, 2. 3 seconds enough. To read the question, 3 seconds. To answer 2 questions, 2 seconds. 5 seconds you can get the answer. So you have to be so quick. Then only it's possible to complete the question. If you want to do the method as explained earlier. So dV by ds. Rate of change of volume of the sphere with respect to its surface area. This could be written as dV by dr divided by ds by dr. Correct? Volume of sphere is what? 4 by 3 pi r cube. Differentiate this with respect to r. 4 by 3 pi r cube. If you differentiate, dV by dr is equal to 4 by 3 pi is constant. Derivative of r cube is 3r square. Correct? With respect to r I am doing. So 3 cancels. What I get is 4 pi r square. dV by dr is 4 pi r square. ds by dr. Surface area is 4 pi r square. Differentiate with respect to r. What we get? ds by dr is equal to 4 pi into 2r. That is 8 pi r. Correct? This is 8 pi r. 8 pi r. Pi cancels. 1 r will cancel. So 4 ones are 4 twos are. So r by 2. R is 4. 4 by 2 is equal to 2. So 2 centimeter cube per centimeter square. Option B is the answer. Move on to the next one. Rate of change of area of circle with respect to its radius at r equal to 2 centimeter. Rate of change of area of circle with respect to radius is nothing but circumference. Circumference is calculate 2 pi r. That is r is to 4 pi is answer. Over. Quickly you can answer in no time. Question asked in there 2016. If you want to do the method, area of circle is pi r square. Correct? Differentiating with respect to r. So dA by dr. dA by dr is equal to constant into variable. Constant keep as it is. Differentiate r square with respect to r. 2 pi into radius is how much? 2. Correct? You have to find dA by dr at r is equal to 2. dA by dr at r is equal to 2. So 4 pi over 4 pi centimeter square per centimeter. If you want, you can write the unit. A stone is dropped into a quiet lake and waves moves in the circle at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? This is a question found in the NCERT book itself. Answer you can remember and write directly 85 centimeters square per second. Straightforward, exactly same question is found in exercise 6.1 of NCERT book. Correct? So stone is dropped into a quiet lake. Stone is dropped into a quiet lake. What happens? The waves are moving in the form of circle at the speed of 5 centimeter per second. So waves are moving in the form of circle at the speed of 5 centimeter per second. So at the speed of 5 centimeter per second means radius of the circle is increasing. When the circle size increases, what happens? Radius is increasing. So dr by dt is given 5 centimeter per second. So when the waves are in the form of circle are expanding at the speed of 5 centimeter per second, that means radius is expanding, radius is increasing. So at the instant when the radius is 8 centimeter, you have to find how fast is the enclosed area increasing. So we have to find out dA by dt when r is equal to 8. Want to find dA by dt at the instant when radius is 8 centimeter. Area of the circle is pi r square. Differentiate this with respect to time. dA by dt is equal to constant into variable, constant keep as it is. Derivative of r square with respect to time is 2r into dr by dt. Correct? This becomes 2 pi into radius is 8. dr by dt is 5. 8 into 5 is 40. 40 into 2 is 80. 80 pi centimeter square per second over. Correct? Quite simple one. Straightforward question from the NCERT exercise 6.1. The sphere increases its volume at the rate of. So volume of the sphere is increasing. Question is on sphere here. So at the rate of pi cc. Cc is cubic centimeter per second. Second is unit of time. So dV by dt is given. dV by dt is pi cc per second. Rate of change of volume with respect to time is given. Rate at which surface area increases, you have to find out when the radius is 1 centimeter. Rate at which surface area increases, you have to find out when the radius is 1 centimeter. So the problem is on sphere. So start with volume of sphere. Want to find rate at which surface area increases. ds by dt you have to find out. But dr by dt I don't know. So to find dr by dt, I'll start from dv by dt. Start from volume of sphere. Volume of sphere is 4 by 3 pi r cube. Differentiate this with respect to time. dV by dt is equal to 4 by 3 pi is constant. Derivative of r cube is 3r square into dr by dt. Correct? dV by dt is given to us pi. Pi is equal to 4 pi. 3 cancels. Correct? R is 1 square into dr by dt. So dr by dt is 1 by 4 from this. Pi cancels. dr by dt is equal to 1 by 4 centimeter per second. Now we can start with surface area now. Surface area of the sphere is 4 pi r square. Differentiate this with respect to time. ds by dt is equal to 4 pi into derivative of r square 2r into dr by dt. Correct? So this will be equal to 8 pi r into dr by dt. dr by dt just now we got using this. Correct? Starting from volume, differentiate this with respect to time. 4 pi, 3 got cancelled, radius is 1, dr by dt we got 1 by 4, that we can substitute here. 8 into pi into radius is 1, dr by dt is 1 by 4, so we get the answer is 2 pi square centimeter per second. That's the answer. Okay, so ds by dt we got centimeter square per second. Quite simple question. Connecting the sphere. The problem is on sphere. Start with dV by dt. Using dV by dt, you have to find out dr by dt. They asked to find ds by dt, rate of change of surface area with respect to time. In order to find ds by dt, dr by dt is required. Correct? So that's why I am finding dr by dt using dV by dt. Find out dr by dt using dV by dt. Okay? So then find ds by dt. We'll get the answer. Question asked in the year 2011. Move on to the next one. A spherical balloon is being inflated at the rate of 35 cc per second. If you can't make out what is given, look at the units so that you can make out. Cc is cubic centimeter. Cubic centimeter is unit of volume. Minute is the unit of time. So what is given is dV by dt. So dV by dt is given. Spherical balloon. So problem is on sphere only again. So dV by dt is 35 cc per minute. Rate at which volume increases with respect to time is given. Rate of increase of surface area to find out. ds by dt to find out. Rate of increase of the surface area is equal to how much? When the diameter is 14 centimeter. When the diameter is 14 centimeter. Diameter is 14 means radius is equal to 7. Diameter is 2r. 2r is equal to 14. So r equal to 7. Correct? You have to find out ds by dt. Once again, to find ds by dt, dr by dt is required. dr by dt is not given. dv by dt is given. No. So using dv by dt, you find out dr by dt. Using dr by dt, you can find ds by dt. Okay. So start with volume of sphere, spherical balloon. So the problem is based on the sphere. So volume of sphere you can start. Volume of sphere is 4 by 3 pi r cube. Differentiate this with respect to time. dV by dt is equal to 4 by 3 pi is constant. Constant into variable means constant you keep as it is, differentiate the variable. Derivative of r cube is 3r square into dr by dt. Correct? 3 cancels. dv by dt is given to us 35. You can substitute. dv by dt is 35. Correct? 3 cancels. 4 pi into radius is 7. Substitute 7 square into dr by dt. So dr by dt I am getting from this. Correct? dr by dt is equal to 35 divided by 7 square is 49. 49 into 4 is 196. Don't need to multiply. Keep as it is. We'll cancel it later. 7 square into 4 pi. Keep as it is. Okay. dr by dt. Now go for finding ds by dt. Start with surface area. Surface area is 4 pi r square. Surface area is 4 pi r square. Differentiate with respect to time. ds by dt is equal to 4 pi into derivative of r square is 2r into dr by dt. It's equal to 8 pi r dr by dt. Substitute the values of r and dr by dt here. 8 pi into radius we got, radius was given to be equal to 7 because diameter was given. Initially diameter was given. Diameter is 14 means radius is 7. Radius is half of the diameter. Correct? dr by dt we got it as 35 divided by 7 square is 7 into 7 into 4 pi. Correct? So from this pi cancels. 1 7 will cancel. 7 1s are 7 5s are. Correct? 4 1s are 4 2s are. 5 into 2 10 is the answer. 10 square centimeter per minute. Correct? No? The calculation part. If you want to do it again. If many things are cancelled, we can't make out what is cancelled and what is left out. Correct? So 8 pi, radius is 7, dr by dt is 35 divided by 7 square is 7 into 4 pi. Correct? 7 got cancelled. Pi will cancel. Pi cancels. I can use different ink here if you want. Pi is cancelling. Correct? 7 is cancelling. 4 1s are, 4 2s are. 7 1s are, 7 5s are. 5 into 2 is 10. Correct? So 10 square centimeter per minute. 10 centimeter square per minute. Answer is option D. On to the next one. Question number 9. Rate of change of surface area of a sphere of radius r when the radius is increasing at the rate of 2 centimeter per second is proportional to what? So radius is increasing at the rate of dr by dt is given. dr by dt is given to be equal to 2 centimeter per second. Correct? Radius is increasing at the rate of 2 centimeter per second. Rate of change of surface area to find out. Rate of change of surface area is proportional to what? Is proportional to what? Correct? Start with surface area of the sphere. Question is on sphere. So surface area of the sphere is 4 pi r square. Differentiate this with respect to time. ds by dt is equal to 4 pi into derivative of r square. They asked to find rate of change of surface area of the sphere when the radius is correct increasing at the rate of 2. dr by dt is given. Yes, you can differentiate with respect to time. Constant keep as it is. Differentiate r square with respect to t. So 2r into dr by dt. Correct? dr by dt is given. dr by dt is given. Right? Radius is increasing at the rate of. So dr by dt is given. So 4 into 2 becomes 8 pi r into dr by dt. dr by dt is given to us as 2 centimeter. Correct? 8 pi r into 2, which becomes equal to 16 pi r. That means it is proportional to radius. Correct? ds by dt. From this I can conclude that ds by dt is proportional to radius. Option D is the answer. Option D. Rate of change of surface area with respect to time is nothing but radius. Just differentiate with respect to time and get the answer. Constant into variable. Constant keep as it is. Derivative of r square 2r dr by dt becomes 8 pi r dr by dt. Dr by dt is given as 2. So 16 pi r I'm getting. So I can conclude that rate of change of surface area with respect to time is proportional to radius. Move on to the next one. Question number 10. Volume of the ball is increasing at the rate of 4 pi cc per second. Cc is cubic centimeter. Cubic centimeter is unit of volume. Second is unit of time. So volume of a ball is increasing. Ball is spherical in shape, you know. So ball is spherical in shape. So problem is on sphere. Balloon is spherical in shape. Air bubble is spherical in shape. Ball is spherical in shape. Correct. dv by dt is given 4 pi cc per second. Find the rate of increase of radius. Dr by dt you have to find out. Dr by dt you have to find out when the volume of the sphere is, when the volume of the ball is spherical, you know, 288 pi. Volume is given 288 pi. So dr by dt you have to find out using dv by dt for a ball. So ball is spherical in shape. So I'm using the formula for sphere. V equal to 4 by 3 into pi r cube. So, but radius is not given. Indirectly the given radius in terms of volume. Volume is given to be equal to 288 pi. From this I can find out the radius. Volume of sphere, what is the formula? 4 by 3 pi r cube. From this we can find out what is radius. 4 by 3 pi r cube is equal to 288 pi. Correct? Pi cancels. Correct? So 4 ones are 4, 72s are. Cross multiply, get r cube is equal to 72 into 3 is 216. 216 is 6 cube. Correct? So taking cube roots, I get r equal to 6. Radius equal to 6. So using radius and dv by dt, I can find out dr by dt. Question is on sphere. So start with volume of sphere. Volume of sphere is 4 by 3 pi r cube. Differentiate this with respect to time. Differentiate with respect to time. What we get? dv by dt is equal to constant into variable. Constant keep as it is. Derivative of r cube is 3r square into dr by dt. 3 cancels. So what we get is 4 pi into radius is 6 square into dr by dt. Dr by dt I have to find out. dv by dt is given 4 pi. Correct? dv by dt was given into dr by dt. Dr by dt I am finding out. 4 pi cancels. So I get 1 is equal to, cancels means it becomes 1 there. Correct? Don't write 0 there. So 36. 6 square is 36. So that dr by dt is 1 by 36. dr by dt is 1 by 36. dr by dt is 1 by 36 centimeter per second. Option B is answer. Question asked in the year 1993. Correct? From the volume, you can find the radius. So radius, you know, dv by dt, you know, you can find dr by dt. Just consider the equation of volume of, write the formula for volume of sphere, differentiate this, constant into variable, constant keep as it is, derivative of r cube with respect to t, 3r square into dr by dt, follows by chain rule, 3 cancels, you get 4 pi, r you substitute 6, dv by dt is given as 4 pi cancels, 1 by 36 is dr by dt. Move on to the next one. Question number 11. Area of an expanding circular region. So problem is on circle. Increases at a constant rate. So area of the circle is increasing at a constant rate. So dA by dt is given. dA by dt is equal to area of expanding circle. Circle is area of the circle is increasing at a constant rate. So dA by dt equal to k. I'll take k as a constant. Okay. Rate of increase of the perimeter with respect to time varies as what you have to find out. So perimeter is nothing but circumference for a circle, correct? So you have to find out dc by dt varies as what? dc by dt is proportional to what you have to find out. So dA by dt is constant. Rate of change of area of circle is constant. It is increasing at a constant rate. Area of the circle is increasing at a constant rate, means dA by dt is constant. So start from area of the circle. Area of the circle is pi r square. Differentiate with respect to t. dA by dt. Constant into variable. Constant keep as it is. Derivative of r square is 2r into dr by dt. Differentiate this with respect to time. dA by dt is k. Constant. Correct? Is equal to 2 pi r into dr by dt. From this I can write an expression for dr by dt. dr by dt is equal to how much? dr by dt is equal to k divided by 2 pi r. Now using this I can find at what rate the circumference is increasing, or at what circumference increasing is proportional to what? Circumference for a circle is 2 pi r, correct? Circumference of the circle is 2 pi r. Differentiate with respect to time, dc by dt. Constant into variable, constant keep as it is. Differentiate r with respect to t, dr by dt. So this is equal to 2 pi into dr by dt is k divided by 2 pi r. 2 pi cancels, we get k by r. That means I can conclude that dc by dt is proportional to 1 by r, correct? Therefore I can write the conclusion that rate of change of circumference with respect to time is proportional to 1 by r. Means inversely varies as radius. Varies inversely as a radius. Proportional to 1 by r means varies inversely as a radius, correct? Proportional to 1 by r, correct? So dA by dt is constant according to the question. From there you find out dr by dt. Constant keep as it is. Derivative of r square 2r into dr by dt. So dr by dt is k by 2 pi r, correct? That is substitute in dc by dt. Constant into variable. Constant keep as it is. Differentiate r with respect to t, dr by dt. 2 pi into k by 2 pi r. 2 pi cancels, k by r. That means proportional to 1 by r. Varies inversely as a radius. That's the answer. Option D is the answer. Same type of question is there in NCERT exemplar book. Okay, that is for a cube. This is for a circle. There it is for a cube. Next we have questions on concept of velocity and acceleration. So if a displacement equation is given, no, s of t, s is a function of t, displacement as a function of time is given to you. The first derivative will give the velocity and the second derivative gives acceleration. You must know this. So many times questions are asked on velocity and acceleration too in the earlier CET exams. Okay, before the year 2000, many questions you can find of velocity and acceleration, commonly asked question on rate measure. And that is what I given here. S of t represents the displacement as a function of time t. ds by dt means the first derivative. If you differentiate for the first time, what I am going to get is velocity. Double differentiate, what we get? Acceleration. If you double differentiate the displacement equation, what you get is acceleration. So first derivative gives velocity and the second derivative gives acceleration. And these are the important things to be noted. When a body is thrown up vertically, at the topmost point, what happens? Velocity is 0. And time of ascent equal time of descent. Time taken to go up is same as time taken to come down. That's the important thing. Okay. So time of ascent equal to time of descent. When the moving body stops, velocity is 0. Correct? When the body is moving, when it stops, no, at that point velocity becomes equal to 0. All those things you must know. Very basic knowledge. Those who know physics, they can know better. Correct? So take the questions based on this. Question asked in the year 2023 recently. The distance s in meters traveled by a particle in t seconds is given by this. You have to find the acceleration when the particle comes to rest. So you have to find the acceleration when the particle comes to rest. Particle comes to rest means velocity is 0. So you have to find the acceleration when the velocity is 0. Correct? So differentiate this. S is a function of time. Displacement as a function of time is given. S is given as 2 by 3 into t cube minus 18t plus 5 by 3. Differentiate this. Differentiate with respect to time. ds by dt is equal to constant into variable. Constant keep as it is. Derivative of t cube is 3t square. Constant into variable. Constant keep as derivative of t is 1. Derivative of 5 by 3 is 0. So what you get is 2t square minus 18. This is velocity. You have to find the acceleration when the particle comes to rest. So particle comes to rest means velocity is 0. That means t square is equal to 9, correct? 2t square equal to 18, t square equal to 9 implies t is equal to 3, as t can't be negative, correct? Because t equal to minus 3 is not possible. T is not equal to minus 3. T is plus or minus 3, time can't be negative. Double differentiate this, we'll get acceleration. We got ds by dt is equal to 2t square minus 18, no? 2t square minus 18. Differentiate this again. Double differentiate, that is d square s by dt square, second order derivative. Derivative of 2t square is 4t. Derivative of 18 is 0. Correct? Want to find the acceleration when the velocity becomes 0. When the particle comes to rest. Particle comes to rest when time t equal to 3. At this instant you have to find out the acceleration. So d square s by dt square at the instant when time t equal to 3. 4 into 3, 12. 12 centimeter square or meter square they given. Meter square per second. 12 meter square per second. So option D is the answer. Finding the acceleration when the velocity becomes 0. They ask to find acceleration when the particle comes to rest. Particle comes to rest means velocity is 0. Velocity is 0 when t equal to 3. So when t equal to 3, find out the acceleration. Derivative of 2t square is 4t. Here constant into variable. Constant keep as it is. Derivative of t cube is 3t square. 3 cancels. We get 2t square. 2t square minus 18. Differentiate this again 4t. Derivative of constant is 0. 4 into 3. Substitute t equal to 3. Get the answer. Move on to the next one. Question number 2. A stone is thrown vertically upwards from the top of a tower 64 meters high. According to this law given by S equal to 48t minus 16t square. The greatest height attained by the stone above the ground level. So stone is thrown vertically upwards from a top of a tower. So this is a tower. Tower is already 64 meters high. 64 meters high. Tower is there. Okay. So stone is thrown vertically upwards from the top of a tower. This is the top of a tower. 64 meters high. This is the ground level. (64 meters high). According to this law, S is equal to 48t minus S is given as 48t minus 16t square. Want to find the greatest height attained by the stone above the ground. Stone is thrown here. Boy is standing here. Stone is thrown vertically upwards from the top of a tower. Stone is thrown vertically upwards. Stone reaches the topmost point here. When it reaches the topmost point, at that point velocity becomes 0. Stone is thrown up according to this equation. S is equal to 48t minus 16t square. Differentiate this. ds by dt is equal to constant into variable. Constant keep as it is. Derivative of t is 1. Derivative of 16t square is 32t. Correct? 16 into 2t, 32t. Equal to 0. Velocity should become 0 at the topmost point. So 32t or 48 is equal to 32t I am getting. Correct? So from this t is equal to how much? 16 2s are 16 3s are 3 by 2. 3 by 2 is 1.5. Time taken is 1.5 seconds to reach the topmost point. From this point the stone is thrown up. So it takes how much time to reach the topmost point? 1.5 seconds. So from here to here I can find out the distance traveled. Distance traveled during from this point to this point. How much time it takes to reach the topmost point from the top of a tower? From the top of a tower the stone is thrown up. It reaches the topmost point in 1.5 seconds. Because at the topmost point what happens here? Velocity is equal to 0. At the topmost point velocity is equal to 0. Correct? So time taken to reach the topmost point is 1.5 seconds. This 1.5 seconds you can substitute here. So distance traveled is 48 into t is 1.5 which is 3 by 2. I can write 3 by 2 itself, that's better for me. 16 into 3 by 2 square. 2 ones are 2 24s are. Correct? 24 into 3 is 72. 2 ones are 2 24s are. 24 into 3 is 72. 2 square is 4. And this becomes 16 into 9 by 4. Correct? 4 ones are 4 4s are. 4 into 9 is 36. What you get is 72 minus 36 is equal to 36. So distance traveled from the top of the tower to the topmost point where the stone reaches. This much is 36 I got. This much is 36. 36 meters. Correct? So they asked to find the greatest height attained by the stone above the ground. Not this height they are asking. From the ground level, what is the greatest height attained? Greatest height attained by the stone from the top of the tower is 36. We need to add this also, correct? So greatest height attained by the stone above the ground is 64 plus 36. Required is 64 plus 36. Hope you understand. Above the ground level, what is the greatest height attained by the stone? You have to find out, which is 100 meter, not 36 meter, not 64 meter, 100 meter. Hope you understand. Question asked in the year 2009. What the next one? This question appeared 2 times, exactly same question, once in 1991 and in the year 2008. So a stone is thrown vertically upwards, and the height x feet reached by the stone in t seconds is given by this. So height is given as a function of time. Stone reaches the maximum height in how many seconds? So differentiate. At the topmost point, what happens? Velocity is 0. So when you differentiate this, you get velocity, correct? So x is given as 80t minus 16t square. Same equation is given in the previous question also. No, see 80t minus 16t square. No, 4080 that was 4080. Now it is 80t. So differentiate this. It's not the same equation. Differentiate with respect to time. Constant into variable. Constant keep as is. Here constant into variable. Differentiate the variable. Constant into variable. Constant keep as is. Derivative of t is 1. Constant into variable. Constant keep as is. Derivative of t square is 2t. So what I am going to get here is 80 minus 32t. This is equal to 0. At the topmost point, when the stone reaches the topmost point, at that point velocity equal to 0. When the stone reaches the topmost point, stone reaches the topmost point, what happens? Velocity equal to 0. First derivative gives velocity, we know, correct? This is first derivative, that's velocity. So equate this to 0. That is 80 minus 32t equal to 0. 80 is equal to 32t. 80 is equal to 32t. So 8t is equal to how much? 80 divided by 32. Correct? We can cancel with 8 table. Correct? Or 16 table directly. 16 2s are 16 5s are 5 by 2. 5 by 2 is 2.5. 2.5 seconds. 2.5 seconds. Option B is the answer. 16 2s are 16 5s are 5 by 2. 5 by 2 is 2.5. Simple question. You must know that when the stone is thrown vertically upwards, when it reaches the topmost point, at that point velocity is equal to 0. They ask to find the time taken. The stone reaches the maximum height in how many seconds? So stone will reach the maximum height in 2.5 seconds. Because when it reaches the maximum height, at that point velocity equal to 0. Topmost point means the maximum height. Maximum height is the topmost point. When it reaches the maximum height, at that point velocity equal to 0. So I am using velocity equal to 0. First derivative gives velocity. Velocity equal to 0, at that velocity equal to 0 implies t equal to, I am getting 2.5. So time taken is 2.5 seconds. That's the answer. Move on to the next one. If a ball is thrown vertically upwards and the height s reached in time t is given by this. S is equal to 22t minus 11t square. 22t minus 11t square. The total distance travelled by the ball is how much? Question asked in the year KCET 2012. So displacement as a height as a function of time is given. Height is s, reached in time t is given by this. So total distance, ball is thrown vertically upwards. So when the ball reaches the topmost point, velocity equal to 0. Ball reaches the topmost point and again it has to come down, correct? Time taken to go up is same as time taken to come down. Or else I can tell distance travelled in the upward direction is same as distance travelled in the downward direction. So first to differentiate this, we'll get velocity. ds by dt. ds by dt is equal to constant into variable. Constant keep as it is. Derivative of t is 1. Constant keep as it is. Derivative of t with respect to t is 1. Here constant keep as it is. Derivative of t square is 2t. Correct? So when the ball reaches the topmost point, velocity equal to 0. Correct? Velocity equal to 0 for the topmost point. So 22 minus 22t equal to 0, which gives t equal to 1. Correct? T is equal to 1. So time taken to go up is 1 second. So during that time, we'll find out the distance in the upward direction. When time t equal to 1, when time t is equal to 1, what we get? S is equal to 22 into 1, substitute t equal to 1 here, minus 11 into 1 square. 22 minus 11 is equal to 11. Correct? Distance traveled in the upward direction is 11. The ball reaches the topmost point in 1 second. Because at the topmost point, velocity is 0. Time taken to go up is 1 second. Distance traveled in the upward direction is 11 meters or 11 units. They ask to find the total distance traveled by the ball. Ball goes up, again it comes down, right? So total distance traveled is 11 plus 11. Upward distance is 11, downward distance is 11. 11 plus 11 becomes 22. Therefore, total distance traveled is total distance traveled. Total distance traveled is equal to how much? 11 plus 11 is equal to 22. Upward plus downward. 22 units is the answer. Move on to the next one. Distance s feet traveled by the particle in time t seconds is given. Its acceleration vanishes at time t equal to how much? Vanishes means becomes 0. Acceleration is becoming 0 at what time they are asking. So double differentiate this. S is given to be equal to t cube minus 6t square minus 4t minus 8. Differentiate. ds by dt is equal to 3t square minus 12t minus 4. Correct? Differentiating with respect to time. Again, double differentiate. They ask to find its acceleration vanishes at time t equal to how much? First derivative gives velocity. Second derivative gives the acceleration. This is acceleration. 3 into 2t becomes 6t. Derivative of 12t is 12. This is acceleration. Second derivative is acceleration. Acceleration vanishes. Vanishes means becomes 0. Correct? So 60 minus 12 equal to 0. 60 is equal to 12. 60 is equal to 12 means t is equal to 2. So time taken is 2 seconds. Time taken is 2 seconds. Acceleration is going to vanish at time t equal to 2. This differentiate 3t square, 6 into 2t, 12t, derivative of 4t is 4. Double differentiate 3 into 2t, 60, 12 into 1, 12, derivative of 4, 0. 60 minus 12 equal to 0. 60 equal to 12, t equal to 2. Option A is the answer. Move on to the next one. The distance s meters traversed by a particle in t seconds is given by this. Find the velocity of the particle when the acceleration is 0. This is commonly asked question. This type many questions are there. 3 or 4 questions are there of this type. Finding the velocity of the particle when the acceleration is 0. S is given to be equal to t cube minus 3t square. Differentiate this. ds by dt. ds by dt is equal to derivative of t cube is 3t square. Derivative of 3t square, 3 into 2t, 6t. I have to find the velocity when acceleration is 0. Double differentiate to get the acceleration. Double differentiate this. d square s by dt square is equal to derivative of 3t square is 6t. Derivative of 6t is 6. Acceleration equal to 0. 6t equal to 6. That is t equal to 1. So time taken is 1 for acceleration to become 0. Correct? Derivative of t cube is 3t square. Derivative of 3t square is 60. Double differentiate. Derivative of 3t square is 60. Derivative of 60 is 6. Correct? 3t square derivative is 60. Correct? No, derivative of 60 is 0. T equal to 1. So when t equal to 1, you have to find the velocity. They ask to find velocity of the particle when the acceleration is 0. Acceleration is 0 when t equal to 1. So at this instant, you have to find the velocity. ds by dt when time t is equal to 1. When the time t is equal to 1, you have to find out the velocity. So we get 3 into 1 square minus 6 into 1. Correct? That's equal to 3 minus 6, which is equal to minus 3. Minus 3 meters per second. Option C is the answer. Hope it's clear. Move on to the next one. Speed v of a particle moving along a straight line is given by this, where x is its distance from the origin. Find the acceleration of the particle. Question asked in the year 1996. So the equation given to us is a plus b into v square is equal to x square. speed v is a speed, x is a distance. So differentiate with respect to time. Differentiating with respect to time, differentiate with respect to time. What do we get? A and B are constants here. Derivative of constant is 0. Derivative of A is 0. Here constant into variable. Constant keep as it is. Differentiate v square with respect to t. Derivative of v square. V is a speed. Nothing but velocity. Consider here. Derivative of v square is 2v into dv by dt. By chain rule it follows. Correct? Derivative of v square is 2v into further differentiate v with respect to t. Derivative of x square 2x into dx by dt. By chain rule it follows. Dx by dt is nothing but velocity, correct? So what I am going to get here is 2bv into dv by dt, that is acceleration, correct? Acceleration is nothing but dv by dt. I'll keep dv by dt as it is. That is what I need to find. 2x into dx by dt, rate of change of distance with respect to time, that is velocity here or speed. So 2v is going to cancel, 2 cancels, v cancels. What I am getting is b into dv by dt is equal to x, correct? Dx by dt is velocity or dx by dt is speed according to the question. V is a speed, v cancels, 2 cancels. What is that? Is b into dv by dt is equal to x. From this, dv by dt is the acceleration. No, acceleration is x by v. From this, acceleration is x by v, which is option B, correct? Constant into variable. Constant you keep as it is. Derivative of v square 2v into dv by dt. Derivative of x square 2x into dx by dt. So what is that? 2bv dv by dt is equal to 2xv. 2 cancels, v cancels, dx by dt is v, correct? So 2v has been cancelled. b into dv by dt is equal to x. So dv by dt is x by v. Option B is the answer. Move on to the next one. The distance s moved by a particle in time t is given as this. To find the velocity of the particle when its acceleration becomes 0. Commonly asked question many times in the earlier CET papers. These were the common question from rate measure. Finding the velocity of the particle when the acceleration is 0. 3 or 4 times repeated same type of question with different equations. Okay. So s is equal to t cube minus 6t square minus 15t plus 12. This is given to us. Differentiate this with respect to time. ds by dt. Differentiate 3t square minus 6 into 2t, 12t minus 15. Double differentiate. d square s by dt square. Derivative of 3t square, 3 into 2t, 6t. Derivative of 12t, 12 into 1, 12. Acceleration becomes 0. Acceleration equal to 0. That gives t is equal to 2. So when t is equal to 2, find out velocity. ds by dt, you have to find out when t is equal to 2. Substitute t is equal to 2 and get the answer. 3 into 2 square minus 12 into 2 minus 15. 2 square is 4. 4 into 3 is 12. 12 into 2, 24. Minus 15. Correct? 12 minus 24 is minus 12. Minus 12 minus 15 minus 27. Option B is the answer. Acceleration becomes 0 when t is equal to 2. At that instant, you have to find out the velocity. They asked to find the velocity of the particle when the acceleration is 0. Derivative of t cube is 3t square. Derivative of 6t square, 6 into 2t, 12t. Derivative of 15t is 15. Double differentiate, 3 into derivative of t square, 2t, 6t. Derivative of 12t is 12. Acceleration equal to 0 gives t equal to, substitute t equal to 2. Get the answer. 2 square 4, 4 into 3, 12. 12 2 is a 24. 12 minus 24, minus 12, minus 12, minus 15, minus 27. Option B. Move on to the next one. Distance moved by the particle in time t is given. Find the velocity of the particle when the acceleration becomes 0. S is equal to t cube minus 3t square plus 3t minus 5. To find the velocity when acceleration becomes 0. Differentiate this. ds by dt is equal to derivative of t cube 3t square. Derivative of 3t square 6t. Derivative of 3, 0. The derivative of 3t, 3. Derivative of 5, 0. Double differentiate. D square s by dt square is equal to 6t minus 6 equal to 0. That gives t equal to 1. So time taken is 1 second for acceleration to become 0. Acceleration becomes 0 when t equal to 1. When t equal to 1, you have to find the velocity. Correct? Differentiate this equation. T cube derivative is 3t square. Derivative of 3t square 60. Derivative of 3t 3. Derivative of 5 0. Correct? So to find the velocity of the particle when acceleration becomes 0. Acceleration becomes 0 when t is equal to 1. At the instant when t is equal to 1, you have to find the velocity. Substitute t equal to 1 here. 3 into 1 square minus 6 into 1 plus 3. Correct? 3 into 1 square, 3. 3 plus 3, 6. 6 minus 6 equal to 0. Answer is option C. Hope it's clear. Just differentiate 3t square minus 6t plus 3. Double differentiate 6t minus 6 equal to 0. T equal to 1. T equal to 1 substitute. Finding the velocity of the particle when the acceleration is 0. Answer is 0. Velocity is 0 when t equal to 1. Move on to the next one. The distance moved by the particle in time t is given this. Find the velocity when the acceleration is 0. Many times, same type of question repeated. Still, for the sake of completeness, I'll do all the questions. 2 plus 3t minus t square plus t cube. Differentiate this. ds by dt. ds by dt. Derivative of 2 0. Derivative of 3t is 3. Derivative of t square 2t. Derivative of t cube 3t square. Just go on differentiate. To find velocity when acceleration is 0. Double differentiate. D square s by dt square. Derivative of 3 is 0. Derivative of 2t is 2. Derivative of 3t square is 6t. Equal to 0. That gives 6t is equal to 2. 6t is equal to means t is equal to 2 by 6, which is 1 by 3. To find the velocity when acceleration is 0. So finding the velocity ds by dt you have to find out when acceleration is 0. Acceleration becomes 0 when t equal to 1 by 3. When t equal to 1 by 3, you have to find out the velocity. So find out 3 minus 2t. 2t is 1 by 3. No, substitute and write. Substitute and write. T equal to 1 by 3. T is 1 by 3. Correct? Plus 3 into t is 1 by 3. 1 by 3 square. This is equal to 3 minus 2 by 3. Here 1 3 cancels, 1 3 remains. Correct? 3 into 1 by 3 square, 1 by 3. So 3 minus 2 by 3 plus 1 by 3 is minus 1 by 3. Take common denominator 3. 3 into 3. Correct? 3 is 3 by 1. 3 3s are 9 minus 1 8. 8 by 3. You can write this as mixed fraction. 3 2s are 6. 6 plus 2 8. 2 2 by 3. Answer is option A. Writing the fraction in terms of the mixed fraction. Writing improper fraction as a mixed fraction. 3 2s are 6. 6 plus 2 8. 8 by 3 is 2 2 by 3. Option A. Move on to the next one. The distance moved by the particle in time t is given with this. At the instant when acceleration is 0, find the velocity. Commonly asked question 4 or 5 times, same type of question repeated. S is given as t cube minus 12t square plus 6t plus 8. Differentiate this. ds by dt is equal to derivative of t cube 3t square. Derivative of 12t square 12 into 2t 24t. Derivative of 6t is 6. Derivative of 8 0. Double differentiate. You want acceleration to be 0. D square s by dt square is equal to derivative of 3t square 6t. Derivative of 24t 24. Derivative of 6 0. Acceleration equal to 0. T is equal to 4 again. 6t is equal to 24. This gives t is equal to 4 seconds. So time taken is 4 seconds for acceleration to be 0. When acceleration is 0, you have to find the velocity. At the instant when acceleration is 0, velocity is how much? So find out velocity when acceleration is 0. Want to find velocity. The first derivative is velocity. Find out ds by dt when t is equal to 4. T is equal to 4 is substitute. 3 into 4 square minus 24 into 4 plus 6. Correct? Put t equal to 4 in this and find out the velocity. 4 square 16. 16 into 3 is 48. 24 into 4 is 96 plus 6. Correct? 48 plus 6, 54. 54 minus 96 minus 42. Minus 42 is the answer. Move on to the next one. The distance S in centimeters traveled by a body falling freely in vacuum near the surface of Earth in time t seconds is given by this. S is equal to gt square by 2. That is half gt square, right? Half gt square. G is given 980 centimeters per second square. Velocity v of the body at time t is how much? Differentiate this with respect to time. ds by dt is equal to constant into variable. Constant keep as it is. Differentiate t square with respect to t. 2t, 2 cancels. I am getting gt. gt is answer. Quite simple one. Question asked in there 1984, the first time when CET was introduced. Next we have question on angular velocity and angular acceleration. As I told earlier, the rate of change of angular displacement is angular velocity and the rate of change of angular velocity is angular acceleration. If you differentiate the angular displacement, we get angular velocity. If you differentiate the angular velocity, we get angular acceleration. So rate of change of angular displacement is angular velocity and the rate of change of angular velocity is angular acceleration. Okay, two important points given here on angular velocity and angular acceleration. Question is asked, one such question asked in the year 2021 recently. A particle moves from rest and its angular displacement in radians is given by this. Angular displacement is given. Theta is equal to, given to be equal to t square by 20 means 1 by 20 into t square. I'll write in the form of constant into variable. Constant keep as it is, correct, into variable. When differentiating it becomes easy. So I'm writing in the form of constant into variable. T by 5 could be written as 1 by 5 into t. 1 by 5 into t. Differentiate this with respect to time. Angular displacement is given. Theta represents angular displacement. So if you differentiate this angular displacement, what we get is angular velocity. So differentiate this with respect to time. Angular displacement is given. You differentiate the angular displacement with respect to time. What we get is angular velocity. So angular velocity is d theta by dt. Correct? Constant into variable. Constant keep as this. Derivative of t square is 2t. Constant into variable. Constant keep as this. Derivative of t with respect to t is 1. Constant into variable. Constant right as this. Derivative of t square is 2t. Constant into variable. Constant keep as this. Differentiate t with respect to t1. You want to find the angular velocity at the end of t equal to 4 seconds. That is given to be equal to k. Want to find 5k. So d theta by dt, you have to find out angular velocity, you have to find out at the end of t is equal to 4. At the end of t is equal to 4. That is equal to how much? 2 ones are 2 tens are cancels. 2 ones are 2 tens are. So 1 by 10 into t is how much? 4 plus 1 by 5. 4 by 10 is 2 by 5. 2 by 5 plus 1 by 5. This is 3 by 5. 3 by 5 is k according to the question. Angular velocity at the end of t equal to 4 is k. This is k according to the question. So from this I want to find 5k. So cross multiply. 5k is 3. They has to find 5k on cross multiplication. 5k is equal to 3. 5k is equal to 3. 3 is the answer. Read the question properly. Angular velocity at the end of t equal to 4, that is k. So angular velocity at the end of t equal to 4, we got 3 by 5, that is k. Want to find 5k. 5k is equal to 3. Correct? Option D is the answer. Next we got marginal revenue and marginal cost, as I told earlier, but no questions are asked based on this in CET exams. Just given the concept. Marginal revenue is rate of change of total revenue. Total revenue equation is given. Just differentiate. What we get is marginal revenue. And if marginal cost you want, differentiate the total cost. Total cost is given. Differentiate, we get marginal cost. marginal revenue and marginal cost. Okay. Next we move on to increasing and decreasing function. Definition is given. A function is said to be increasing, means what? X value increases, function value increases. We tell strictly increasing function. x1 less than x2, f of x1 less than x2, then f of x1 less than f of x2, the function is said to be strictly increasing. x1 less than x2, x1 less than x2 implies f of x1 is less than f of x2. Strict inequality is there, then the function is strictly increasing. F is strictly increasing. As you increase the value of x, even the function value is going to increase strictly. Strict inequality is given. Okay, in that case, if this condition is satisfied, the function is said to be strictly increasing. If x1 less than x2, x1 less than x2, f of x1 is greater than f of x2, then the function is said to be strictly decreasing. F is strictly decreasing. X value increases, but the function value is going to decrease. Increasing arrow mark up, decreasing arrow mark down. Strictly decreasing, strictly increasing. X value increases, but function value decreases. Here x value increases, function value also increases. Something like directly proportional in physics. Here inversely proportional in physics, correct? Can be compared comparatively, correct? And also we have if x1 less than x2, if we have f of x1 less than or equal to f of x2, correct? Slack inequality is used. Here strict inequality, here slack inequality, less than or equal. Then we tell the function is increasing. Function is increasing, not strictly increasing, increasing. Because at some points derivative, at some points the function value may remain same. Even though x value increases, at some points even the function value might remain the same. So this is increasing, strictly increasing and increasing function. X value increases, function value might increase or remain the same. So f of x1 less than or equal to f of x2. Same way we got x1 less than x2, x1 less than x2, f of x1 greater than or equal to f of x2. Then function is decreasing. Again we use the slack inequality, not strictly decreasing, only decreasing. X value increases but function value decreases or it may remain same. Okay, so function is decreasing. So strictly decreasing, decreasing. Here strict inequality, here we use slack inequality. Here it's increasing and strictly increasing. And if x1 less than x2, if f of x is a constant, then it is a constant function. That is also given. So definition of increasing and decreasing function given, and also given the graphs of these functions, strictly increasing and increasing function, decreasing and strictly decreasing function, and constant function. This is a constant function, sorry. This is constant function, not neither increasing nor decreasing. This is a constant function, okay? Constant function. This is constant function. This is graph of strictly increasing function, correct? As we move right side, the function is going to increase, strictly increasing. This is strictly decreasing. As we move right side of x-axis, the function value decreases. The height is decreasing, no? Here the height is increasing, see? Height is increasing. Height means the function value. Here the height is decreasing. Height is decreasing. Height becomes small, correct? Here the function is increasing, not strictly increasing. Here it increases, remains constant, again increases. So it's not strictly increasing function. See here the function is constant here in this interval, correct? So the line is parallel to x-axis, means it's a constant function. Increases, remains constant, again increases. Here the function is constant here, decreases, again constant, again decreases. So decreasing function. So in the graphs of increasing and decreasing function, the function might remain constant also. Increases, remains constant, again increases. Here it's constant, decreases, again constant, decreases. So decreasing function. This is strictly decreasing. So the height is becoming less and less. Here the height is becoming more and more. As you move right side of x-axis, the height is increasing. So strictly increasing. Here the height is decreasing. Here the height is constant. Therefore it is a constant function. Okay, constant function. This is neither increasing nor decreasing in sine function. We can draw the sine function graph. I can draw like this. Sine function graph like this. This is neither increasing nor decreasing. In the interval 0 to pi, what happens? 0 to pi by 2 increases. 0 to pi by 2 increases. pi by to pi decreases. So in the interval 0 to pi it is neither increasing nor decreasing. Even in the interval pi to 2 pi to 3 pi by 2 the function is decreasing. Pi to 3 pi by 2 the function is decreasing. 3 pi by 2 pi the function is increasing. So this is neither increasing nor decreasing, this graph. Neither increasing nor decreasing. Neither increasing nor decreasing. Correct? This function. Graph of sine function. In the interval 0 to 2 pi. Or in the interval 0 to pi also I can tell. It's neither increasing nor decreasing. This is a constant function. So graphs of increasing, decreasing, strictly decreasing, constant and neither increasing nor decreasing functions are shown here to make you understand. Increasing and decreasing function in terms of derivatives. A function is said to be increasing in the interval if derivative is positive. I made it very simple. I don't want to make it very complicated. Closed interval, open interval, strict inequality, slack inequality, all those things not required at all. Simply I am making very simple. Function is increasing means derivative is positive. Function is decreasing means derivative is negative in that interval. Okay. So there is one important difference between strictly increasing and increasing function and strictly decreasing and decreasing function. That I'll tell you. Okay. And also changed a bit of options also, because many times questions are very much leading to controversy. Multiple correct answers also found in the CET exam paper. So I made some manipulation, made some adjustment, made some corrections in the options. Okay. So that you get only one answer as right. So that is also there. So increasing function means derivative is positive in terms of derivatives, and decreasing function means derivative is negative. So if it is greater than, I'm not distinguishing much about increasing and strictly increasing, decreasing and strictly decreasing, all those things. I'll explain to you when it comes there. Okay. For time being, just understand that strictly increasing means derivative is positive only. Increasing means also derivative is positive. It can be greater than or equal to 0 also, no problem. So I'll explain the difference between the strictly increasing and increasing function and strictly decreasing and decreasing function when it comes to the problem. Okay. So for time being, just focus on this. And critical points, one of the important concepts here in this chapter, application of derivatives, three terms to be understood very nicely. One is critical point, another one is stationary point, another one is point of inflection. Three important terms to be understood very well. Critical points, stationary points and the point of inflection. Okay. Critical points means the points where derivative becomes equal to 0 or the points where the derivative is not defined. Critical points. Again repeat, for a given function y equal to f of x, you can find the points where derivative becomes 0, derivative vanishes, or the points where derivative is not defined. Such points are called as critical points. See, f of x equal to x square, f dash of x 2x. 2x equal to 0 means x equal to 0. So x equal to 0 is the critical point for the function f of x equal to x square. If we consider f of x equal to root x, derivative of root x 1 by 2 root x, f dash of x is not defined at x equal to 0. So x equal to 0 is the critical point, correct? Even f of x equal to mod x, mod x is not differentiable at x equal to 0, which is a critical point, correct? So function is not differentiable at a point, that is a critical point. If the derivative becomes 0, that is also critical point, correct? But stationary point is there, no? Stationary point means the points where derivative becomes 0. Points where derivative becomes 0 are called as critical, are called stationary points. Only derivative becomes 0. Only if the derivative becomes 0, it's a stationary point. Every critical point is a stationary point too. Correct? Sorry, every stationary point is a critical point, correct? F dash of x equal to 0 means every stationary point is a critical point, correct? But every critical point need not be a stationary point, that is there. Because f dash of x equal to 0 means a stationary point. Critical point means f dash of x equal to 0 or f dash of x not defined. So every stationary point is going to be a critical point. But every critical point need not be a stationary point. So difference is there. So for stationary point, at the stationary point, the tangent drawn will be parallel to x-axis. I given the note of stationary point too. And here I given the table of critical points for different functions. F of x equal to x square already told, I explained here, correct? F of x equal to x square, derivative becomes 0 at x equal to 0. So 0 is the critical point for x square. For root x, f dash of 0 does not exist. Derivative of root x is 1 by 2 root x. F dash of 0 is 1 by 0, not defined. And f of x equal to mod x is not differentiable at x equal to 0. So 0 is a critical point, correct? So 0 is a critical point for mod x. Because x equal to 0 at x equal to 0, mod x is not differentiable. Root x is not differentiable at x equal to 0. And x square derivative becomes 0 for x square at x equal to 0. Derivative of x square 2x, 2 into 0, 0. So, and sin x you take derivative of sin x is cos x. Already drawn the graph of sin x, no? Drawn the graph of sin x here. You take sin x here, you can draw the tangent here, correct? And tangent is parallel to x axis at this point, correct? Tangent is parallel to x axis at 3 pi by 2, correct? So f dash of x equal to 0 will give the stationary point. F dash of x equal to 0 you can do. F of x equal to sin x. F dash of x what? F of x is equal to sin x. F dash of x. Derivative of sin x is cos x. F dash of x is cos x. Cos x is equal to 0. Cos x becomes 0 for odd multiple of pi by 2. 2n plus 1 pi by 2. N belongs to z. Similarly, cos x, derivative of cos x is minus sin x. Minus sin x equal to 0. Sin x becomes 0 for n pi. F of x equal to x cube, derivative of x cube 3x square. 3x square becomes 0 for x equal to 0. 0 is the critical point. F of x equal to greatest integer function. We know greatest integer function is discontinuous for every integral values. Correct? Every integral values the function is discontinuous. Hence it is not differentiable at every integral values. So for every integer it is a critical point. Signum of x is not differentiable at x equal to 0. Signum of x means mod x by x. Mod x by x is called signum function. Mod x by x for x not equal to 0. 0 for x equal to 0. Signum function. Signum function is not differentiable at x equal to 0 because it is not continuous at x equal to 0. Correct? Every discontinuous functions are non-differentiable functions. That also we know. Correct? Signum function is discontinuous at x equal to 0. Therefore, it is not differentiable at x equal to 0. If a function is not differentiable, it is a critical point. So, x equal to 0 is a critical point for signum function. Mod of sin x. Mod of sin x, you can draw the graph. Mod of sin x, no, it is not differentiable at n pi. Mod of sin x graph we can draw. Or I can tell mod of sin x is not differentiable at the points where sin x becomes 0. Sin x becomes 0 at n pi. You can draw the graph of mod of sin x. I'll show like this. Mod of sin x is like this. Sin x graph is like this, no? Sin x graph is like this. In the interval minus 2 pi to plus 2 pi. This is. If you want mod of sin x, graph is like this. Whatever is below, no, will be shifted above. It will be reflected above the x-axis. Mod of sin x. This is 0, pi, 2 pi. This is minus pi and minus 2 pi. This is graph of mod of sin x. Mod of sin x is not differentiable at n pi because at every multiple of pi, no, we can draw. There is possibility of drawing more than one tangent. Or I can tell there is that is where it intersects the x-axis, the points where it intersects the x-axis. Or you can tell there is a sharp point. There is a sharp point at x equal to n pi. Mod of sin x is not differentiable at n pi. Mod of cos x is not differentiable at the points where cos x becomes 0. Cos x 0 means 2n plus 1 pi by 2. We can draw the graph of cos x and hence draw the graph of mod of cos x. Cos x graph is like this. Cos 0 is 1. Cos pi by 2 is 0. Cos pi is minus 1. Cos 3 pi by 2 is 0. Cos 2 pi is 1. Graph comes like this. This is cos x graph. Cos x. If you want mod of cos x, the graph will be like this. Whatever is present below the x-axis will be shifted. This is pi by 2, 3 pi by 2. Between pi by 2 to 3 pi by 2 is below the x-axis. It will be shifted above the x-axis. Like this. Correct? Like this it goes up. Whatever is present below the x-axis will be shifted above the x-axis. This is pi by 2. At pi by 2 there is a sharp point. Wherever there is a sharp point, the function is not differentiable. At the points where it intersects the x-axis, the function is not differentiable. This is graph of mod of cos x. Graph of mod of cos x. Mod of cos x. Not differentiable at the points where cos x becomes 0. Cos x becomes 0 for 2n plus 1 pi by 2. Hence it is a critical point. Mod of tan x, x equal to n pi by 2 is a critical point. Sin inverse of sin x. Sin inverse of sin x also we can draw the graph. Sin inverse of sin x has same critical points as that of sin x. 2n plus 1 pi by 2. Remember, sin x and sin inverse of sin x both have same critical point. Cos x and cos inverse x both have same critical point. I can draw the graph of sin inverse of sin x2. I can draw the graph of sin inverse of sin x2 and show you. I can draw it here itself. Graph of sine inverse of sin x. Graph of sine inverse of sin x like this. Between minus pi by 2 to pi by 2 it is a straight line. Okay, passing through the origin like this. And passes through 3 pi by 2 here. It comes down. Between pi by 2 to 3 pi by 2. Pi by 2 is here. 3 pi by 2. Sine inverse of sine 3 pi by 2. Between these two. Like this it comes down. At pi it passes. And it goes up like this. So it is not differentiable at 2n plus 1 pi by 2. 2n plus 1 pi by 2. It is not differentiable. It comes down like this. Like this. So at pi by 2 there is a sharp point. At 3 pi by 2 there is a sharp point. Where the graph has sharp point, at such points it is not differentiable. At pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, there is a sharp point. Pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. In general, 2n plus 1 pi by 2. Sine inverse of sin x has sharp point at 2n plus 1 pi by 2. Hence it is not differentiable. Cos inverse of cos x also we can draw the graph. Cos inverse of, this is graph of sine inverse of sin x. Sine inverse of sin x. Next I am drawing the graph of cos inverse of cos x. Cos inverse of cos x graph is here. Cos inverse of cos x if you want, 0 is here. Pi, 2 pi. Range of cos inverse, 0 to pi. No, graph will not come below the x-axis. So 0 to pi like this it goes up and it comes down like this. Here it is minus pi, minus 2 pi. This is graph of cos inverse of cos x. Where it is not differentiable, you see. It is not differentiable at every multiple of pi. Pi, 2 pi, minus 2 pi. At pi and minus pi it has a sharp point. At 2 pi and minus 2 pi it is intersecting the x-axis, correct? So it's not differentiable at n pi. Cos inverse of cos x is not differentiable at x equal to n pi. So x equal to n pi is a critical point. Okay, so these are the various things given the information about a critical point for you. Move on to the next one. Finding the intervals where the function is strictly increasing and strictly decreasing. So if they give a function to you, differentiate and find the critical points and divide the entire number line. Okay, entire number line to be divided at the critical points. Suppose a and b are the critical points. Suppose you get a polynomial function. In that case, you differentiate and get two critical points. If suppose you get a cubic polynomial. Okay, I'll represent here itself. Real number line extends from minus infinity to plus infinity, correct? So this is a and b. Assume that a is less than b. Assume that a is less than b. So a and b are the critical points. You check for derivative sign. You can use wavy curve method also here. Okay, from right side of beam, the coefficient of x square is positive. Then coefficient of highest power of x is positive. Then start from right side. Right side will be positive depending upon the power. If the derivative is positive, function is strictly increasing. If the derivative is negative, the function is strictly decreasing. Like this it goes on. Just a given information about how to find out the intervals where the if the function is strictly increasing and decreasing. Where the interval is strictly increasing if the derivative is positive. Derivative is negative means the function is strictly decreasing. Okay, I'll explain to you while working out the problems on this. And this is for tips and tricks given here for a cubic polynomial. Okay, if a and b are the critical points with a less than b, what happens? It depends upon the coefficient of x cube. So when a cubic polynomial is given to you, okay, cubic polynomial is given to you, okay, differentiate. When you differentiate, what you get is quadratic. Quadratic function becomes 0 for 2 points, correct? So take the critical points as a and b. When you differentiate a cubic polynomial, we get a quadratic polynomial. That is derivative. F of x is cubic, f dash of x is quadratic. F dash of x equal to 0 means quadratic equal to 0. Quadratic equal to 0 has two real roots. Assume that it has two real roots. A and b are the two critical points. If a and b are the two critical points with a less than b, like this, if a less than b, and coefficient of x cube is positive. If coefficient of x cube is positive, then how the function nature will be there? No, if the coefficient of x cube is positive, positive, negative, positive, like this it will be. So function will be increasing, strictly increasing in the interval minus infinity to a union b to infinity, and decreasing in the interval a to b. If coefficient of x cube is positive. If coefficient of x cube is negative, no, in that case it will be like this. I'll represent here. A and B are the critical points. Okay. If coefficient of x cube is negative, if coefficient of x cube is negative, in that case what happens? It will be negative, positive, negative like this. So the function is going to be increasing in the interval a to b and decreasing in the interval minus infinity to a union b to infinity. Decreasing, increasing, decreasing, strictly decreasing, strictly increasing, strictly decreasing. Here it is increasing, decreasing, increasing. So you can write the interval accordingly. So you can use the shortcut method. Okay. So when a cubic polynomial is given to you, just differentiate and find the critical points. Okay. F dash of x equal to 0 to critical points you get. So right side you start positive, negative, positive. Where if the coefficient of x cube is positive, if the coefficient of x cube is negative, negative, positive, negative, then you can write derivative is negative means the function is strictly decreasing. If derivative is positive, the function is strictly increasing. Understood? So, and if they give a biquadratic polynomial, the degree 4 is given. Suppose degree 4 is given, in that case I'll represent here. When a polynomial of degree 4 is given, okay, if you differentiate degree 4, no, polynomial, you get f dash of x as cubic. Cubic equation has 3 roots. So you'll get 3 critical points. Assume that all a, b, c are real numbers. A, B, C are real numbers. In this order you take a is less than, b is less than, c. And if coefficient of x power 4 is positive, coefficient of x power 4 is positive, okay, it will be decreasing, increasing, decreasing, increasing. So right side you start positive, okay, positive, negative, positive, negative like this. So here it is decreasing, increasing, decreasing, increasing like this it will be. So increasing in the interval a to b union c to infinity and decreasing in the interval minus infinity to a union b to c. And a less than, b less than, c, same condition to take if coefficient of x cube is coefficient of x power 4, correct, coefficient of x power 4 is positive, here coefficient of x power 4 is negative, in that case what happens? In that case a, b, c are the critical points, right side of c is negative, then alternate plus minus, plus minus plus. So where it is increasing in the interval minus infinity to here. Here it is increasing. Here it is decreasing. Here it is increasing. Here it is decreasing. So you can write. From right side you start. If coefficient of x power 4 is negative, from right side you start with negative. If coefficient of x power 4 is positive, from extreme right you start positive. Alternate plus minus from right side. Here alternate minus plus from the right side. Hope you understand. Derivative positive is strictly increasing. Derivative is negative means function is strictly decreasing. Accordingly we can write. Take some questions on this. Question asked in the year 2022. F of x is given like this. 4 sin cube x minus 6 sin square x plus 12 sin x plus 100. F of x is given like this. 4 sin cube x minus 6 sin square x plus 12 sin x plus 100. Differentiate this. F dash of x we get. Differentiating this. F dash of x. 4 into 3 becomes 12. 12 sin square x minus 6 into 2. 12. Sorry, I need to use chain rule. No, sorry. Derivative of sin cube x. Derivative of sin cube x is 3 sin square x into derivative of sin x cos x, right? Apply the chain rule. Constant into variable. Constant keep as this. Derivative of sin cube x is 3 sin square x and derivative of sin cos. 3 sin square x into cos x. Derivative of sin x cos x. Minus 6 into derivative of sin square x. 2 sin x into derivative of sin x cos x. Plus 12 into derivative of sin x is cos x. Derivative of 100 is 0. I won't write that. So we can take 12 cos x is common, right? 6 2s are 12, 4 3s are 12. 12 cos x is common. 12 cos x is taken out. What remains is sin square x minus 12 cos x taken out minus sin x plus 1. And note that sin square x minus sin x plus 1 is always positive. Because you know x square minus x plus 1 is always positive. Is greater than 0 for all x belongs to R. For every real number it is positive. Even x square plus x plus 1 is always positive. x square minus x plus 1 and x square plus x plus 1. Both are always positive for any real values of x, correct? Because the coefficient of x square is positive, correct? And b square minus 4ac is negative. Coefficient of x square is positive and b square minus 4ac is negative. That's the reason. B square minus 4ac is less than 0. That's the condition for quadratic to be positive. Coefficient of x square is positive and b square minus 4ac is negative. Correct? That is the condition for quadratic to be positive. B square minus 4ac calculate. 1 minus 4 minus 3 again. B square minus 4ac is minus 3. Here also b square minus 4ac is 1 minus 4 minus 3 again. So b square minus 4ac is negative and coefficient of x square is positive. The quadratic is always positive. The sine square x minus sine x plus 1 takes this form. X square minus x plus 1. Any expression taking this form, no? X square minus x plus 1. Here x is replaced by sine x. Still it is going to be positive. I don't have to check for the sign of this. It is always positive. Okay? Because since sine square x minus sine x plus 1 is always positive, sine square x minus sine x plus 1 is greater than 0 for all x belongs to R. It depends upon cos x. It depends upon cos x. If cos x is positive, then derivative will be positive, function is increasing. If cos x is negative, derivative will be negative, function will be decreasing. It depends upon cos x. It depends upon cos x for f dash of x to be positive or negative. Various options are given. We will check one by one. Decreasing in the interval pi by 2 to pi. Pi by 2 to pi is second quadrant. Second quadrant cos function is negative. Correct? Second quadrant cos function is negative. So negative. Negative into positive. Negative. So decreasing in the interval pi by 2 to pi is true. Correct? In the second quadrant, pi by 2 to pi is second quadrant. Second quadrant cos function is negative. The cos x is negative, means derivative is negative. So derivative is negative, function is decreasing is true. Option A is the answer. I can tell. Other options are verified. See, they told decreasing in the interval minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2 will cover the first and fourth quadrant. Minus pi by 2 to pi by 2 like this. In first quadrant, cos function is positive. Correct? Cos x positive means derivative positive, increasing. They told decreasing. No. This is fourth quadrant. Fourth quadrant also cos function is positive. Cos x is positive means derivative is positive, increasing. So it's not true. This is not true. Correct? Decreasing in the interval 0 to pi by 2 is not true. 0 to pi by 2 first quadrant. First quadrant cos function is positive. Derivative is positive. Function is increasing. They told decreasing. Not true. Increasing in the interval pi to 3 pi by 2. Pi to 3 pi by 2 is third quadrant. Third quadrant cos function is negative. Negative means decreasing. So they told increasing. The derivative is negative. Correct? Third quadrant. Third quadrant cos function is negative. So derivative is negative. If derivative is negative, function is decreasing. It can't be increasing. So not true. Answer is option E. Question asked in there 2022. Very nice question. Function f of x equal to log of 1 plus x minus 2x by 2 plus x is increasing on which interval you have to find out. Find out the derivative of this. First of all, you have to fix the domain of this function. This is a rational function. Rational function is defined for denominator not equal to 0. Correct? 2x by 2 plus x is defined for 2 plus x not equal to 0. This is for x not equal to minus 2. And log 1 plus x is for x greater than minus 1. Correct? 1 plus x should be greater than 0. 1 plus x should be greater than 0. That means x is greater than minus 1. So domain of this function is x greater than minus 1. If you take x greater than minus 1 to infinity, anyway minus 2 is not there, correct? So domain of f is x greater than minus 1. Domain of the function I'll write first. In that domain you find out the derivative. Minus 1 to infinity is the domain of this function. Find out derivative of this. F dash of x. Derivative of log is 1 by 1 plus x. 1 by 1 plus x. To differentiate this 2x by 2 plus x, I can use one shortcut method. Derivative of ax plus b by cx plus d is there. If the function takes this form, no, ax plus b by cx plus d. If y is equal to ax plus b by cx plus d, then dy by dx is equal to ad minus bc by denominator square. Okay, this is a shortcut. AD minus BC by denominator square. AD minus BC, crisscross, applesauce, just like taking determinant, correct? So now y is given to be 2x by 2 plus x. I'll write in this form, 2x plus 0, correct, divided by 2 plus x is same as x plus 2. So I can write dy by dx as dy by dx is equal to what? AD minus BC by denominator square, AX plus B by CX plus D, AD minus BC, 2 into 2, 4, minus 1 into 0, correct? 4 minus 0 divided by denominator square, 4 by x plus 2 the whole square. 2 into 2, 4, AD minus BC, compare with AX plus B by CX plus D, compare, correct? I wrote 2 plus x as x plus 2, both one in the same, correct? 2x is 2x plus 0, AD minus BC, 4 minus 0, 4, so 4 by x plus 2 the whole square. Take LCM and simplify this. Common denominator is 1 plus x into x plus 2 the whole square. So what do we get? Here x plus 2 the whole square minus 4 times 1 plus x. If we simplify this, what do we get? X square plus 4 plus 4x minus 4 minus 4x, correct? Open the bracket, divided by 1 plus x into 2 plus x the whole square. Here what happens? 4x will cancel, plus 4 minus 4 cancels. I am getting x square divided by 1 plus x into 2 plus x the whole square. In the interval x belonging to minus 1 to infinity, I can tell that this is always greater than or equal to 0. So function is increasing. Derivative can become 0 for x equal to 0. 0 by 1 plus 0 into 2 plus 0 square. 0 by non-zero becomes 0. Derivative can become 0 at x equal to 0. Otherwise it is always positive, because my domain is x belongs to minus 1 to infinity. Means 1 plus x is positive. 1 plus x positive. Denominator 2 plus x the whole square is there, no? It is always positive. 2 plus x the whole square is always positive because square is there. 1 plus x positive because of this condition we have. 1 plus x is positive. And numerator can become 0 if you put x equal to 0. So derivative is always greater than or equal to 0. Derivative is positive or 0, means function is increasing. Function is increasing for which interval? For this interval, because this is the domain of this function. So function is increasing in the interval minus 1 to infinity, option D. Same question is found in the NCERT textbook, okay? Their domain is given in the question itself. Here domain you have to find out, and in that domain you have to find where the function is increasing. The domain of the function is nothing but the interval where the function is increasing, okay? Move on to the next one. Question number 3, the function f of x given like this is strictly decreasing in which interval? Question asked in the year 2021. Strictly decreasing means f dash of x less than 0. F of x is given here. F of x is given to be equal to x square minus 2x. F dash of x. F dash of x is differentiate this polynomial function of degree to 2x minus 2. F is strictly decreasing. Given f is strictly decreasing implies f is strictly decreasing implies f dash of x is less than 0. So what you get is 2x minus 2 less than 0. Means 2x less than 2. I'll get x less than 1. X less than 1 is left side of 1 minus infinity to 1. Correct? On the number line if you plot. X less than 1, correct, left side of 1, minus infinity to 1, this is the interval we want. Less than 1 is x between minus infinity to 1, x belonging to this interval, minus infinity to 1, correct? Simple question. Strictly decreasing means f dash of x less than 0. F dash of x we find out, solve the inequality, get the answer. 2x less than 2, divide by 2 on both sides. X less than 1. Less than 1 is left side of 1. Minus infinity to 1 is the answer. Option A. Move on to the next one. The interval in which the function f of x is increasing in. So in which interval the function is increasing. Actually I will change the option a little bit here, okay? Because to avoid multiple correct answers, I'll tell you the reason why. Given a function of a polynomial function of degree 3. So when you differentiate we get a quadratic polynomial. To find the interval where the function is increasing or decreasing, we find the critical points first and divide the number line into 3 disjoint intervals, correct? F dash of x you find out. What is f dash of x? Derivative of x cube is 3x square. Derivative of 6x square, 12x. Derivative of 9x, 9. Derivative of 10 is 0. 3 is common here. X square minus 4x plus 3 equal to 0. F dash of x equal to 0. 3 can't be 0. So factorize this. X minus 1 into x minus 3 equal to 0. That means x equal to 1, x equal to 3. Critical points are 1 and 3. These are the critical points. F dash of x equal to 0 are called as critical points. By using Wavy-Curve method, and find out. Already told the shortcut method for finding this. For polynomial function, where it is polynomial function of degree 3 is given, where it is increasing and where it is decreasing, by plotting these critical points on the number line. You know, 1 is less than 3. Right side of 3 is start. Coefficient of x cube is 1, positive. If coefficient of x cube is positive, start from right side. Coefficient of x square is also positive, right? So positive, negative, positive. By Wavy-Curve method it follows. Coefficient of x square is positive. So from right side of right, from the extreme right you start. From extreme right, positive, negative, positive. Correct? If coefficient of x cube is positive, derivative will be 3x square, no? X square, x cube derivative is 3x square, it's positive only. Coefficient of x square is positive, we have dash of x. So increasing, decreasing, increasing. Where it is increasing, minus infinity to 1, union 3 to infinity. I can use the open closed interval, here closed open interval. So here the function is increasing, here also the function is increasing, here it is decreasing. So I can tell f is increasing in the interval, f is increasing in the interval. Otherwise you can use the Wavy-Curve method actually. From the right side of 3, right side of 3 is positive. Positive, no, 3 is derived from where? 3 is derived from x minus 3. X minus 3 power 1, no, 1 is odd number. So sign changes here. Plus will become minus. 1 is derived from where? 1 is derived from x minus 1. X minus 1 power 1, odd number. Odd number means again sign changes. Negative becomes positive. Correct? So f is increasing in the interval. Minus infinity to 1, union 3 to infinity. Function is increasing in the interval. Minus infinity to 1, union 3 to infinity. Actually in the options, no, actual paper, they given the open interval here. Minus infinity to 1, union 3 to infinity. That was another option actually. I changed the option actually, okay, to avoid multiple correct answers. Why? Because I'll tell you the reason. If the function is increasing, suppose the function is increasing in the closed interval AB, okay, you think that the function is increasing in the closed interval AB. If the function is increasing in the closed interval AB, then can I tell the function is also increasing in the open interval AB? There is no much difference, correct? Because every open interval is going to be a subset of closed interval, right? Open interval is a subset of closed interval. If anything happens in the closed interval, same thing should happen even in the open interval, right? So function is increasing in the closed interval implies the function is also increasing in the open interval. And moreover, if the function is strictly increasing in the open interval, if you tell function is strictly increasing in the open interval, then I can tell function is also strictly increasing in the closed interval also. Closed interval and open interval, what is the difference? Only endpoints. In open interval, endpoints are excluded. Correct? In closed interval, endpoints are included. That's the only difference. So if the function is defined at the endpoints, if the function is defined, what happens? No, if the function is strictly increasing in the open interval, then the function f is also strictly increasing in the closed interval, provided the function is defined at the endpoints. Over. That's the important thing to be noted. That's the difference. There is no much difference between strictly increasing and decreasing. Where it matters, you know, a function increasing and strictly increasing, I'll tell you the difference. Suppose a function is going to remain constant. Function is going to remain constant in a set of, for a set of points. For a set of points or in an interval. Suppose you take an interval, say in the interval 1 to 5. 1 to 5, the function is increasing. Okay. Where the difference between increasing and decreasing comes, suppose the function is increasing in the interval, closed interval 1 to 5. But what happens is in the interval, say in the interval 2 to 3, in the interval 2 to 3, in this interval, a part of the interval I taken 2 to 3, then the function is not increasing, then the function is remaining constant. Then I can't tell it is strictly increasing. Then it is not strictly increasing. Suppose only at one point it is remaining constant, not in a set of points in an interval. Okay, in that case we can tell the function is strictly increasing only. Again I repeat, so function is increasing in the interval 1 to 5. Say at x equal to 2, derivative becomes 0. That means at x equal to the function is constant. Okay, only at x equal to derivative is 0. Rest everywhere in this interval the function derivative is positive. In that case I can tell function is increasing also. I can tell it is strictly increasing also, no problem. Whereas in the interval 1 to 5 the derivative is greater than or equal to 0. That means at some interval, say 2 to 3, in the interval 2 to 3 derivative is becoming 0. That means the function is constant in the interval 2 to 3. Then this function is going to be increasing but not strictly increasing. Graphical approach is the best thing, I'll tell you. See, in the graph I've shown already, correct? The graph of increasing and decreasing functions. Strictly increasing and strictly decreasing function. Here, in this case, what happens? In this entire interval, the function is constant. Here it is increasing. Here it is constant. Again increases. In this entire interval, the function is what? Constant. Therefore, this function is not strictly increasing. It is not strictly increasing. It is only increasing because in a set of points in the interval from this to this, it becomes an interval because there is infinitely many points from this to this. Correct? In that interval, from here to here, the function is increasing. But here the function is not increasing. It is becoming constant, right? So I can't tell it is strictly increasing. Here also same story. Here the function is constant. Here decreases, constant in an interval, and again decreases. So it is not strictly decreasing. It is only decreasing. It's not strictly decreasing because in a set for a set of points the function is constant. Suppose the function is behaving like this. The function is behaving like this. Increases like this. And here it becomes 0. Here at this point derivative is becoming 0. And again increases like this. Okay. Then the function is strictly increasing only. Only at this point derivative is becoming 0 means I should take derivative equal to 0. F dash of x equal to 0 means we should intersect the x-axis, not like this. Something like this where derivative becomes 0. F dash of x equal to 0 means I should have a, if a tangent is drawn it becomes parallel to x-axis, correct? Something like that, but rough sketch. Okay, I'll draw the better figure. F dash of x equal to 0. At some point derivative becomes 0. Okay. In that case, again the function increases. Increases, remains constant. That is, at one point the derivative becomes 0 and again increases. F dash of x equal to 0. Okay. In that case, the function is going to be increasing, or you can tell even strictly increasing. Does not matter for us. So this was over. Even this question also over. Answer is minus infinity to 1 union 3 to infinity. Move on to the next one. Here the function is strictly increasing in the interval. F dash of x is find out. F dash of x. Derivative of x square is 2x. Derivative of 2x is 2. Derivative of 5 is 0. Function is strictly increasing. Strictly increasing implies f dash of x greater than 0. Function is strictly increasing implies f dash of x is greater than 0. That means 2x plus 2 is greater than 0. 2x is greater than minus 2. That means x is greater than minus 1. X is greater than minus 1 means minus 1 to infinity. Answer is option D. Derivative should be positive. Correct? Derivative of x square 2x. Derivative of 2x 2. Derivative of 5 0. F dash of x greater than 0. 2x plus 2 greater than 0. So 2x is greater than minus 2. X is greater than minus 1. Correct? So x is greater than minus 1 is minus 1 to infinity. Minus 1 to infinity. This side, right side of minus 1. So function is increasing in the interval minus 1 to infinity. 2x plus 2 greater than 0. 2x is greater than minus 2. X is greater than minus 1. So minus 1 to infinity is the answer. Option D. Question answer there 2017. And if the function is strictly increasing in the interval minus 1 to infinity, it is also strictly increasing in the interval minus 1 to infinity. See, f is strictly increasing. F is strictly increasing according to the question we got. in the interval minus 1 to infinity. Correct? Even f is strictly increasing implies f is also strictly increasing in the closed open interval minus 1 to infinity. Because at minus 1 if you include, what is the difference between this and this? Here minus 1 is excluded, here minus 1 is included. So if you take minus 1, f dash of x will be 0, correct? At minus 1, f dash of x is equal to 0. F dash of minus 1 if we calculate, that will be 0. 2x plus 2 becomes 0. Correct? At x equal to minus 1, derivative is becoming 0. At only one point, derivative is becoming 0. Well, that means at only one point, the function is becoming constant. That does not matter for us. We are not getting a set of points where the function is constant. So even this is true. Even this is true. Here also I have changed the option actually. Actually, minus 1 to infinity was given. No, this is open interval. And one more option was there with closed open interval, minus 1 to infinity. I have changed the option, I think. Okay. So this is not exactly found in the paper. In the paper, question was something like this. Both options were present. I modified the options so that I get only one right answer. Even this is true, even this is true. Both are true. Both the sentences are true. Okay. Because difference between these two is here minus 1 is included, here minus 1 is excluded. At minus 1, derivative is becoming 0. Correct? And even at x equal to minus 1, the function is well defined. It's a polynomial function defined for every real number. So it does not affect our answer. So at minus 1, if you draw the tangent to that, it is becoming parallel to x-axis. For this curve at x equal to minus 1, tangent is parallel to x-axis. F dash of minus 1 equal to 0. That does not matter. At only one point, derivative is becoming 0. Means at that point only the function is constant. Rest of everywhere the function is increasing. So strictly increasing in this interval as well as this interval. Both are true. But here I modified the option so that only one answer is correct here. Option D is the answer. Hope it's clear. Difference between increasing and strictly increasing functions and decreasing and strictly decreasing function. This type of question asked in JEE Mains also this time 2025. One of the question asked. Okay, this is a very standard one. I can give the shortcut also for this. Function is of the type x by a plus a by x. The function is of the type x by a plus a by x. X by a plus a by x. This function is going to be strictly decreasing, directly I'll tell, strictly decreasing in the interval minus a to 0 union 0 to a. Minus a to 0 union 0 to a. And strictly increasing in the interval, strictly increasing in the interval minus infinity to minus a union a to infinity. Learn this as a standard result for a not equal to 0. For x not equal to 0 is the condition actually. X not equal to 0. X not equal to 0. Okay. So this function is going to be decreasing in the interval minus 3 to 0 union 0 to 3. Over. Answer is done. Within 5 seconds you can answer. Read the question. 5 seconds enough to crack this. Decreases in the interval minus 3 to 0 union 0 to 3. If you want to do the steps, already given here. Correct? F dash of x. Differentiate. Derivative of x by 3. X by 3 derivative is 1 by 3. Derivative of 3 by x, 3 into 1 by x. If you want to write f of x first, then write f dash of x. F of x I'll write in the simplified form, in the form of constant into variable form. Constant into variable form I write f of x. F of x is equal to x by 3 is 1 by 3 into x plus 3 by x is 3 into 1 by x. 3 into 1 by x. Function is written like this. In the form of constant into variable. X by 3 is same as 1 by 3 into x. 3 by x is 3 into 1 by x. Differentiate this. F dash of x. F dash of x is equal to 1 by 3 into derivative of x is 1. 3 into derivative of 1 by x is minus 1 by x square. F dash of x we got. Function is decreasing is what? F dash of x less than 0. F is decreasing implies f dash of x is less than 0. Correct? So what do you get? 1 by 3 plus into minus is minus 3 by x square less than 0. I'll get 1 by 3 is less than 3 by x square. Correct? Or I can write from this x square is less than 9. X square is less than 9 means x lies between minus 3 and plus 3. but x is not equal to 0. Correct? But x is not equal to 0. But x is not equal to 0. So minus 3 to plus, because you know the rules of inequalities. X square is less than a square, means x should lie between minus a and plus a. Okay, so x square is less than 9 means x lies between minus 3 and plus 3. Okay, so x is not equal to 0. So using this, I have to leave the point 0. 0 is belonging to this interval minus 3 to plus 3. So 0 should be excluded, no? So I'll write x belongs to the interval minus 3 to 0 union 0 to 3. Minus 3 to 0 union 0 to 3, which is option A. So function is decreasing that. If they ask increasing, the complement of this, not exactly complement, less than minus 3 greater than 3. Correct? Minus infinity to minus 3 union 3 to infinity. That's the derivative is going to be positive and the function is increasing in that interval. So learn this, okay? Quite important. Even in JEE exams 2025, this type of question was asked. If they give x by 5 plus 5 by x, suppose I give modified form. Instead of 3, if I give 5, x by 5 plus 5 by x is going to be decreasing in the interval minus 5 to 0 union 0 to 5. Function is decreasing or strictly decreasing. And increasing in the interval minus infinity to minus 5 union 5 to infinity. Same way you can solve. If they ask increasing, no, you can take f dash of x greater than 0 and solve the inequality. Here you get x square greater than 9. X square greater than 9 means x is greater than 3 or x is less than minus 3. If you forget the shortcut, you can solve directly. I'll write the rules of inequality here. X square is greater than a square. X square is greater than a square means what? X is greater than a or x is less than minus a. Where a is positive. Where a is positive. Okay. Learn the rules of inequalities. Set of real values of x for which the function is increasing. Increasing they ask. So f dash of x you find it first. Apply quotient rule for this. Denominator square. Denominator square. Applying quotient rule. Denominator into differentiate the numerator minus numerator into differentiate the denominator. D by dx of log x. This is denominator into derivative of x is 1 minus x into derivative of log x is 1 by x divided by log x the whole square. This will cancel. So what you get is log x minus 1 divided by log x the whole square. Denominator is anyway positive, correct? Square is there. So numerator should be positive, correct? So log x minus 1 should be greater than or equal to 0. Function is increasing, its derivative is greater than or equal to 0. So I'll use log x is greater than or equal to 1. Convert log to exponential form. The base is not given, so take the base as e. So converting log to exponential, I get x is greater than or equal to e power 1. E power 1 is e. So x is greater than or equal to e. Set of all x as that x is greater than or equal to e. The function is increasing. Just apply quotient rule. Asked in the year 2010, one of the most difficult question paper in the entire history of CET exams. 2010 was the most difficult paper, okay, mathematics paper. Denominator square, denominator keep as it is, differentiate the numerator minus numerator into derivative of denominator. Derivative of log x is 1 by x. X cancel, you get log x minus 1. Denominator is positive, so numerator should be greater than or equal to 0. And solve this, convert this log form to exponential form and get the answer. Answer is option C. Move on to the next one. Y is equal to minus x square plus 6x minus 3 is increasing in which interval? Y is given like this. Minus x square plus 6x minus 3. Differentiate this. Function is increasing. So dy by dx is less than 0 we can take depending upon the options. Minus 2x plus 6. Function is increasing. Function is increasing means derivative is greater than 0. Because y is increasing, they told. Because in all the options strict inequality is used, I am using strict inequality. So this implies 6 is greater than 2x. You can divide by 2. So x will be less than 3. X is less than 3 is answer. Option D. Correct? Just differentiate minus 2x plus 6. Minus 2x plus 6 greater than 0 because function is increasing. Derivative is positive. 6 is greater than 2x. Divide by 2 on both sides. X is less than 3. x less than 3 we get. The function is going to be increasing. Is that clear? Move on to the next one. Question asked in the year 2007. Question asked in the year 2025. F of x equal to tan x minus x. Differentiate. F of x is given to be equal to tan x minus x. Find out f dash of x. F dash of x is equal to derivative of tan x is secant square x. Derivative of x is 1. We know that secant square x, no, it is always greater than or equal to 1. Yeah, secant square x is always greater than or equal to 1, because we know that secant x is always less than or equal to minus 1 or greater than or equal to 1. Correct? Secant x belongs to which interval? The range of secant x is minus infinity to minus 1 union 1 to infinity. Correct? Minus infinity to minus 1 union 1 to infinity. This is the range of secant function. That means secant x is greater than or equal to 1 or less than or equal to minus 1. If you square a number which is greater than or equal to 1, then it will be greater than or equal to 1 only. If you square a number less than or equal to minus 1, again you get greater than or equal to 1. Come square this or square this. In both the cases we get secant square x is greater than or equal to 1. So secant square x is greater than or equal to 1 means what? I can write secant square x minus 1 is greater than or equal to 0. So derivative is greater than or equal to 0 means function is always increases. Always increases. Derivative is greater than or equal to 0 means the function is increasing. Increasing for all x, correct? But there is an exception actually. I should have mentioned that x is not equal to odd multiple of pi by 2. Because the tan function is not defined, correct? 2n plus 1 pi by 2, n belongs to z. That is not mentioned here, should have mentioned. So function is always increases because derivative is greater than or equal to 0. Because secant square x is always greater than or equal to 1. If you square a number greater than or equal to 1, we get greater than or equal to 1. If you square a number which is less than or equal to minus 1, we'll get greater than or equal to 1, correct? If you take a number say minus 2, minus 2 square is 4, it is greater than 1, correct? If you take a number less than or equal to minus 1 and square it, we'll get after squaring greater than or equal to 1. Here also we get greater than or equal to 1. So secant square x is always greater than or equal to 1, but x is not equal to odd multiple of pi by 2. For odd multiple of pi by 2, both tan and sec are not defined. So that should be remembered. So you can conclude that answer is option A. Question asked in the year 2025. Move on to the next one. Function f of x equal to x power x is strictly increasing for. We know derivative of x power x very standard by logarithmic differentiation. Derivative of x power x is x power x into 1 plus log x. You must remember, it's very standard. So f of x is x power x according to the question. F of x is x power x. So f dash of x will be derivative of x power x is x power x into 1 plus log x. X power x into 1 plus log x. This should be what? Strictly increasing means derivative is positive because f is strictly increasing. F is strictly increasing. F is strictly increasing. Correct? X power x is already positive because it's exponential function. They told x is greater than 0. In fact, they call it a transcendental function because variable for variable is that. X is positive, x power x is positive. So 1 plus log x should be positive. 1 plus log x is positive. That means log x is greater than minus 1. Log x is greater than minus 1. That means x is greater than e power minus 1. E power minus 1 is 1 by e. Correct? Log x is greater than minus 1. So x is greater than, convert log to exponential form. E power minus 1. Base is e, no? So base is e means base is greater than 1. If the base is greater than 1, log function is increasing. If the base lies between 0 and 1, the log function is decreasing. You must know that. So here the base is e, so it's greater than 1. The base is greater than 1, it is an increasing function. Increasing function means what happens? When you convert log to exponential form, no, the inequality remains the same. Inequality remains the same. If it was a decreasing function, if the base lies between 0 and 1, when you convert log to exponential, the inequality is going to reverse. Now x is greater than e power minus 1. E power minus 1 is 1 by e. So x is greater than 1 by e. Option C is the answer. If you want to write a note here. Log x to the base a, if it is greater than b, then you can write this as x is greater than a power b. Okay, for increasing function, for log x to be increasing function, for x is anyway positive and a is greater than 1. A is greater than 1. The base should be greater than 1. This is the condition for increasing function. That means if log x is increasing function, that is possible when the base is greater than 1. The base is greater than 1, log function is increasing. When it is increasing function, when you convert log to exponential form, the inequality remains the same. Suppose it is a decreasing function. Suppose I give like this, log x to the base a is greater than b. From this, I'll write this x is less than a power b. Inequality has been reversed here. This is for x is greater than 0. X should be positive and a will lie between 0 and 1. A will lie between 0 and 1. This is important. This is for log x base a is a decreasing function. Log x base a greater than b. From this step, I am writing in terms of exponential, converting log to exponential. So x will be greater than becomes less than a power b. For a to lie between 0 and 1. Of course, x is positive. Here also, x is positive because log function is not defined for if x is negative, and a should be greater than 1. See the difference. This is an increasing function. Inequality remains the same. Here is a decreasing function. Inequality is going to reverse. Clear? All these things, important things you must learn. Okay. So answer is option C. Question asked in the year 2024 recently, last year. Move on to the next one. Function f of x equal to x into e power x into 1 minus x. F of x is what? Various options are given. Differentiate using product rule. F of x is given to be equal to x into e power x into 1 minus x. Correct? This is same as x into e power. This is x minus x square. F dash of x we find out. F dash of x using product rule. First into derivative of second plus second into derivative of first. First function keep as it is. Derivative of e power is e power x minus x square into derivative of x minus x square 1 minus 2x plus second function keep as it is. E power x minus x square into derivative of x is 1. Correct? First function keep as it is. Differentiate the second function. Derivative of e power x minus x square is e power x minus x square into derivative of x minus x square is 1 minus 2x plus second function keep as it is. Derivative of x is 1. Correct? So we can take e power x minus x square as common. What remains is x into 1 minus 2x plus 1. Correct? Equal to 0 to get the critical points. Exponential function never becomes 0. E power x is always positive for any real values of x. So this is positive. Terms inside the bracket should be 0. So what we get there? X into 1. Open the bracket and write x minus 2x square plus 1 equal to 0. Multiply by minus 1 and write. If you multiply by minus 1, this becomes 2x square minus x minus 1 equal to 0. Factorize this. 2x square minus 2x, correct, plus x minus 1 equal to 0. 2x common from the first two terms. 2x into x minus 1 plus 1 into x minus 1 equal to 0. Again x minus 1 is common. X minus 1 into 2x plus 1 equal to 0. X minus 1 0 means x equal to 1. X is equal to 1. X is equal to minus half. X equal to 1 and x equal to minus half. These are the critical points. So we can divide the number line at x equal to 1 and x equal to minus half. Of course, minus half is smaller. Minus half is smaller. Then comes 1. So you can find out the derivative. This no need to check. No need to check this. It's always positive. It is always positive. Only we need to find the terms inside this bracket, whether it is positive or negative. If it is positive, derivative will be positive. In that case, the function is increasing. If this terms inside the bracket is negative, in that case, derivative becomes negative, function is decreasing. Okay, so this bracket is nothing but a simplified form is here. Minus 2x square plus x plus 1, correct? This bracket is nothing but, you take minus sign out, correct? Minus of, what I got, our factors, x minus 1 into x plus 1, correct? This is minus of x minus 1 into 2x plus 1. So coefficient of x square is negative, correct? Minus 2x square. So right side of 1 is start. Right side of 1 is going to be negative because coefficient of x square is negative. And 1 is derived from here. 1 is got from this x minus 1. What is the power of x minus 1? 1. Odd number. Power of x minus 1 is 1, odd number. Odd number means sign changes. Minus will become plus. Minus half is got from where? Minus half is derived from this 2x plus 1. By equating 2x plus 1 to 0, I got x equal to minus half, right? So what is the power of 2x plus 1? Power of 2x plus 1 is 1. 1. 1 is odd number. 2x plus 1 means 2x plus 1 to the power 1. The power of 2x plus 1 is odd number. Odd number means again sign changes. Plus will become minus. Here the derivative is negative. This is negative means derivative is negative because this is always positive. So f dash of x sign depends upon this. This I wrote like this after factorizing it. From here I wrote minus of, don't forget to write minus sign because here I multiply by minus 1. Here I can't multiply by minus 1. Sign matters here, okay? So minus of x minus 1 into x plus 1. Negative, positive, negative. So derivative is positive means function is increasing. Here it is decreasing. Here it is increasing. Here it is decreasing. They ask to find which of them is correct. Increasing in R is not true. Decreasing in R is not true. Not true. Not true. Decreasing in minus half to 1 is not true. Increasing in minus half to 1 is true. Option D is the answer. Increasing in the interval minus half to 1. Correct. Derivative is positive. Therefore, function is increasing. Hope it's clear. Okay. Using Wavy-Cobb method, you can get. Differentiate using product rule and get the answer, get the critical points, plot the critical points on the number line. Same question was asked in JEE exam also earlier, prior to this in 2024, earlier PYQ if you refer, it is there. Okay, same question asked. Move on to the next one. This is a 2025 question. Column 1 and column 2 are given, matching type question. Various options are given here. So x mod x, root of mod x plus greatest integer function. Here mod x minus 1 plus mod x plus 1. First, you check x mod x, whether it is continuous, differentiable, strictly increasing, not differentiable. Various options are given here. Correct? Go for x mod x first. X mod x. X mod x, we can redefine it by using the definition of modulus function. Whenever modulus function is there, we split in two cases. X greater than or equal to 0 or x less than 0. Two things are possible. Correct? For x greater than or equal to 0 and for x less than 0. For x greater than or equal to 0, mod x is x. X into x becomes x square. Here for x less than 0, mod x is minus x. Minus x into x becomes minus x square. The function is continuous in the interval minus 1 to plus 1. At 0 also it is continuous. Only doubtful point is 0. Right hand limit is 0 square. Left hand limit is minus 0 square. Left hand limit equal to right hand limit. The function is continuous. At 0 it is continuous. Whether it's differentiable in the interval minus 1 to plus 1. F dash of x you find out. Call this as f of x. Call this as f of x. Okay, f of x is equal to x mod x. Find out f dash of x. F dash of x is equal to derivative of x square is 2x. And this is for x greater than or equal to 0. Derivative of minus x square minus 2x for x less than 0. Correct? F dash of 0 plus. F dash of 0 plus will be 0. 2 into 0, 0. F dash of 0 minus will be equal to minus 2 into 0. That is 0. Function is differentiable. Function is differentiable even at 0. So function is continuous in the open interval minus 1 plus 1. That is obviously true. Function is differentiable in the open interval minus 1 plus 1 is also true. Correct? And whether it's strictly increasing. See, for x greater than 0, derivative is positive. For x less than 0, derivative is minus 2x. Correct? That means when you put x equal to negative value, it's going to be positive. Function is increasing. Strictly increasing in the interval minus 1 to plus 1 is also true. If you want, I can draw the graph of this. Graph of this. In the interval for x greater than or equal to 0, it is like this. Parabola. Half parabola. And for x less than 0, it is minus x square like this. In the interval minus 1 to plus 1, the function is increasing only. Strictly increasing is true. Because here derivative is positive. 2 into positive is positive. Correct? Minus 2 into negative is positive. So in this interval as well as in this interval, the function is increasing. So function is strictly increasing in the interval minus 1 to plus 1 is true. Because derivative is positive here. Here also derivative is positive. Because x is negative, no? X is less than 0. Minus 2 into negative. Because x is negative. Minus 2 into negative is negative. Minus 2 into negative is positive. So here also derivative is positive. Here also derivative is positive. Function is strictly increasing. Hope it's clear. Minus 2 into x is less than 0. No? Less than 0 is negative. Minus 2 into negative is positive. 2 into positive is positive. In both the case, I am getting derivative as positive. Function is increasing, strictly increasing in the interval minus 1 to plus 1. Function is differentiable in the open interval minus 1 to plus 1. So option A, A column A is going to 1, 2, 3. A goes to 1, 2, 3. 4 is not possible, correct? A goes to 1, A goes to 2, A also goes to 3. Go to root of mod x. Root of mod x, no graph we can draw. Root of mod x graph will be something like this. If x is positive, it becomes, what is root of mod x? Root of mod x will be root x if x is greater than or equal to 0. Root of minus x if x is less than 0. So graph of this, for x greater than or equal to 0, y is equal to root x like this. And for x less than 0, root of minus x like this. This is graph of root of minus x. I'll call this as g of x. G of x equal to root of mod x. Definitely the function is continuous at x equal to 0. You can find out the left hand limit, right hand limit. For x tends to 0 plus. 0 plus is root 0, 0. Take x equal to small positive quantity, root 0, 0. Root of minus x, where x is negative. X is negative means minus x is positive. So root of small positive value, correct? Minus x is positive and close to 0. Root of x close to 0. Both will tend to 0. As x tends to 0 plus and 0 minus, this function will tend to 0. Even f of 0, 0, function is continuous. At x equal to 0, function is continuous. But it is not differentiable at x equal to 0. Root of mod x, now if you differentiate, g of x is root of mod x. Derivative of root of mod x what? 1 by 2 root of mod x into derivative of mod x, that is x by mod x, for x not equal to 0. Correct? X not equal to 0. At x equal to 0, the function is not differentiable. G dash of 0, 1 by 2 root of 0 I get. Correct? If you want, take root of x. G dash of 0 plus also is not defined. G dash of 0 plus, if you find out, 1 by 2 root x, 1 by 2 root of 0. If you find out g dash of 0 plus, I'll get 1 by 2 root of 0, which is not defined. Correct? The function is not differentiable at x equal to 0. It is continuous but not differentiable. So not differentiable at least one point is possible for this. 1 is possible, 2 is not possible. Strictly increasing in the interval minus 1 to plus 1 is not possible, because here the function is decreasing. Correct? Here the function is increasing. Decreasing, increasing. So neither increasing nor decreasing in the interval minus 1 to plus 1. In the interval minus 1 to plus 1, it is neither increasing nor decreasing interval. So root of mod x can be continuous in the open interval minus 1 to plus 1, but it is not differentiable at least one point in the open interval minus 1 plus 1. So second one, B will go to 1 and 4. B goes to 1 and 4. Next one, C. Take this function as f I took G, I'll take this as h. H is equal to x plus greatest integer function, I'll take h of x. Take h of x is equal to x plus greatest integer function. We know that greatest integer function is discontinuous at every integral points. Correct? So in the interval minus 1 to plus 1, 0 is present, integer. So at 0 it is not continuous. If it is not continuous, it is not differentiable also. So root of x plus greatest integer function is not continuous in the open interval minus 1 plus 1, because 0 is there. Correct? At 0 the function is not continuous. We know that greatest integer function is discontinuous for every integral points. At 0 it is discontinuous. So if the function is discontinuous, it is not differentiable. So it is not differentiable. This is not possible. This is not possible. This is possible. Not differentiable at least one point in the open interval minus 1 plus 1. Greatest integer function, x plus greatest integer function is not differentiable at x equal to 0, which belongs to the open interval minus 1 plus 1. What about the nature of the function, whether it's increasing or decreasing? You can find out. You can split this. Minus 1 to 0 I'll split. Minus 1 less than x less than or equal to 0. Correct? Minus 1 less than or equal to x. Minus 1 less than x less than or equal to 0. 0 less than x less than 1. So like this I'll split, because at 0 I have to split. Minus 1 to 0, any value you take, greatest integer function becomes minus 1. So this will be x minus 1, correct? X minus 1, okay, for x between minus 1 and plus 1. For 0 to 1, greatest integer function is 0, x plus 0 is x. Like this I get. Here the derivative is 1. Here also derivative is 1. Derivative is positive. Therefore the function is increasing. Function is strictly increasing in the interval minus 1 to plus 1 is true. Because h dash of x In both the case, I am getting 1 only. In this interval also derivative is 1. In this interval also derivative is 1. The function is increasing. That is true. So x plus greatest integer function can go to c. C can go to 3 and 4. It's not differentiable at 0 and it is strictly increasing. So c can go to 3 and it can also go to 4. Lastly, we have mod x minus 1 plus mod x plus 1. We know the graph of this, a bucket shaped graph. The critical points are this is 1 and minus 1. Between minus 1 to plus 1 it becomes a constant. Learn the graph of mod x minus 1 plus mod x plus 1. It's very familiar. In differentiability, I'll teach all those things. While doing NCERT syllabus, I'll write here only. Mod of x minus 1 plus mod x plus 1. Minus 1 is here, plus 1 is here. X plus 1 becomes 0 at minus 1. X minus 1 becomes 0 at x equal to 1. So minus 1 and plus 1 are the points where the terms inside the mod become 0. Between minus 1 to plus 1 it remains constant. The graph goes like this. It is continuous. It is continuous in the interval minus 1 to plus 1. Nowhere it is discontinuous. You can verify if you want. And it is differentiable in the open interval minus 1 plus 1. This mod x minus 1 plus mod x plus 1 is there. No, it is not differentiable at exactly 2 points. One, it is not differentiable at minus 1. Another one is not differentiable at 1. Anyway, minus 1 plus 1 are excluded here. Correct? Mod x minus 1 plus mod x plus 1 is not differentiable at x equal to minus 1 and plus 1. You must know that. It is not differentiable at x equal to minus 1 as well as plus 1, because at minus 1 and plus 1 the graph has sharp point. At such point the function is not differentiable. So differentiable in the open interval minus 1 plus 1 is possible because minus 1 plus 1 are excluded here. It is continuous in the open interval minus 1 plus 1. It is differentiable in the open interval minus 1 plus 1. What about increasing? In the open interval minus 1 plus 1 it is constant. No, it is not increasing. So option this D can't go to 3. It is not differentiable at least 1 point. That is also not possible. So D can go to 1 and 2. It is continuous in the open interval. It is also differentiable in the open interval minus 1 plus 1. Of course, it is not differentiable at minus 1 plus 1. But in the open interval means minus 1 plus 1 are excluded. So it can go to 1 and 2. D can go to 1 and 2. D goes to 1 and 2. So this is answer. So you have to see which of them is going to match. The strongest one is B. B can go to 1 and 4. B going to 1 is not there. B going to 4 is there. Correct? A going to 2 is there. A can go to 1, 2, 3. A goes to 2 is there. B goes to 4 is there. C goes to 3 and 4 is there. So C goes to 3 is there here. D goes to 1 is there. Option B is the answer. Correct? I have given the solution in detail. Okay? A is here. A can go to 1, 2, 3. B can go to here. B, C, D I have written here. Correct? B can go to 1 and 4. C can go to 3 and 4. D can go to 1 and 2. From this, I can conclude that answer is option B. A goes to 2, B goes to 4, C goes to 3, D goes to 1. Everything is given. In detail, I have written the solution. This is graph of root of mod x. Graph of x plus greatest integer function also you can plot by knowing the graph of greatest integer function. You must know even the concept of continuity and differentiability. Not only the increasing and decreasing function concept, even the concept of continuity and differentiability is required here. Okay. Hope it's clear. Move on to the next one. Maxima and minima. Finding maximum and minimum values of certain functions. I given a table here which is from NCERT book only. I have taken all these functions. So f of x equal to mod x. I can draw the graph if you want. Mod x graph is V-shaped graph. No, it has minimum value 0, but maximum value does not exist because the graph extends indefinitely upwards. Correct? Graph is extending indefinitely upwards. F of x equal to mod x. I'll draw the graph here itself. F of x equal to mod x like this. Graph extends indefinitely upwards. F of x equal to mod x. Therefore, if the graph extends indefinitely upwards, then the function will have minimum value 0, but maximum value does not exist. Hence, maximum value does not exist, but minimum value is 0. For minus mod x, graph of minus mod x I can draw here like this. Graph of minus mod x like this. F of x equal to minus mod x. This graph extends indefinitely downwards. This graph extends indefinitely downwards. So minimum value does not exist and the maximum value is 0. Correct? Maximum value is 0. Next one, f of x equal to x square given. X square graph. X square is like mod x only. X square graph is extending indefinitely upwards like this. Extends indefinitely upwards. F of x equal to x square. F of x equal to x square. Indefinitely upwards. So maximum value does not exist. Minimum value is 0. Correct? Because graph extends indefinitely upwards. So no maximum value. If there's minus x square, graph of minus x square, f of x equal to minus x square, the parabola which is opening downwards, f of x equal to minus x square. This graph also extends indefinitely downwards. So like minus mod x. If it extends indefinitely downwards, the minimum value does not exist. Maximum value will be 0. Okay. And sin x, maximum value is 1, minimum value is minus 1 because the range of sine function is closed interval minus 1 plus 1. If as sin square x, maximum value is 1, minimum value will be 0 for sin square function. That you must know. And 2x minus 1 the whole square plus 3. 2x minus 1 the whole square is similar to the graph of x square. Correct? So minimum value for this will be 0. 0 plus 3, 3. Minimum value is 3. Maximum value does not exist because this graph is similar to graph of x square. 2x minus 1 the whole square means where it is starting, at x equal to half. 2x minus 1 becomes 0 means at x equal to half. The vertex will be at x equal to half. Like this graph of 2x minus 1 the whole square. X square is like this. 2x minus 1 the whole square means at x equal to half the vertex will lie. Correct? So x equal to half is here. Like this. This is graph of 2x minus 1 the whole square. And if you want 2x minus 1 the whole square plus 3, shift it 3 units right side. Okay. So 3 comma 0 will be the vertex for that. So the maximum value does not exist because graph extends indefinitely upwards. And the minimum value of this will be 0, 0 plus 3, 3. And for this function, minus x minus 1 the whole square plus 10. For this function, this is similar to minus x square. See, minus x square, maximum value is 0, but minimum value does not exist. So minimum value for this function does not exist because minus x square graph extends indefinite downwards. Even this graph will extend indefinitely downwards. So no minimum value, but maximum value is 0. 0 plus 10, that is 10. So maximum value is 10. Mod x plus 2 minus 1. It is similar to mod x. Mod x graph extends indefinitely upwards. So no maximum value. Even this function has no maximum value. So maximum value does not exist. Mod function, minimum value is 0. So mod x plus 2 also, minimum value is 0, which occurs at x equal to minus 2. At x equal to minus 2, this becomes minimum, 0. 0 minus 1, minus 1 is the minimum value. This is similar to graph of minus mod x. Minus mod x is here. Minus mod x extends indefinitely downwards. So no minimum value. This function has no minimum value. Maximum value for minus mod x is 0, correct? So maximum value for the 0 plus 3, 3. Sin 2x, a range of sine function is minus 1 to plus 1. Maximum value is 1. So 1 plus 5, 6 is maximum value. Sin 2x, minimum value is minus 1. Minus 1 plus 5, 4, minimum value. Mod x plus 3, maximum value does not exist because extends indefinitely upwards, correct? So no maximum value. Minimum value of mod x is 0. 0 plus 3, 3, minimum value is 3. X plus 1, x belongs to the open interval minus 1 to plus 1. Since the interval is open, the endpoints are excluded. One cannot tell what is the greatest value of x in this interval. One may tell 0.99, another student will tell 0.999, and then the student will tell 0.999999. So we can't tell what is the greatest value of x in this interval. So x is greatest value, one cannot define in this open interval minus 1 to plus 1. So x plus 1 also cannot have a maximum value. X cannot be, x maximum value of x in this interval one cannot tell. Correct? If x belongs to minus 1 plus 1, x plus 1 will belong to 0 to 2. X plus 1 belongs to open interval 0 to 2. So 0 to 2, I can't tell which is the greatest value of the function. Correct? So maximum value does not exist. Even the minimum value does not exist because both the endpoints are excluded. Because both the endpoints are excluded, one cannot tell the maximum value, one cannot tell the minimum value. Both are not possible. And x cube plus 1, the graph of x cube, no, it extends indefinitely upwards, indefinitely downwards. So neither maximum nor minimum. So maximum value does not exist, minimum value does not exist. X cube graph is like this, extends indefinitely upwards, indefinitely downwards. Graph of f of x equal to x cube. This is x tends indefinitely upwards. As x tends to infinity, x cube tends to infinity. As x tends to minus infinity, f of x tends to minus infinity. Maximum value does not exist. Minimum value does not exist. Hope you understand. Sin 4x plus 3, mod of sin 4x plus 3. Start from sin 4x. Sin 4x lies between minus 1 plus 1, correct? Maximum value of sin 4x is 1. 1 plus 3, 4. Mod 4 is 4. Minimum value of sin 4x is minus 1. Minus 1 plus 3, 2. Mod of 2 is 2. So minimum is 2, maximum is 4. Learn this table. At least understand it, okay? So learn the graphs of mod x minus mod x square minus x square, and also the graph of x cube. And also you must know how to shift the graphs. Suppose I give 2x minus 1 whole square or minus of x minus 1 whole square, you must know how to draw the graph. At least you must be able to compare with those four. Those four are elementary. Mod x minus mod x square and minus x square. If you know those graphs, if you understand properly the maximum and minimum value of those four functions, we can get other things. Okay, hope it's clear. I'll be doing the synopsis part of this in detail. Okay, this is just PYQs I've taken. So in synopsis part of every chapter will come. Okay, will be uploaded in the coming days. Move on to the next one. Here the minimum value of 1 minus sin x is asked. 2025 this year. F of x minimum value what? F of x you take, let f of x be equal to 1 minus sin x. Let f of x be equal to 1 minus sin x. You want to find minimum value, so take maximum value of sine function. Because you're writing 100 marks exams, if you do maximum mistakes, you'll get minimum marks, right? If you want to get minimum marks, you do maximum mistakes. You want minimum value of this, correct? You have minimum they ask. You have minimum is 1 minus, take maximum value of sine function. Maximum value of sine function is 1. 1 minus maximum will give minimum. 1 minus minimum will give maximum. Correct? Hope understand. So maximum value of sine function is 1. 1 minus 1, 0. Option B. Very simple question asked in 2025 this year. I am taking maximum value of sine x to get the minimum value because it is 1 minus. 1 minus minimum will give maximum. 1 minus maximum will give minimum, correct, of the function. Hope it's clear. Move on to the next one. Minimum, local minimum value of the function 3 plus mod x. That's not I told. Mod x graph is extends indefinitely upwards, correct? So no maximum value. But minimum value of mod x is 0. 0 plus 3, 3. Local minimum value is also the minimum value of the function, which is equal to 3. Over. 5 seconds enough. Mod x graph is like this. Mod x graph is like this. Mod x. This is graph of mod x. Y is equal to mod x. If you want mod x plus 3, it will be shifted 3 units above the origin like this. Mod x plus 3. This is f of x equal to mod x plus 3. X axis, origin, y axis. This point is 0, 3. X equal to 0, y equal to 3. The vertex. Okay, the lowermost point. So minimum value of mod x is 0. 0 plus 3, 3. F minimum is 3. Correct? F minimum is equal to 0 plus 3 is equal to 3. If you learn this table, it's easy. Already I given that same question here. Correct? Mod x plus 3. Maximum value does not exist. Minimum value is 3. Because minimum value of mod x is 0. It follows from here. Minimum value of mod x is 0, which occurs at x equal to 0. 0 plus 3 equal to 3. Okay? 0 plus 3 equal to 3 is the minimum value. Same question asked in the year 2014. Next we got the first derivative test for local maxima and local minima. If f dash of x changes sign from positive to negative, it is local maxima. F dash of x changes sign from negative to positive, local minima. Correct? So the first derivative test is given. The function should be continuous at the critical point. F dash of x changes sign from positive to negative as x increases through c. Then c is a point of local maxima. F dash of x changes sign from positive to negative, then it is local maxima. If f dash of x changes sign from negative to positive, then it is local minima as x increases through c. If f dash of x does not change the sign as x increases through c, then c is the point of inflection. Point of inflection. Not point of local maxima. Point of inflection. That is by mistake it has come extra sentence. Point of inflection. C is the point of inflection. Okay, learn the first derivative test. For CET level questions, normally we don't apply the first derivative test. Second derivative test is more important. But for JEE level questions, no, normally we apply first derivative test more frequently, more often we apply. Is it clear? Learn the first derivative test for local maxima and local minima. F dash of x changes sign from positive to negative, local maxima. Negative to positive, local minima. And f of c is going to be the local minimum value in this case. Here f of c is going to be the local maximum value. And also given the second derivative test, first derivative should be 0 and second derivative should be negative for local maxima. According to second derivative test, first derivative should be equal to 0 and second derivative should be negative, local maxima. For local minima, first derivative should be equal to 0 and second derivative should be positive. And if f dash first derivative and second derivative both are 0, this test is going to fail. You have to go back to the first derivative test. That's what given. First derivative should be 0 and second derivative is negative, local maxima. And here f dash of c, first derivative is 0 and second derivative is positive, local minimum. Take down problems on this. Find the local maximum value of this function. Already asked 3 times. 1996, 2008 and 2020. Find the critical point of this. Apply quotient rule and get the answer. F dash of x. Applying quotient rule. Denominator square. Denominator square. Denominator keep as it is. Differentiate numerator 1 by x minus log x into derivative of x is 1. Correct? X cancels. What we get is 1 minus log x. 1 minus log x divided by x square. F dash of x. F dash of x equal to 0 to get the critical points. 1 minus log x equal to 0. Numerator by denominator is 0 means numerator should be 0. 1 minus log x should be equal to 0. That means log x equal to 1. Log x equal to 1. That means x equal to e. Convert this log to exponential form. E power 1. Base is not given. Take the base as e. X is e power 1. That is e. X equal to e is a critical point. No need to find the second derivative for competitive exams if you get only one critical point. That's a technique. No need to find the second derivative because they have to find local maximum value. That point should be the point of local maximum because only one point I'm getting, right? So only one critical point you get. At that point, the function should attain the local maximum according to the question. So no need to find the second derivative for competitive exams. For board exams, do all the steps, okay? Because only one critical point I'm getting, x equal to e is a critical point. Convert log to exponential form. Hope you understood how to convert log to exponential form. Log x base e is 1. So x is e power 1. Correct? E power 1 is e. So x equal to e is a critical point. They ask to find local maximum value. F max we can get by putting x equal to e. That is equal to log e divided by e. Put x equal to e in this. Log e means log e base e, which is 1. So 1 by e is the answer. You can remember and write also answer because it is already asked 3 times in the exam, no? So in the PYQs. So if it is asked for next time in 2026, definitely write directly 1 by e is the local maximum value of this function. Correct? So that much of practice is required. Apply quotient rule, denominator square, denominator keep as it is, differentiate the numerator minus numerator keep as it is, differentiate the denominator. X will cancel, 1 minus log x by x square 0, 1 minus log x equal to 0, log x equal to 1, x equal to e power 1 e. So f max is log e by e, which is 1 by e. Option A is the answer. Move on to the next one. F of x is given like this. Is maximum at which point? F dash of x we find out. F dash of x. It's a polynomial function of degree 3. Cubic polynomial is given. Differentiate f dash of x. 6x square minus 30x plus 36. Also find f double dash of x. F double dash of x is 12x minus 30. F dash of x equal to 0. Critical point will get. F dash of x equal to 0. Here 6 is common, right? 6 is common from this. What remains? X square minus 5x plus 6 equal to 0. 6 can't be 0. So terms inside the bracket is 0. X square minus 5x plus 6 equal to 0. So x minus 2 into x minus 3 equal to 0. Correct? Factorizing it. I'll get x equal to 2, x equal to 3 as the critical points. X equal to 2 and x equal to 3 are the points where derivative becomes 0. First derivative is 0. Find out the second derivative. F double dash of 2. When you put x equal to 2, second derivative how much? 12 into 2. 24 minus 30. 24 minus 30, which is minus 6, negative. So x equal to is a point of local maxima, correct? Maximum value occurs at x equal to. At x equal to f as, actually they should have given local maximum value, okay? Earlier they were not distinguishing, not at all distinguishing between the local maximum and maximum value. It is having a local maximum at x equal to, I can conclude, not the maximum value. The function can have more than infinity also. I mean, more than a finite number, correct? I mean, as x tends to infinity, f of x can tend to infinity, correct? So it can go big and big. Don't think that it is having a maximum at x equal to. Maximum means it is the absolute maximum. So should have used the word local maximum value. At x equal to f as local maximum. I'll use the sentence. F as local maximum, because first derivative is 0 and second derivative is negative. So function has local maximum at x equal to, because at x equal to first derivative is becoming 0 and second derivative is negative. So local maxima. If you want, I'll take another critical point, x equal to 3. You have double dash of 3 if you find out. You have double dash of 3. Put x equal to 3. 12 into 3, 36. Correct? Putting x equal to 3 in this. 12 into 3, 36 minus 30, which is equal to 6. Positive. Second derivative is positive. So at x equal to 3, the function has local minima, because second derivative is positive. If second derivative is positive, the function has local minima. If second derivative is negative, local maxima. So at x equal to, the function has local maxima. So local maximum should have been the word there, at x equal to, that is confirmed, because at x equal to second derivative is negative. Condition for local maxima is first derivative should be 0 and second derivative should be negative. And for local minima, first derivative should be 0 and second derivative should be positive. At x equal to 3, the function has local minima. At x equal to, the function has local maxima. Move on to the next one. F of x, the function f of x as, same type of question is asked, correct? 2x cube minus 3x square as minimum at what? As local minimum they should have asked. Dy by dx we find out. Dy by dx. Again, a cubic polynomial is given. Differentiate. 2 into x cube, derivative is 3x square, 6x square. Derivative of 3x square is 6x. Derivative of 12x is 12. Also find the second derivative. D square y by dx square. Second order derivative. This will be 12x minus 6. Now dy by dx equal to 0. You get the critical point. Dy by dx equal to 0. You can take 6 common there. 6 is common throughout. 6 out. What remains? X square minus x minus 2 equal to 0. 6 can't be 0. So x square minus x minus 2 equal to 0. Factorize this. Adding you should get minus 1. Multiplying you should get minus 2. Minus 2 plus 1 will do. Correct? X minus 2 into x plus 1 equal to 0. This will give x equal to 2. X equal to minus 1. Correct? Critical points are minus 2 and minus 1. So either it is option A or option B. These two are ruled out. Option C is not possible. Option D is not possible. Either A or B. Correct? So minus 1 and 2 are the critical points. Find out the second derivative at 2. D square y by dx square at x equal to 2. At x equal to 2. What do you get? Putting x equal to 12 2s are 24. 24 minus 6, which is 18. 18 is positive. Second derivative is positive, means local minima. Correct? At x equal to, the function has local minima. At x equal to, y has local minima. Y has local minima. And you can find out the second derivative at x equal to minus 1 if you want. Minus 1 is the other critical point. At x equal to minus 1, what is the second derivative? 12 into minus 1. Minus 12 minus 6. Minus 18, which is negative. Correct? Second derivative is negative, is local maxima. At x equal to minus 1, the function has local maxima. At x equal to minus 1, y has local maxima. Y has local maxima. At x equal to minus 1, the function has local minima. Correct? Sorry, at x equal to 2. Got x equal to, I am marking it wrong. X equal to, the function has local minima. Local minima at x equal to 2. Hope it's clear. Differentiate derivative of 2x gives 6x square. 2 into 3x square, 6x square. 3 into 2x, 6x. Derivative of 12x, 12. Differentiate again. 12x minus x. dy by dx 0. 6 is common here. Keep outside. X square minus x minus 2 equal to 0. 6 can't be 0. So x square minus x minus 2 0. Factorize it. X minus 2 into x plus 1 0. X equal to x equal to minus 1. X equal to is substitute here. Second derivative is positive. If second derivative is positive, local minima. So local minimum at x equal to. At x equal to minus 1, second derivative is negative. Correct? Minus 12 minus x minus 18. When you put x equal to minus 1, second derivative is negative. So local maxima. X equal to the second derivative is positive. So local minima. They have to find minimum value at x equal to. Answer is option B. On to the next one. The function y is given like this. A polynomial of degree 4 has a minimum at x equal to which value? Differentiate this. Dy by dx. You get a cubic polynomial here when you differentiate this. Dy by dx is 4x cube minus 12x plus 8. Again differentiate. D square y by dx square. D square y by dx square is equal to 12x square minus 12. First derivative equal to 0 you do. 4 is common, correct? 4 you take out. What do you get? X cube minus 3x plus 2, correct? X cube. Sorry. X cube minus 3x. Taking 4 common. Taking 4 common. What do you get? X cube minus 3x plus 2 equal to 0. 4 can't be 0. So terms inside the bracket should be 0. X cube minus 3x plus 2 equal to 0. Correct? By inspection method, it's a cubic equation. No, cubic equation has at most 3 roots. Correct? The first root can be got by method of inspection. By inspection, I can tell x equal to 1 is the root of this. Correct? X equal to 1 satisfies. X equal to 1 satisfies the above equation. If x equal to 1 is a root, no? X equal to 1 is a root means x minus 1 should be the factor by remainder and factor theorem. By remainder and factor theorem, I can tell if x equal to alpha is a root, then x minus alpha should be the factor of that. That is x equal to 1 is a root here. X equal to 1 is a root of this equation. So x minus 1 should be the factor. Implies x minus 1 should be a factor. X minus 1 should be a factor. X minus 1 should be a factor. You divide this entire equation by x minus 1. Take this polynomial and divide by x minus 1. You'll get other factor. X cube plus, I'll write 0x square minus 3x plus 2. And one more interesting thing about the cubic equation is all the 3 roots will be real, or else one root is real, other 2 roots will be imaginary. That's the most important thing about a cubic polynomial, a cubic equation. Cubic equation has at most 3 roots. All the 3 roots can be real number, or else one root will be real, other 2 roots will be imaginary. And you know that imaginary roots always occurs in the conjugate phase. Correct? So x minus 1, I'm dividing it. X to multiply by x square to get x cube. Minus 1 at x square, minus x square. Change the sign. Minus plus cancels. We get x square minus 3x plus 2. X into how much will give x square? X into x gives x square. Correct? Minus 1 into x, minus x. Change the sign. Minus plus cancels. You get minus 2x plus 2. When you multiply by minus 2, you get minus 2x plus 2. Correct? X into minus 2 is minus 2x. And minus 1 into minus 2 is plus 2. Change the sign. Plus minus. Minus 2x plus 2x will add up to 0. 2 plus minus 2 becomes 0. So product of these two will be that. Because I got remainder to be equal to 0. Correct? Remainder is 0. So I am getting the other factor as x square plus x minus 2. X square plus x minus 2 is other factor. So x square plus x minus 2, if we equate it to 0, I'll get the roots as, this I can factorize it as x plus 2 into x minus 1. Correct? 2 minus 1 is 1 and 2 into minus 1 is minus 2. So this will give x equal to minus 2, x equal to 1. X equal to 1 is a repeated root. Here also we got x equal to 1. Here also I'm getting x equal to 1. X equal to 1 is a repeated root and x equal to minus 2 is the other root. Find out the second derivative at x equal to 1 and x equal to minus 2. D square y by dx square at x equal to 1 you find out. What do we get? 12 into 1 square minus 12. Second derivative is becoming 0. That is not the point of minimum. Correct? They are asking the point of minimum. Find out the second derivative at x equal to minus 2. Find out the second derivative at x equal to minus 2. D square y by dx square at x equal to minus 2. At x equal to minus 2. Find out how much we get. 12 into minus 2 square minus 12. Correct? Minus 2 square is 4. 4 into 12 is 48. 48 minus 12, 36, which is positive. Correct? Second derivative is positive. Therefore, the function has minimum at x equal to minus 2. At x equal to 1, the second derivative is 0. If second derivative becomes 0, I can't apply the second derivative test to conclude the maximum or minimum. We have to go back to the first derivative. So, anyway, that's not required for us here. When x equal to minus 2, what happens is 12 into minus 1 square. Correct? If you put x equal to minus 2 in the second derivative, minus 2 square is 4. 4 into 12 is 48. 48 minus 12, 36. Positive. Second derivative is positive. Therefore, it is point of minimum at x equal to minus 2. Function attains minimum value according to the second derivative test. First derivative becomes 0 at x equal to minus 2 and second derivative is positive. So, minimum, the local minimum value in fact occurs at x equal to minus 2. Move on to the next one. Log x by x. This was the question number 4. 5. Take the given function as y. Already we did this type of question. Already. Y is equal to log x by x. Here they are asking it attains the maximum value at which point. So find out the critical point. Dy by dx is find out by using quotient rule. Denominator square. Denominator into derivative of numerator d by dx of log x minus log x into derivative of x is 1. Log x into d by dx of x. Correct? This is equal to x into derivative of log x is 1 minus derivative of log x 1 by x. Derivative of log x is 1 by x minus log x into derivative of x1 divided by x square. Applying quotient rule, denominator square, denominator keep as it is, derivative of log x is 1 by x. X cancels, correct? Log x into derivative of x1. So I am getting 1 minus log x by x square. 1 minus log x divided by x square equal to 0. Numerator by denominator is 0 means numerator should be 0. 1 minus log x equal to 0. 1 minus log x is 0 means log x equal to 1. Log x is 1 means x equal to e. Correct? Only one point I am getting. So this should be the point of maximum. It occurs at x equal to e. Maximum value, the local maximum value occurs at the point x equal to e. At which point the maximum occurs, they are asking at x equal to e. At x equal to derivative is becoming 0. So log x is 1 means x equal to e. Converting log to exponential form. Log x means log x base e. Correct? Log x base e is 1. So x is e power 1. E power 1 is e. So x equal to e is the point of maximum. Next one, the maximum value of 1 by x power x. Question asked 2 times already, 2018 and 2016. So this is variable power variable. Now take log and differentiate. Y is equal to 1 by x to the power x. You can use the formula derivative of u power v. Derivative of u power v is u power v into derivative of v log u, correct? Using this shortcut method. D by dx of u power v. Derivative of u power v is equal to u power v into d by dx of v log u. D by dx of v log u. Using logarithmic difference, we have this. Learn this formula. Derivative of u power v is u power v into derivative of v log u. So dy by dx is equal to dy by dx is equal to what? 1 by x to the power x. Write the same thing. U power v, same thing you write. Differentiate v log u. Derivative of x log 1 by x. D by dx of, bring the power down and take log for this and write x log 1 by x. X log 1 by x. And log 1 by x is minus log x. Correct? This will be equal to 1 by x to the power x into d by dx of what is log 1 by x minus log x. So this becomes minus x log x. Apply the product rule for this. Minus you can keep outside. Minus you keep outside. Minus of 1 by x power x. To differentiate x log x, apply product rule. X into derivative of log x plus log x into derivative of x is 1. Correct? X cancel. Becomes 1 plus log x. 1 by x power x can't be 0. Correct? So 1 plus log x will be equal to 0. I'll get 1 plus log x equal to 0. 1 plus log x is equal to 0 means log x equal to minus 1. Log x equal to minus 1. Convert this log to exponential form. The base is not given means take the base as e. Okay, log x base e is minus 1 means x is equal to e power minus 1. E power minus 1 is 1 by e. X equal to 1 by e is only one critical point I am getting. If you get only one critical point, that should be the point of maximum or the point of minimum. Here the question asks is maximum, so it should be the point of maximum. Correct? Question asked is maximum. You're getting only one critical point. That itself should be the point of maximum. For competitive exams, no need to find the second derivative if you get only one critical point. Okay. Question asks us to find the maximum value of this. You take x equal to 1 by e and substitute here. Y max you want to find out. So at x equal to e, at x equal to 1 by e, the function is maximum. At x equal to 1 by e, because 1 by e is the critical point I got. Correct? This should be the point of maximum. At x equal to 1 by e, y has maximum. And you can find the maximum value. Y max is got by putting x equal to 1 by e in this. Put x equal to 1 by e in this. 1 by e to the power x is 1 by e. What is 1 by e? E power 1 by e. So I am getting the answer e power 1 by e. Option C. Is that clear? Use derivative of u power v formula. Derivative of u power v is u power v into derivative of v log u. And log 1 by x is minus log x. Differentiate this using the product rule. First minus I kept outside. Differentiate this by using product rule. First function keep as it is x. Differentiate log x 1 by x plus second function keep as it is. Differentiate x1. So x will cancel 1 plus log x. Terms inside the bracket should be 0 because this cannot be 0. 1 by x power x can't be 0. So terms inside the bracket should be 0. 1 plus log x equal to 0. Log x equal to minus 1. Convert this log to exponential form. Log x to the base e is equal to minus 1 means x is equal to e power minus 1. E power minus 1 is 1 by e. So put x equal to 1 by e in that. That will be the maximum value. Maximum value is occurring at x equal to 1 by e and y max is got by putting x equal to 1 by in this. 1 by e power 1 by e. 1 by is e. So e power 1 by e is the answer. Option C. 2 times asked already in the exams. 2016 and 2018. Quite important. Move on to the next one. X is real. Then the minimum value of this. We can do it by two methods. One is you can use the differentiation method or else you can complete the square and get the answer. I will do both the methods for your convenience. So for better understanding. Y is equal to take x square minus 8x plus 17. Correct? Differentiate. dy by dx. In fact, it is local minimum value, not the minimum value of the function. 2x minus 8. Correct? I think, yeah, this may become minimum value. Minimum value only. This is correct. Minimum value. 2x minus 8 I am getting. Correct? Derivative of x square is 2x. Derivative of 8x is 8. Minimum value, also the local minimum value. Both can be true here. d square y by dx square. d square y by dx square is equal to derivative of 2x is 2. Positive. Second derivative is positive. It's independent of x. And first derivative equal to 0 you do. We will get x equal to 4. Correct? X equal to 4 is the point of minimum. And minimum value is got by putting x equal to 4 in this. Y minimum equal to. We want to find minimum value. Put x equal to 4 in this. 4 square minus 8 into 4 plus 17. Put x equal to 4 in this. Correct? 4 square is 16 minus 32 plus 17. 17 plus 16, 33. 33 minus 32, 1. So minimum value of the function is 1. Otherwise, another method if you want, I can complete the square for that. Second method. Given is a quadratic polynomial, so I can complete the square there. Y is equal to x square minus 8x plus 17. Correct? Coefficient of x square is already 1, unity. Correct? So you see the coefficient of x. Coefficient of x is minus 8. Take half into coefficient of x. Half into minus 8 is minus 4. Complete the square for this. X minus 4 the whole square. And constant term we should write as it is. And you have to subtract square of this. 4 square is 16. Correct? So this is half into coefficient of x. While completing the square, that's a method. Even in integration also we learned. Correct? How to complete the square. Coefficient of x is minus 8. Take half into minus 8. Half into minus 8 is minus 4. Constant term keep as it is. 17. And you have to subtract square of this. 4 square is 16. correct? So I'm getting this as x minus 4 the whole square plus 17 minus 16 is 1. You know, minimum value of x square is 0. So minimum value of x minus 4 whole square is 0. 0 plus 1 is 1. X square graph, you know, the parabola which is opening upwards, correct? Vertex at origin for x square. X minus 4 the whole square will have the vertex at 4, 0. So minimum value of x square function is 0. So minimum value of x minus 4 the whole square is 0. 0 plus 1 is 1. So y minimum is, this will become 0, minimum value, plus 1. Minimum value occurs when x equal to 4. Where it occurs minimum at x equal to 4. Same thing we got. See, minimum value occurs at x equal to 4. Minimum value occurs where the terms inside the bracket is becoming 0. So y minimum is 1. Any method we can do, either by completing the square and comparing with the graph of x square and get the minimum value, or by using the derivative test we can get the value. Answer is 1. Question asked in the year 2015. Move on to the next one. The maximum value of the function f of x equal to x power 1 by x. Here x power 1 by x is asked. Earlier it was 1 by x power x. This was 1 by x power x. See, almost same type of questions are asked. So if you study PYQs, you'll get a better practice always. F of x is given as x power 1 by x. This is variable power variable. So you should take log and differentiate. Or I can use the shortcut method. Derivative of u power v is u power v into derivative of v log u. Correct? F dash of x is same thing you write, x power 1 by x into d by dx of, bring the power down 1 by x into log x. Apply log to the base. Correct? This is equal to x power 1 by x into, here apply the product rule. To differentiate 1 by x into log x, you apply product rule, UV rule. First function keep as it is, differentiate log x 1 by x, plus second function keep as it is, correct? Derivative of 1 by x is minus 1 by x square. We can take 1 by x square common, equal to 0 you do, to get the critical point, f dash of x equal to 0. What we can do here, 1 by x square is common. So x power 1 by x into 1 by x square is common. So what remains is 1 plus into minus is minus log x equal to 0. 1 by x square can't be 0. X power 1 by x can't be 0. So 1 minus log x should be 0. 1 minus log x equal to 0 means log x equal to 1. Log x equal to 1 means x equal to e, because log e is 1. Or else you can convert this log to exponential form. You get x is equal to e power 1, which is equal to e. X equal to e or e power 1 I am getting. So only one critical point they get. No need to find the second derivative for competitive exams. So that should be the point of maximum. Because they ask maximum value, that should be the point of maximum. Which one? The critical point which you got. So x equal to, you substitute in the given function, you get the maximum value. F max is equal to, F max is got by putting x equal to e. X equal to e we got, substitute e power 1 by e. So e power 1 by e. That's the answer. Option B. Variable power variable, derivative of u power v formula. U power v, write the same thing into derivative of v log u. Hope you understand. Derivative of 1 by x to bring down, take log for this base and write. Differentiate this by using the product rule. First function keep as it is, derivative of log x 1 by x plus log x. Second function keep as it is, derivative of 1 by x is minus 1 by x square. 1 by x square is common, so what you get is 1 minus log x. This can't be 0, so terms inside the bracket equal to 0. Log x equal to 1, so x equal to e power 1. If you take the base as e, I can write x equal to e power 1. If no base is given, take the base as e. E is a standard base for log, okay? So whenever the base is not mentioned, it's understood that the base is e. So log x base e is equal to 1 means x is e power 1. E power 1 is e. Because only one critical point we get, that should be the point of maximum. No need to find the second derivative for competitive exams. Because only one critical point we get means that itself should be the point of maximum, because question asked is maximum value. So put x equal to e and write here in the given function. E power 1 by. Option B is answer. Question asked in the year 1999. Move on to the next one. Maximum value of x into e power minus x. Take the given function as y. Okay. Apply product rule and get the answer. Let y is equal to x into e power minus x. Question asked in the year 2012. Differentiate this by using product rule. dy by dx. dy by dx is equal to. First function keep as it is. Derivative of e power minus x, e power minus x into minus 1 plus second function keep as it is, differentiate x1. Correct? We can take e power minus x common. E power minus x common. What remains is minus 1 into x, minus x plus 1 equal to 0. correct? Dy by dx equal to 0 I'll do. Exponential function can't be 0. E power minus x never becomes 0 for any real x, as e power minus x is not equal to 0 for all x belongs to R. Terms inside the bracket should be 0, correct? Minus x plus 1 should be 0. Minus x plus 1, 0 means x is equal to 1. X is equal to 1 is the critical point, correct? So only one critical point again. That should be the point of maximum. So y max is got by putting x equal to e. Therefore, x equal to 1, y is maximum. Because only one critical point we get, as I told so many times in the previous questions also we did the same thing, correct? If we get only one critical point, that itself should be the point of maximum. The question asked is maximum. If you get only one critical point, that itself is the point of minimum. If the question asks minimum, okay, so that second derivative is not required. If you get two critical points, then we can't tell which is maximum or minimum. In that case, I should go for second derivative test. If second derivative is positive, local minima. If second derivative is negative, local maxima. But here not required all those things. So directly let x equal to 1, y has maximum. In fact, it is local maximum value, but they asked as a maximum value. So y max we can find out by putting x equal to y max is equal to let x equal to 1. Put x equal to 1 and write 1 into e power minus 1. E power minus 1 is 1 by e. So 1 by e is the maximum value of the function. In fact, it is local maximum value occurs at x equal to 1. And the local maximum value is 1 by e. Got by putting x equal to 1. 1 into e power minus 1. E power minus 1 is 1 by e. Option B. Question asked in the year 2012. Move on to the next one. Question number 10. F of x is given as 2x plus cos x. The function f is what? F dash of x we find out. F dash of x. Derivative of 2x is 2. Derivative of cos x is minus sin x. Correct? This 2 minus sin x, now it is always positive. It cannot be negative. Greater than 0 only for all x belongs to R. So therefore, function is increasing function. F is an increasing function because derivative is always positive. 2 minus sin x can never become 0 because maximum value of sine function is 1. If you take maximum value of sine function 1, 2 minus 1 is 1. If you take minimum value of sine function minus 1, 2 minus minus 1, 2 plus 1, 3, correct? Positive only. It can't become negative. If you take sin x equal to 0, 2 minus 0, 2 positive. So because sin x lies between minus 1 and plus 1, as you know, sin x lies between minus 1 plus 1 including the endpoints for all x belongs to R. Even minus sin x also lies between minus 1 and plus 1. Multiply by minus 1, inequality is going to reverse. Minus 1 becomes plus 1, plus 1 becomes minus 1. Inequality reverses. Add 2 for all. If you add 2, 2 plus 1, 3, greater than or equal to 2 minus sin x is greater than or equal to. Add 2 for this. 2 minus 1 is 1. So 2 minus sin x lies between 1 and 3. Correct? 1 and 3. That means it is always positive. It's definitely greater than or equal to 1 and I can tell it is greater than 0. So function is increasing. In fact, it is strictly increasing function. It's given as increasing. So answer is option D. Question asked in the year 2002. Hope it's clear. Move on to the next one. Next we have stationary points. As I told, for a given curve y equal to f of x, if f dash of x equal to 0, such points are called as stationary points. Critical points and stationary points not exactly one and the same. Okay, for stationary points the condition is f dash of x equal to 0. For every stationary point, no, the tangent drawn will be parallel to x-axis. At the stationary point, the tangent drawn will be parallel to x-axis. And every stationary point is also a critical point, correct? And every critical point need not be a stationary point. This I told earlier also, correct? For stationary point, f dash of x equal to 0. If f dash of x equal to 0, it can also be the critical point. Stationary point, every stationary point is a critical point. But every critical point need not be a stationary point. Because critical point means what? F dash of x equal to 0 is possible. Also f dash of x not defined possible. Correct? So critical point, every critical point need not be a stationary point. Whereas every stationary point is a critical point. So that's an important note. Okay? And at the stationary point, the tangent is parallel to x-axis. Get a horizontal tangent. Something like this. At the stationary point, we have like this. The tangent is parallel to x-axis. At the stationary point, f dash of x will be equal to 0. F dash of x equal to 0. The tangent is parallel to x-axis. Every stationary point is a critical point. But every critical point need not be a stationary point. The point to be noted so that I can distinguish between what is a stationary point and a critical point. I think we got some problem. One problem is that on a stationary point, f of x equal to x power x has a stationary point at which value of x they ask. F of x is x power x. Derivative of x power x is what? Derivative of x power x is x power x into 1 plus log x. Second time using this. So quite important from logarithmic differential. Please learn that. Derivative of x power x is x power x into 1 plus log x. For stationary point, f dash of x should be equal to 0. Correct? For stationary point, f dash of x should be equal to 0. For stationary point, what is the condition? F dash of x is equal to 0. F dash of x is what? X power x into 1 plus log x. X power x into 1 plus log x equal to 0. X power x can't be 0. So 1 plus log x should be 0. 1 plus log x equal to 0 means log x equal to minus 1. Log x equal to minus 1 means x equal to e power minus 1. Log x is minus 1 means x is equal to e power minus 1. E power minus 1 is 1 by e. X equal to 1 by e is a stationary point for this. Question asked in the year 2018 as well as 1993. Okay. Convert log to exponential form. 1 plus log x equal to 0. Terms inside the bracket should be 0. So log x equal to minus 1. X is e power minus 1. So log x base a equal to b means you must know how to convert. Log x base a is equal to b means x is equal to a power b. Learn this conversion. Okay. X is a power b. For a is not equal to 1 and a is positive. X should be positive. Base is never equal to 1. Base of the log is never equal to 1. Okay. X should be positive. A is positive and a is not equal to 1. Log x base a equal to b means x is equal to a power b. So log x base e is minus 1 means x equal to e power minus 1. E power minus 1 is 1 by e. So x equal to 1 by e is a stationary point. Learn all these things properly. Okay. Important. Next we got point of inflection. Many of them have a doubt on point of inflection and there is confusing point also. This is point of inflection. It's not very clear from the NCERT book. I'll give some examples to make it clear what is point of inflection. I'll be explaining in detail in synopsis. Okay. This is I'm just doing the PYQs. So along with PYQs I've taken the concepts also so that it becomes easy for you to understand. So I'll be doing complete synopsis of all the chapters for KCET. Okay, please go through that. Okay, please watch the videos so that it will be helpful for even for teachers also how to teach. That is also there, and for students also it's beneficial. So listening to my classes definitely will be benefited. Okay, so what is point of inflection? First of all, you must note that if a function f has neither maximum nor minimum, such a point is called as point of inflection. Okay. So point of inflection means the point where the function is neither maximum nor minimum. That is first thing you must know. And another thing is that how to find the point of inflection for a given curve. They can give various curves like x cube, sin x, cos x. Any curve can be given to you. X mod x. I'll explain all those things. What is point of inflection by taking graphical approach. Okay. And one more thing is that the derivative test. You must know in terms of derivatives. Second derivative is important here. Second derivative, if it changes sign from positive to negative or negative to positive. In that case, we tell at x equal to that point, x equal to c, where it is changing the sign. Second derivative sign changes from negative to positive or positive to negative. At that point is called as point of inflection. So second derivative sign matters here. If it second derivative sign changes from negative to positive or positive to negative, then we can tell the function has at that point the point of inflection. Okay, to make it clear I'll take some examples. F of x equal to x cube I'll take. If you take f of x equal to x cube graph, f of x equal to x cube is what? F dash of x is what? 3x square, correct? Derivative is 3x square and double differentiate. F double dash of x, f double dash of x is 6x, correct? Here if you take f double dash of 0 plus means slightly greater than 0, small positive value will be positive, correct? Second derivative will be positive here. Second derivative is going to be positive. F double dash of 0 plus is positive. Means you take a value of x slightly greater than 0. Say 0.1, you take 6 into 0.1 is going to be positive. If you take your double dash of 0 minus, 0 minus means what? Slightly less than 0, negative value. In that case, second derivative is going to be negative. 6 into minus 0.1, negative. 6 into 0.1, positive. So at x equal to 0, what happens? Second derivative sign changes from, see, from less than 0 to greater than 0 will come. Less than 0 to greater than 0. In that case, what happens? The second derivative sign changes from negative to positive. As x passes through 0, second derivative sign changes from negative to positive. So x equal to 0 is a point of inflection. If you take on the other hand f of x equal to sin x, f of x equal to sin x, we should take. Derivative of sin x is cos x. You have dash of x. Derivative of sin x is cos x. Again differentiate. You have double dash of x. Derivative of cos x is minus sin x. Correct? If you take 0 plus means slightly greater than 0, positive value. Okay, say 0.1. Sine of 0.1, it is very close to 0 and positive. So minus sine 0.1 is negative. So you have double dash of 0 plus is going to be negative. And you have double dash of 0 minus. 0 minus means slightly less than 0, minus 0.1. Sine of minus 0.1 is minus sine 0.1. And minus into minus becomes plus. Correct? Minus sine of minus 0.1. Put x as minus 0.1 here. Sine of minus 0.1 is minus sine 0.1. Minus into minus plus sine 0.1. It becomes positive. Correct? This is going to be positive. Second derivative for this case will be positive. So as x passes through 0 from negative to positive, as x increases from negative to positive, second derivative sign changes from positive to negative. Correct? So the function is going to have point of inflection at x equal to 0. This happens not only at x equal to 0, at x equal to pi, 2 pi, 3 pi, minus 2 pi, everywhere it happens for sine curve. So for sine function, the point of inflection is at x equal to n pi. Okay? I'll take f of x equal to x mod x if you want. F of x equal to x mod x. We'll take the graph of x mod x. X mod x is what? Mod x means I should discuss two cases. X less than 0 and x greater than or equal to 0. Two cases. Correct? X greater than or equal to 0 and x less than 0. X greater than or equal to 0. For x less than 0, mod x will be minus x. X into minus x becomes minus x square. And if x greater than or equal to 0, mod x becomes x. X into x becomes x square. So find out f dash of x. F dash of x is equal to how much? Derivative of minus x square, minus 2x. Derivative of x square, 2x. This is for x less than 0. And this is for x greater than or equal to 0. Find out f double dash of x. F double dash of x will be what? Second derivative is minus 2 for negative values. And for positive values, second derivative will be 2. Correct? I'll write here. F double dash of x. F double dash of x. Derivative of minus 2x is minus 2. This is for x less than 0. Derivative of 2x is 2. This is for x greater than or equal to 0. So in the neighborhood of x equal to 0, as x is passing through the point 0 from negative to positive, second derivative sign changes from negative to positive. Correct? So therefore x equal to 0 is a point of inflection for x mod x. Like that you can take f of x equal to cos x. Derivative of cos x minus sin x. Derivative of minus sin x is minus cos x. Minus cos x, where the sign changes you should see. In the neighborhood of x equal to pi by 2 you can take. Less than pi by 2, if you take, cos function is positive. Greater than pi by 2, cos function is negative. Correct? There also second derivative sign changes. Not only at pi by 2, at 2n plus 1 pi by 2, the cos function has point of inflection at x equal to 2n plus 1 pi by 2. For sine function, point of inflection is n pi. And for cos function, it is 2n plus 1 pi by 2. All those things you must know. Okay, so point of inflection is explained where the second derivative sign changes from. You have double dash of x changes sign from positive to negative or changes the sign from negative to positive as x passes through C. Such a point C is called as point of inflection. At the point of inflection, the function has neither maximum nor minimum. And also I can tell from the graph, no, it is changing its concavity, concave up and concave down. That also is words are used. Concavity also words are used. The f of x equal to x cube graph, no, right side of 0, it's concave up. Left side of 0 is concave down, correct? Concave up and concave down. Such words are also used. Okay, so this is about examples for x cube and sin x are given. Okay, x cube has point of inflection. I can write the function f of x and the point of inflection. Few of them I'll mention here. X cube, sin x, cos x, and I'll mention x mod x. X cube has point of inflection at x equal to 0. And for x mod x also. X mod x also, the point of inflection is at x equal to 0. Next I can take f of x equal to sin x. Sin x has point of inflection at x equal to n pi, correct? That is what we got. N pi was the point of inflection. X equal to n pi, where n belongs to z. For cos x, the point of inflection is x equal to 2n plus 1 pi by 2. 2n plus 1 pi by 2. N belongs to z. Okay. These are the important curves. I have written the point of inflection, where the sign changes, where the second derivative sign changes. More examples I can give in the synopsis, complete synopsis of this chapter. Okay. With the examples I'll be doing the complete synopsis. Also I'll be solving the NCERT exam, that book. Entire chapter I'll be solving. Okay. So please make a note of this. And there are a few questions based on this. One asked in the year 2024. This question I have taken in point of inflection because it becomes like that. So I have taken. In the exam we can't make out whether it is point of inflection or minima or maxima or not a critical point, correct? So f dash of x will find out here. F dash of x. Differentiate this. Derivative of x cube, 3x square. Derivative of 6x square, that is 12x. Derivative of 12x is 12. Derivative of 3 is 0. Find out f double dash of x. Second derivative is 6x minus 12. F dash of x equal to 0 to get the critical point for this. 3 common here. X square minus 4x plus 4 equal to 0. 3 can't be 0. So terms inside the bracket should be 0. X square minus 4x plus 4 equal to 0. X square minus 4x plus equal to 0 means x minus 2 the whole square equal to 0. X minus 2 the whole square equal to 0 means x minus 2 equal to 0. So x equal to 2. That's a critical point. They told x equal to is not a critical point. That's not possible. X equal to is of course a critical point. E is a critical point. Correct? X equal to E is a critical point. They told it is not a critical point. That is false. Option C is not correct. Correct? X equal to is not a critical point. It is false. X equal to is a critical point because derivative is vanishing at x equal to. But derivative vanishes means it should be a critical point. Derivative is not defined also, it's a critical point. Stationary point means derivative equal to 0 only. Okay. So difference is there. Now you see at x equal to f double dash of 2 plus 2. F double dash of 2 plus you find out. F double dash of 2 minus you find out. 2 plus means what? Slightly greater than 2. Slightly greater than 2.1 you take. 6 into 2.1. 6 into 2.1 is 12 point something. 12 point something minus 1 is positive. If you take 2 minus means what? Slightly less than 2. Slightly less than 2, 1.9. 6 into 1.9. 6 into 1.9 will be less than 12. Less than 12 minus 12 is negative. So second derivative sign changes as x passes through 2 from x less than 2 to x greater than 2. Derivative sign changes from negative to positive. Therefore, the function has point of inflection. At x equal to, the function has point of inflection. If you find f double dash of 2, it is equal to 0. See, if you have double dash of 2, if you put x equal to 2 here, 6 into 2, 12, 12 minus 12, 0. Second derivative becomes 0 means what? We can't conclude, correct? The second derivative test is going to fail there, correct? So, it's a point of inflection is confirmed from this by using the second derivative sign changes from negative to positive as x increases through 2. As x increases through 2, second derivative sign changes from negative to positive. So x equal to is a point of inflection. Option B is answer. Move on to the next one. A point of inflection asked in the year 1992. So long back, see, point of inflection was asked there. Y equal to e power minus x square curve. Y equal to e power minus x square. Find out the second derivative for this. dy by dx equal to. dy by dx equal to. Derivative of e power x is e power x. Derivative of e power minus x square. E power minus x square into derivative of minus x square, which is minus 2x. Correct? Derivative of e power minus x square. E power minus x square into derivative of minus x square, which is minus 2x. Now I need to find the second derivative. Equal to 0 if you do, I'll get the critical point here, correct? Exponential function cannot be equal to 0, so x should be equal to 0. X equal to 0 I'm getting, correct? Now, find out the second derivative. Find out the second derivative, d square y by dx square. D square y by dx square. X equal to 0 is the point of, it's a critical point actually, correct? Now, find out the second derivative from this. Minus 2 you can keep outside. Minus 2 you can keep outside. Apply the product rule for this. First function keep as it is. Derivative of e power minus x square. E power minus x square into derivative of minus x square minus 2x plus second function keep as it is. Differentiate x1. From this e power minus x square common. Minus 2 into e power minus x square out. What remains is 1 minus 2x square. Correct? 1 minus 2x square. This will become 0 at x equal to plus or minus 1 by root 2. Correct? If you do second derivative equal to 0, I will get the condition that x square is equal to, if you take terms inside the bracket equal to 0, x square equal to 1 by 2. So I will get x equal to plus or minus 1 by root 2. Correct? So 1 by root 2 is there, even minus 1 by root 2 is there. Two values are there. So I need to find which is going to be the point of inflection at x equal to 1 by root 2 or at x equal to minus 1 by root 2. If you take the second derivative if you take d square y by dx square at x less than x tends to 1 by root 2 minus 1 by root 2 minus, okay. If you take a value of x less than 1 by root 2, x square will be less than half, correct? Less than half it will be. Or you take x tends to minus 1 by root 2. In that case also I'll get the same thing, correct? X equal to 1 by root 2 or minus 1 by root 2. In both the case, x square is going to be positive only. But it is going to be less than half here. If you take less than 1 by root 2 or you take less than minus 1 by root 2, x square will be less than half. 2 into less than half will be less than 1. 1 minus less than 1 is positive. This will be positive. And same way find out d square y by dx square. D square y by dx square for x tends to 1 plus 1 by root 2 plus. If x is slightly greater than 1 by root 2 or if x is slightly greater than minus 1 by root 2, in both the case x square will be greater than half. So 2 into x square will be greater than 1. 1 minus greater than 1 is negative. Negative into negative is positive. Here it is negative actually. This sign also I should consider. No, that will be negative there. Because outside there is negative. Correct? Outside there is one negative sign. This negative also I should consider. This is anyway positive. Exponential function is always positive. For x tends to 1 by root 2 minus or x tends to minus 1 by root 2 minus, in both the case, this quantity is going to be negative. Negative into negative is positive. Sorry. What I said? This will be negative. Oh, sorry. 1 minus 2x. X square will be less than half. X square less than half is 2 into half. That is 2 into less than half will be less than 1. So positive. Positive into negative is negative. And this will be positive. Correct? This will be positive. This will be positive. Because x greater than 1 by root 2. X square is greater than half. X square greater than half is 2 into x square will be greater than 1. So 1 minus greater than 1 is negative. Negative into negative is positive. So the second derivative sign changes from negative to positive. Correct? For x tends to 1 by root 2 or even x tends to minus 1 by root 2. That I not indicated here. Okay? Or I'll write here minus 1 by root 2 minus in both the case. Or 1 by root 2 minus 1 by root 2 plus in both the cases. So x equal to 1 by root 2 and minus 1 by root 2. Both are a point of inflection here. But when x is 1 by root 2, what we get? When x equal to 1 by root 2, what is the value of y? Value of y is how much? Y is equal to e power minus x square, correct? So x square will be half. For x is 1 by root 2, x square is how much? Half. So e power minus half. E power minus half is 1 by e power half. So 1 by root t. So 1 by root 2 comma 1 by root t is the answer. 1 by root 2 comma 1 by root t is the answer. If you take x equal to minus 1 by root 2, that is also the point of inflection actually. x equal to minus 1 by root 2. I'll get y is equal to e power minus 1 by root 2 square is half. So e power minus half, that will be 1 by root e. Correct? Both are 1 by root e only, y value. But x value is 1 by root 2 and y value is 1 by root e. 1 by root 2, 1 by root e is possible, or minus 1 by root 2, 1 by root e. That is not given in the options. Correct? X is minus 1 by root 2, y equal to 1 by root e is not found. So answer is option C. Both x equal to 1 by root 2 and minus 1 by root 2 are the points of inflection. And the corresponding value of y for x equal to plus or minus 1 by root 2 is 1 by root e. Minus 1 by root e is not possible, correct? Y value can't be negative. Y value is 1 by root e only. Y has only one value for two different values of x. So answer is option C. Question asked in there 1992 on point of inflection. Move on to the next one. Function f of x is given like this. The point x equal to pi by 6 is what they are asking. So find out f dash of x and f double dash of x. Derivative of root 3 sin x is root 3 cos x. Derivative of 3 cos x is minus 3 sin x. Correct? F double dash of x. F double dash of x is put x equal to differentiate this. Derivative of root 3 cos x minus root 3 sin x. And derivative of 3 sin x is 3 cos x. Also, they give in some books, they given third derivative equal to 0 and second derivative not equal to 0 is a point of inflection. Okay, that is not stronger actually. But x mod x, if you take, it fails. X mod x, if you take, it is going to fail. Second derivative is not becoming 0. Correct? Some conditions are given like that. Second derivative is equal to 0 and third derivative is not equal to 0. Something like that it is given. Okay? That condition fails for x mod x. So I don't apply that for point of inflection. If you want, you can verify that condition using this. For this case, x equal to pi by 6 you can put here in second derivative. Second derivative is not equal to 0 I am getting. Correct? So it's a point of, it's neither a point of local maxima nor a minima, I can conclude I think. Second derivative is equal to 0. Does it become 0 here? F double dash of pi by 6. F double dash of pi by 6. Second derivative is not equal to 0. Correct here? Here I am getting second derivative is not equal to 0. Does it become a point of inflection? See, when you put x equal to pi by 6, sin pi by 6 is half. Correct? Cos pi by 6 is root 3 by 2. Second derivative is, here it's negative. Whether first derivative becomes 0 at x equal to pi by 6, check. Here f dash of pi by 6 how much? F dash of pi by 6 root 3 into cos pi by 6. Cos pi by 6 is root 3 by 2. Correct? Minus 3 into sin pi by 6 is half. So this becomes root 3 into root 3, 3 by 2 minus 3 by 2, 0. Correct? First derivative is 0. And second derivative is how much I am getting? This is minus root 3 by 2 minus 3 root 3 by 2. Which is negative I can tell. Correct? It's a negative value. Second derivative is negative and first derivative is 0. So it should be the point of local maxima. Correct? Second derivative is negative. So local maxima. It's not a question on point of inflection, but I have included in the section of point of inflection because I attempted by seeing that option, point of inflection. So I included in this, but it is not a point of inflection. Because when you put x equal to pi by 6 here, root 3 into cos pi by 6 minus 3 sin pi by 6. Cos pi by 6 how much? Root 3 by 2. Sin pi by 6 half. Root 3 into root 3, 3 by 2 minus 3 by 2, 0. At x equal to pi by 6, first derivative is 0. And second derivative is how much? Correct? No, derivative of root 3 cos x is minus root 3 sin x. Differentiate root 3 sin x, root 3 cos x. 3 into derivative cos minus sin. Double differentiate root 3 into minus sin x. Minus 3 cos x. When you put x equal to pi by 6, sin pi by 6 half. Cos pi by 6 root 3 by 2. Minus root 3 by 2 minus 3 root 3 by 2 becomes minus, you can take common there, minus 4 root 3 by 2, which is negative. Second derivative is negative is local maxima. X equal to pi by 6 is the point of local maxima. If second derivative is positive, local minima, we know that. Conditions for local maxima and local minima. So it's not a point of inflection, but in some books the given condition for point of inflection as second derivative is equal to 0 and third derivative is not equal to 0. That becomes a weaker condition sometimes, okay. In x mod x it fails. I already told about x mod x, so I won't be using that kind of definition. I am using that second derivative sign changes from either negative to positive or second derivative sign changes from positive to negative to have a point of inflection, okay. That condition is going to be much stronger. Move on to the next one. Clear, no? Point local maximum because second derivative is negative. Next one, there is some word problems here. An enemy fighter jet is flying along the curve y equal to x square plus 2. A soldier is placed at the point 3, 2, wants to shoot down the jet when it is nearest to him. Find the nearest distance asked in the year 2023. Draw the figure for this. Y equal to x square plus 2 is a parabola. You can draw the curve. Draw the curve. Y equal to x square plus 2. Enemy fighter jet is flying along the curve. So jet is flying along the curve y equal to x square plus 2. Y equal to x square is a parabola. Correct? X square equal to y. Y equal to x square plus 2 means shifted 2 units above the origin. Y equal to x square is the parabola symmetric with respect to y axis like this. X square plus 2 is shifted 2 units above the origin. Y equal to x square plus 2, shifted 2 units above the origin. A soldier is placed at the point 3, 2. Soldier is placed at the point 3, 2. 3, 2 does not lie on the curve, no? 3 square is 9, 9 plus 2, 11, so does not satisfy. 3, 2 is somewhere here. 3, 2 is here. 3, 2, rough sketch. Soldier is placed at the point 3, 2. Yes, I'll call. Soldier is yes. At the point 3, 2. Wants to shoot down the jet when it is nearest to him. Find the nearest distance. To find the nearest distance. Find the nearest distance. Okay. So you can take the point P as x, y. Point P as x, y. This need not be perpendicular. Okay. P x, y I'll take. Let P x, y be any point on the curve. Distance between the point P and S should be minimum. Let P x, y be any point on the curve. P x, y be any point on the curve. Be any point on the curve. Y equal to x square plus 2. Want to find the distance between S and P should be minimum, correct? And you have to find the nearest distance. So SP should be minimum. Soldier is placed at the point. Soldier is placed at the point 3, 2. Soldier is placed at the point yes 3, 2. So SP you find out. The minimum distance you have to find out. SP. Apply distance from the root of x minus 3 the whole square. SP's or PS both one and the same. X minus 3 the whole square plus y minus 2 the whole square. SP square you do. SP square. Squaring this. What do you get? X minus 3 the whole square plus y minus 2 the whole square. What is y minus 2 from the given curve? Y is x square plus 2, no? So y minus 2 is x square from this. Y minus 2 is equal to x square. That I am going to substitute here. This will call it as a d square. D square you call it as z. That will be equal to what? X minus 3 the whole square plus y minus 2 is x square. X square square x power 4. Correct? So what we get? Z is equal to what we have? X minus 3 the whole square plus x square is x power 4. Differentiate with respect to x. dz by dx. Derivative of x minus 3 the whole square is 2 times x minus 3 into derivative of x minus 3 is 1. Derivative of x power 4 is 4x cube. First derivative equal to 0 we shall do. Also we'll find the second derivative d square z by dx square. d square z by dx square 2 into derivative of x minus 3 is 1. Derivative of 4x cube 4 into 3x square 12x square. First derivative equal to 0 I do. To get the critical points you can divide by 2 and write. If you divide by 2 and write what do you get? 2x cube correct plus x minus 3 equal to 0 dividing by 2 and writing. This is satisfied for x equal to 1 right? X equal to 1 is the point which satisfies this. I am dividing by 2 and writing so 2x cube plus x minus 3. Clearly x equal to 1 satisfies this. Clearly x equal to 1 is a root of the above equation. Correct? X equal to 1 is a critical point. So find out the second derivative for x equal to 1. d square z by dx square at x equal to 1 is going to be 14. 2 plus 12. Correct? 2 plus 12 into 1 square which is 14 positive. So second derivative is positive, therefore it is minimum, it's confirmed, correct? So distance becomes minimum, and also I can quote that d is minimum if and only if d square is minimum. So d and d square will happen to be minimum at the same point, in the same critical point. So that is possible. So x equal to 1, distance becomes least. So d minimum I can find out, that is the nearest distance. Nearest distance is SP, we have to minimize SP. The shortest distance between the point P on the curve and the soldier you have to find out, that is the shortest distance. So d minimum we can find it by putting x equal to 1 in this. D minimum is got by putting x equal to 1. So put square root for this and write d minimum is got by putting x equal to 1 in this. In this you take square root in this equation, you take square root and write because z is d square, d is root of this. Put x equal to 1 here, what do you get? Root of 1 minus 3 the whole square plus 1 power 4. Correct? 1 minus 3 is minus 2. Minus 2 square 4. 4 plus 1 is 5. So d minimum is root 5. Root 5 is the answer. Hope it's clear. Same type of question is found in the NCERT book also. Solved example is there. And Apache helicopter of enemy, something like that is there. Same type of question. Okay. So it's a concept of maxima and minima here. Word problem. Another question is given here. A point on the curve y square equal to 4x, which is nearest to the point 2, 1 is asked in the year 2000. We can verify using options also, or else how I did this question, same way I can do. Take a point on the curve and the distance between the point and the curve and the given point should be minimum. Same way you can do. Take px, y be any point on the curve. Px, y be any point on y square is equal to 4x. Be any point on the curve y square is equal to 4x. And this is a given point. Q 2, 1 is the given point. You have to find PQ. PQ minimum is how much? You have to find out. PQ, that is called D. PQ is what? Root of, we can use distance formula, root of x minus 2 the whole square plus y minus 1 the whole square. You can verify using options also, that is also there. I am doing the actual method, x minus 2 the whole square plus y minus 1 the whole square. Root of x is, I will eliminate one of the variable here, y square is 4x, no? So x is y square by 4, correct? Y minus 1 the whole square is it. X minus 2 the whole square plus y minus 1 the whole square. You can expand it otherwise. If you expand this, what you get? X square plus 4 minus 4x. Here y square, x is y square by 4, that is okay. Expand it. Y square plus 1 minus 2y, correct? So we get this equal to root of x square plus y square minus 4x minus 2y plus 5, correct? 4 plus 1, 5. Y square is x. Y square is x. We can do squaring on both sides. D square will be d square is equal to what? Without root L, right? X square plus y square minus 4x minus 2y plus 5. What is x? X is y square by 4. Otherwise, I'll write for x only. That is better for us. This is not required. X is y square by 4. Correct? X is y square by 4. So, x square will be y power 4 divided by 16 plus y square minus 4 into 4x is y square, no? 4x is y square. 4x is nothing but y square. Y square minus 4x will become 0 otherwise, correct? Minus 2y plus 5. Differentiate this. This we call it as z. Differentiate this with respect to y. dz by dy. Differentiating with respect to y. These two will add up to 0 here. Derivative of y power 4 is 4y cube divided by 16. Derivative of 2y is 2 equal to 0. What do you get? Y cube divided by 4 minus 2 equal to 0 or equal to 2. So y cube is equal to 8. Y cube is equal to 8 means y is equal to 2. When y is equal to 2, find out x equal to how much? Also second derivative you can calculate. D square z by dy square. Second derivative is 4 by 16 is 1 by 4. 1 by 4 derivative of y cube is 3y square. So 3y square divided by 4. Derivative of 2 is 0. When y is equal to 2, second derivative is positive. Correct? So that should be the point of minimum. When y is equal to, I'm getting 3 into 2 square, 3 square, sorry, 2 square. 3 into 2 square is 4 divided by 4. That's equal to 3. When y is to 2 square 4, 4 cancels. So second derivative is equal to 3 is positive. So y is equal to 2 is the point of minimum. Correct? Because when y is equal to 2, first derivative is 0 and second derivative is positive. So when y is equal to 2, x equal to how much you find out? Then you can find the d minimum value. D minimum is equal to, you can find out. When y is 2, x is how much? X is y square by 4. X is y square divided by 4. Y is 2 square 4. 4 by 4 is 1. So required point is 1 comma 2. Required point is 1 comma 2. Therefore required point is 1 comma 2. Otherwise you can use options and verify. Okay. 1 comma 2 does it satisfy? When you put x equal to 1 here, y square is 4. So y is plus or minus 2. Even this value is possible. Correct? 1 comma minus 2 satisfies this equation. But the distance is nearest. The point on the curve which is nearest to this point. Distance between 2 comma 1 and 1 comma 2 is less, or distance between 2 comma 1 and 1 comma minus 2 is less. That you can find out. See, if you find 2 comma 1 and 1 comma 2 distance, 2 comma 1 and 1 comma 2, if you find out distance is equal to root of 2 minus 1, 1 square 1. 1 minus 2 is minus 1, minus 1 square, root 2 I'm getting. If you find distance between 2 comma 1 and 1 comma minus 2, 2 comma 1 and 1 comma minus 2, if you find the distance, how much you get? Root of 2 minus 1, 1 square 1, 1 minus minus 2, 1 plus 2, 3, 3 square 9, root 10, this is more. Root 10 is more than root 2, correct? So minimum distance is possible for this point, 1 comma 2, not this. And this point does it satisfy? See, when you put x equal to 1, 4 into 1, 4, y square 4, y is plus or minus, this point does not lie on the curve. This point does not lie on the curve. At this point you put x equal to 1, x equal to 1 is y square is 4, y square is 4 means x is minus 2, x is minus 2. When you put x equal to minus 2, 4 into minus 2, minus 8, y square is minus 8 is not possible at all. Y square is negative I'm getting. So if you can avoid these steps, so many steps I did know, if you only can avoid this, you can use options and do. Okay, this point does not satisfy the equation. When you put x equal to 1, y square is 4. When you put x equal to 1 is found in 3 of the options. Here it is found, here it is found, here it is found. So x equal to 1 if you put in the curve, y square becomes 4. Y square is 4 means y equal to plus or minus 2. So this point is possible, this point is possible. Option A and option D will satisfy the equation y square equal to 4x. That means those 2 points lie on the curve y square equal to 4x, and for which point it becomes distance least you find out, whether distance between 1 comma 2 and 2 comma 1 is less, or distance between 1 comma 2 and 1 comma minus 2 is less, you find out. Distance between 2 comma 1 and 1 comma 2 is root 2. Distance between 2 comma 1 and 1 comma minus 2 I did here, root 10 I'm getting. Root 10 is bigger than root 2. So root 2 is minimum distance. So nearest distance will be the point satisfying 1 comma 2. That's it, over. Using options you can do. Okay, little bit of basic knowledge is required. Otherwise do the normal method, little bit lengthier actually, but learning the concept is also important. Okay, learn all the methods. Next we have some problems like this. In the NCERT book also you can find these kind of questions. In the miscellaneous exercise, in the exercise 6.3 of the new NCERT textbook, these kind of questions are commonly found. 3-dimensional figure questions are also there, 2D also there. So you should learn all these things. Cone is inscribed in the sphere, cylinder is inscribed in the sphere, correct? Many questions are there of that type. And maximum volume of cylinder is possible if the surface area is constant, if the minimum surface area of the cylinder when volume is constant, maximum volume of the core when the slant height is fixed. Many results are there. All those things should be grasped like anything, should be taken as a time saving result. Some of them I'll tell you orally, I can tell some of them. Okay, suppose a cone is there, okay, and a sphere is there. If you're inscribing a cone in a sphere, maximum volume of the cone is possible when the height of the cone is 4r by 3, where r is the radius of the sphere. I'll explain few of them, okay. Also I'll tell about these. So here only 2 things are mentioned here. One is a cylinder in the sphere, and the one is cone is inscribed in the sphere. Only 2 things are given because there is a problem based on that. Okay, while doing the complete synopsis I'll be doing everything. Okay, so now just I'll explain a few of them for time being. So a sphere, I'll draw the circle only. To draw the sphere, I'll draw the circle itself. If a cylinder is inscribed, okay, if a cylinder means right circular cylinder is inscribed in a sphere, the maximum volume of the cylinder is possible when a cylinder is inscribed in a sphere of radius r, okay, capital R is the radius of the sphere. Cylinder is inscribed in a sphere of radius r, means sphere radius is constant, fixed. Cylinder, we want to maximize the volume. In that case, maximum volume of cylinder is possible when height of the cylinder is 2r by root 3. 2r by root 3, where r is the radius of the sphere. Height of the cylinder should be equal to 2r by root 3 for volume of cylinder to be maximum. That is what given. Height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r by root 3. Learn that. Here it is asked, correct? 2a by root 3. In 2002 the question was asked. Height of the cylinder of maximum volume which is inscribed in a sphere of radius is 2a by root 3. Based on the memory, we can't solve these kind of question in CET exam. It's a 5-mark question or 6 marks question. We can't solve in CET exam. So we have to remember and write. Okay, standard results. And some more I'll mention here. Okay, to draw the sphere, I'm drawing a circle itself. Imagine that this is a sphere. Okay, when a right circular cone is inscribed, in a sphere of radius r. Okay, maximum volume of the cone. Maximum volume of the cone is possible when the height of the cone is 4r by 3, where r is the radius of the sphere. That is what is given here. Altitude means height. Height of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. And that too, when the cone is inscribed in a sphere, the maximum volume of the cone is 8 by 27 volume of the sphere. That is also there in the NCERT miscellaneous exercise. Maximum volume of the cone is, in this case, maximum volume of the cone is 8 by 27 volume of the sphere. Okay, learn this. 8 by 27 into volume of the sphere. Maximum volume of the cone is 8 by 27 into volume of the sphere. Okay, learn this properly. And few more results are there. Among all the rectangles of a given perimeter, square has maximum area. That I'll give. One more question is there. We'll discuss that. And there is, if a rectangle is given of area fixed area, the square has minimum perimeter. Okay. If the area of the rectangle is fixed, then the square is going to have minimum perimeter. In other words, among all the rectangles of a given area, square has a minimum perimeter. Two things are there on rectangle and square. Among all the rectangles of a given area, of a given perimeter, if the perimeter of the rectangle is fixed, then area of that rectangle is maximum when it becomes a square. That means length equal to breadth. If the rectangle area is fixed, then the perimeter of the rectangle is going to be minimum if it is a square. Okay. If area is fixed, if area of the rectangle is fixed, then the perimeter of the rectangle is minimum when it is a square. If the area of the rectangle is fixed, then rectangle area is maximum when it is square. The perimeter of the rectangle is fixed, area of the rectangle is maximum when it is a square. If the perimeter of the rectangle, if the area of the rectangle is fixed, then the perimeter of the rectangle is minimum when it is a square. Okay, these two things are there. And also we have, if the sum of the perimeter of the square and the circle is constant, then their combined area is going to be minimum when the side of the square is 2 times radius of the circle. If the combined area of the circle and the area of the square should be minimum. The perimeter of the circle and the square is constant. Sum of the perimeter of the circle and the square, sum of the perimeters of a circle and a square is constant, then sum of their areas is going to be minimum when the side of the square is 2 times radius of the sphere. That is also there in the NCERT book. And if they give a right circular cylinder of a surface of a given surface area, in other words, surface area of a right circular cylinder is constant, then the volume of the right circular cylinder is going to be maximum when height equal to r. Under this condition, height equal to r is so important. Height equal to r works when the surface area of the cylinder, the total surface area of the closed cylinder is fixed. Volume of the cylinder is maximum under this condition. And on the other way, if the perimeter, if the volume of the right circular cylinder is constant, then the total surface area of the cylinder is going to be minimum when height equal to r. Okay, if volume is constant, surface area of the cylinder is minimum when height equal to r. And related to cone, there are some results. If a right circular cone is there of a fixed slant height of the cone is fixed. Okay, cone is there but slant height is fixed. Okay, and slant height of the cone is fixed. Volume of the cone should be maximum when the semi-vertical angle is tan inverse of root 2. Theta will be tan inverse of root 2. Theta is tan inverse of root 2 for volume to be maximum. V is maximum. Volume of the cone is maximum. And also volume of the cone is maximum with the surface area is constant. If surface area is constant, surface area of the cone is constant, fixed, volume is maximum, then the semi-vertical angle is sin inverse of 1 by 3. Okay, surface area is constant. Surface area of the cone is constant. Okay, and the volume is maximum for the cone. I'm telling this is for a cone. Total surface area of the cone is constant, volume is maximum. Theta is equal to sin inverse of 1 by 3. Sin inverse of 1 by 3. All these results I'm just mentioning it. It's there in the NCERT book. How we can remember, I'm just telling you. Okay, and one more result is there connected to cone. That is, if right circular cone is there with the least curved surface area and volume is fixed. Okay, volume is constant and least curved surface area, that is possible when height equal to root 2 times the radius. H is equal to root 2r. Condition is there. H is equal to root 2r is the condition for least curved surface area and fixed volume. Okay, in these two cases volume is maximum of a given volume. Volume is fixed here. Volume is constant. Volume is constant and least curved surface area. Least curved surface area. Okay, these are all important things to be remembered. And maximum area of rectangle inscribed in circle is, that result is there. Next it comes. Okay, I'm going to explain that. Maximum area of rectangle inscribed in the circle, which is 2 into radius square, and dimensions of the rectangle is root 2a, root 2a. And one more thing is that maximum area of rectangle inscribed in the ellipse 2ab. Dimensions of the rectangle are root 2a, root 2b. Okay, ellipse was not asked so far. Maximum area of rectangle inscribed in the ellipse is not asked so far, but maximum area of rectangle inscribed in the circle is asked. 2 or 3 times they've asked the question. So these are some of the important results. And there is one more result in the miscellaneous exercise. A point on the hypotenuse is situated at a distance of A and B from the two sides of a triangle. Then the minimum length of the hypotenuse is how much? A power 2 by 3 plus B power 2 by 3 whole to the power 3 by 2. That is also there on a triangle. Correct? And window is there. Window in the form of a semicircular opening. Rectangular window in the form of a semicircular opening surmounted by a semicircular opening, like that. All those things are very interesting questions are there in the NCERT miscellaneous exercise of application of derivatives chapter 6 I'm telling of second PU. Okay, these two are the results which is given here. Okay, because one question is already asked in the 2002 based on that. So I mentioned this. How to remember? Just I told you. This is cylinder inscribed in the sphere. Volume of cylinder is maximum and the height of the cylinder is 2r by root 3, where r is the radius of the sphere. This is cone inscribed in the sphere. So volume of the cone should be maximum, means the height of the cone should be 4r by 3. And also we can prove that maximum volume of the cone is 8 by 27 volume of the sphere. Okay, sphere is fixed and we are varying the dimensions of the cone. Here sphere is fixed, means radius of the sphere is fixed. We are varying the dimensions of the cylinder. And one more question is there, that is the cylinder is inscribed in the cone. That also one question is there. There the greatest curved surface area. The curved surface area of the cylinder is greatest when the radius of the cylinder is half of the radius of the cone. That is also solved example in the NCERT book 6.5. There 6.3. Before that they solved that example. Okay, the cylinder is inscribed in the cone. Okay, the greatest curved surface area of the cylinder is possible when it is inscribed in the cone, when the radius of the cylinder will be half of the radius of the cone. Greatest curved surface area of the cylinder, that is. Okay, this is semi-vertical angle is tan inverse of root 2 for volume to be maximum and slant height is constant. Slant height is fixed, volume is maximum when semi-vertical angle is tan inverse of root 2. And here this is surface area of the cone is constant. Surface area of the cone is constant, volume of the cone is maximum, semi-vertical angle is tan inverse of 1 by 3. And one more result I wrote here, the least curved surface area of the cone with volume fixed. Volume is constant, least curved surface area of the cone is possible when height is equal to root 2 times the radius of the base. All those results better to remember. Okay. And here the question asked in 2024, we can't apply those results which I mentioned here. They asked to find maximum volume of the right circular cone with slant height 6. Slant height is fixed as 6. Okay, there is a cone with slant height is 6. You have to find the maximum volume of this cone. Question asked in the year 2024. This is called slant height. This is the height or altitude of the cone, and this is the base radius r, h. We have L is equal to 6. Slant height is fixed as 6. We have L square is equal to r square plus h square. L is 6. 6 square is equal to r square plus h square. So r square is equal to how much? 36 minus h square. R square is 36 minus h square. So volume of the cone is how much? 1 by 3 pi r square. So you have to find the maximum volume of this cone. Correct? R and h both are variables. Now eliminate one of the variable. 1 by 3 pi into r square is 36 minus h square. Is equal to 1 by 3 pi into, here you get 36h minus h cube. 36h minus h cube. Correct? I am eliminating r square because both r and h are variables. I am converting the double variable to single variable using this equation. R square is equal to 36 minus h square because L is constant. L is equal to 6. Slant height is fixed as 6 units. So using that I am substituting like this. And differentiate this. dv by dh. Differentiate with respect to h. Constant into variable. Constant keep as it is. Derivative of 36h is 36. Derivative of h cube is 3h square. Double differentiate this. D square v by dh square is equal to constant keep as it is. Derivative of 36 is 0. Derivative of 3h square is 6h. This becomes minus 2 pi h. Second derivative is negative because height is always positive. Terms inside the bracket equal to 0 to 3h square equal to 36. I'll get h square is equal to 12. So h is equal to root 12. Correct? H square is equal to 12. H is equal to root 12. So h is equal to 2 root 3. When h is equal to root 3, if we substitute, second derivative is negative. When h equal to root 3, second derivative is negative. If you want, you can substitute in C. Correct? Minus 2.2 root 3 becomes minus 4 root 3. I won't write all the steps. So when h equal to root 3, volume is maximum, we can conclude. So you can substitute V max. V max is possible when h is equal to 2 root 3. So pi by 3 into, put h equal to 2 root 3 and write 36 into 2 root 3. 36 into 2 root 3 minus 2 root 3 cube. What do you get? Pi by 3 into 36 into 2 is 72 root 3. 2 cube is 8. Root 3 cube will be 3 root 3. Correct? 8 into 3 becomes 24 root 3. So I'll write the answer here. V max. Therefore, V max is equal to, how much you get? Pi by 3 into 72 root 3 minus 24 root 3. That is 48 root 3. 3 ones are 3. 16s are 16 pi root 3 answer. 16 pi root 3. Correct? Option B. 16 root 3 pi. R square is 36 minus h square. Eliminate one of the variable. So I can write R square as 36 minus h square. Volume of right circular cone is asked. Start with volume of cone. R square is 36 minus h square into h. Open the bracket, 36h minus h cube, differentiate with respect to h, constant into variable, constant keep as it is, differentiate 36h with respect to 36, derivative of h cube is 3h square, a into b0 means either a equal to 0 or b equal to 0, a can't be 0, so b should be 0, 3h square equal to 36, h square equal to 12, h equal to root 12, root of 4 into the 2 root 3, taking the positive square root, substitute the value, second derivative is negative for h equal to 2 root 3, so h equal to root 3 substitute here and get the maximum volume, pi by 3 into 36 into 2 root 3, correct, 2 root 3 cube, 2 cube is 8, root 3 cube is 3 root 3, 72 root 3 minus 24 root 3 which is 48 root 3, 3 ones are 3 16s are 16 pi root 3 or 16 root 3 pi, option B. Move on to the next one. Here there is a question based on maximum value of a slope concept. Finding the maximum value of a slope. Slope means slope of the tangent to the curve. So some curve y is equal to f of x is given to you. You differentiate that curve. What we get is dy by dx. dy by dx is slope of tangent or slope of the tangent to the curve. Slope of the curve they call in short. So dy by dx we call it as g of x. This slope should become maximum. So slope is dy by dx. Given y equal to f of x, dy by dx is slope. So dy by dx will get, that we call it as g of x. G of x first derivative should be 0. G of x second derivative should be negative for slope to become maximum. Okay. Then find out the point of maximum and substitute g max you can find out. That is what I given here. Okay. To find the maximum value of the slope, first differentiate dy by dx, that is the f dash of x, that is slope. Slope we got. Slope's first derivative should be 0. Slope's second derivative should be negative. G double dash should be negative. At the critical point of g of x, verify that second derivative should be negative and find the maximum value of the slope, that is f of x. Slope, maximum value of the slope of the curve y equal to f of x is g max. If you want to find the maximum value of the slope of the curve y equal to f of x, that is nothing but g max. G max is going to be the maximum value of the slope of the curve y equal to f of x. This equal to sign should not be there, I think. That is you can write. Maximum value of the slope of the curve y equal to f of x is given by g max. That's better. Is given by g max. Okay, not is equal to g max. So that will take a problem asked in the year 2021. Also in the NCERT example book, this type of question is there. So y is given. You have to find maximum slope of this curve, means maximum value of the slope of the tangent to this curve you are finding. So dy by dx is equal to what? Dy by dx, that is slope of the tangent to the curve, minus 3x square plus 6x plus 2. I got the slope. Slope is g of x will call. G of x is slope. Okay, this is slope. G of x. After differentiating this, I get that is g of x, slope. G dash of x you find out. G dash of x, that will be equal to how much? G of x is this, g dash of x minus 6x plus 6. G double dash of x, derivative of minus 6x minus 6, which is less than 0. Second derivative is negative. First derivative should be 0. That is x equal to 1. Correct? So x equal to 1 is the point of maximum for g of x. So g max you want. G max is got, G is maximum when x is equal to 1, you can write. G is maximum when x is equal to 1. G is maximum when x is equal to 1. So G max you want, put x equal to 1. G max is got by putting x equal to 1. Minus 3 into 1 square plus 6 into 1 plus 2. Correct? Minus 3 plus it becomes 5 answer. Maximum value of the slope is 5. Correct? G of x is slope. Slope maximum value is got by putting x equal to 1. Slope's first derivative should be 0. Slope's second derivative should be negative. Correct? Satisfied. Slope is g of x. After differentiating the given function, I get minus 3x square plus 6x plus 2. This is slope. Slope is g of x. Slope's first derivative find out. Minus 6x plus 6. Derivative to 0. Equate this to 0. I'll get the critical point of slope. And g double dash of x, derivative of minus 6x minus 6, derivative constant is 0. Second derivative is negative. So slope is maximum when x equal to 1. G max you can get by putting x equal to 1. Minus 3 into 1 square plus 6 into 1 plus 2. 6 plus 2, 8. 8 minus 3, 5 is answer. Option C. Question asked in the year 2021. A nice question. Move on to the next one. Similar type of question asked in even JEE main also. Okay. So next we have result here. These type of questions already you have seen in the NCERT book. If sum of two positive numbers is constant, then the product xy is maximum when x equal to y. If sum of the two numbers is constant, sum of the squares is minimum when x equal to y. Sum of the two numbers is constant, sum of the cubes is minimum when x equal to y. If sum of the two positive numbers is constant, sum of the reciprocals is minimum when x equal to y. And x power a into y power b is maximum when the numbers are in the ratio a is to b. Okay, even this type of question is found in the NCERT book, but not asked so far in the exams. Okay, but other exams like NDA and other competitive exams, questions are asked already, but not for KCET. Here, sum of the two numbers is constant, x plus y is constant. Okay, product is maximum when the numbers are equal, x equal to y. Sum of the squares is minimum when x equal to y. Sum of the cubes is minimum when x equal to y. Sum of the reciprocals is minimum when x equal to y. All these three minimum. The first and last are maximum. Product is maximum when x equal to y. Sum of the squares is minimum when x equal to y. Numbers should be equal. Already we have seen in the NCERT book, right? If x plus sum of the two positive numbers is 16. Find the numbers so that x square plus y square is minimum. It is there in the NCERT book, correct? X square plus y square is minimum when x equal to y. X is equal to y is equal to 8 is answer. Over. Correct? Sum of the two numbers is 16. Correct? Or 15, I think. The question in the NCERT book it is given as 15, I guess. Correct? And sum of the cubes is there. Sum of the cubes is there, the given 16. X equal to y equal to 15 by 2. And one more question is there. X plus y equal to sum of the two numbers is 16. What are the numbers if x cube plus y cube is minimum? X cube plus y cube is minimum when x equal to y. That means x should be 8, y should be 8. Correct? X equal to y is equal to 8. Over. Correct? Like that. There are questions in the NCERT book. These are always solved for solving it for PU board exams. Correct? We're preparing for PU board exams. There are such kind of questions. Should be remembered as a standard result. Even this we have. Product of two numbers is given. Correct? Sum of two numbers is given. X plus y equal to 24. Product is maximum when x equal to 12, y equal to 12. Correct? In this question is there. Sum of the two numbers is given as 24. Find the numbers so that p is equal to x into y is maximum. What is the answer to get? X equal to y. If sum of the two numbers is constant, product is maximum when x equal to y. Correct? X should be equal to 12, y should be equal to 12. Over. 12 and 12. See, all examples are given. Okay? And this is sum of the reciprocals is minimum when x equal to y. Even this type of question is there. P equal to x power a, y power b is maximum. I'll show if you want. See, x plus y is equal to 35. There is one question like this. X plus y equal to 35. X square into y power 5 is maximum. Numbers should be in the ratio 2:5. Numbers depends upon the power of the variable. See, x power a, y power b. No, numbers should be in the ratio a is to b. Which are the numbers in the ratio a is to b satisfying this condition? 10 and 25, correct? 10 plus 25 is 35. 10 and 25, the numbers in the ratio 2:5. So numbers should be 10 and 25 for this product to become maximum. Over. 10 and 25. 10 plus 25 is 35. 10 square into 25 power 5 will be maximum. 2:5 ratio. Correct? 5 2s are 5 5s are. Move on to the next one. There is a question here. Sum of the two positive numbers is given. Sum of their cubes is minimum when they are equal. Just now said. Sum of the cubes is minimum. Sum of the two numbers is constant. Sum of two positive numbers is constant. Sum of the cubes is minimum when x equal to y, means when they are equal. Over. Question asked in the year 2012. Move on to the next one. This is one nice result actually. Perimeter, now it's not found in the NCERT book, but can be asked. Okay. Perimeter of the certain sector of a radius r is p at sectorial angle theta. Maximum area of the sector is possible when radius is 1/4 of perimeter and the sectorial angle is 2 radians and the maximum area is p square by 16. So perimeter means part of a circle. Perimeter of sector means part of a circle. Sorry. Sector means part of a circle. Perimeter of the certain sector is fixed. You want to find maximum area of that sector. That is possible when the radius is 1/4 of perimeter. And area is maximum when sectorial angle is 2 radians. These two things you must know. And the maximum area is p square by 16. Already questions are asked based on this. Okay. If you want, I can give the proof of this. Sector means part of a circle. Correct. This is called sector. This is r. R is the radius of the sector. This is also radius of the sector. This is sectorial angle theta. This is length of the arc. We know this. L is equal to r theta. Perimeter means sum of the sides. Perimeter means what? R plus L. R plus R is 2r plus L. L is r theta. Correct? L is equal to r theta. We know this. This is perimeter. Area of the sector, we know the formula. Half r square theta. Correct? Area of the sector is half r square theta. So eliminate one of the variable here. Find out r is equal to how much? P minus 2r is equal to r theta. Now from this I can write P minus 2r is equal to r theta. Correct? This is half into r into r theta, I'll write. Correct? So that r into r is r square. Half r into, what is r theta? P minus 2r. Correct? From this equation, r theta is P minus 2r. Differentiate this. Multiply half into, what do you get? PR minus 2r square. Differentiate with respect to r. dA by dr is equal to half into derivative of PR is p. Derivative of r square is 4r equal to 0. Find out the second derivative. d square a by dr square is equal to half into derivative of p is 0. Derivative of 4r is 4. So I am getting minus 2. Correct? Second derivative is negative. And first derivative equal to 0 I do. P is equal to 4r. P is equal to 4r means what? Radius is 1/4 of perimeter. Got no? Radius equal to 1/4 of perimeter. And radius is 1/4 of perimeter if you substitute. No? I'll get P is equal to maximum area. That is P square by 16. Also I can prove that sectorial angle. Here theta is how much? Theta is P minus 2r by theta is according to this P minus 2r divided by r. P minus 2r divided by r. What is P? 4r, correct? 4r minus 2r divided by r. 4r minus 2r is 2r. 2r by r is 2. Correct? Sectorial angle is 2 radians. I proved. Sectorial angle is 2 radians. For area of the sector to become maximum, radius should be 1/4 of perimeter. Sectorial angle should be 2 radians. Exactly 2 radians for area of the sector to become maximum. The perimeter is fixed. And maximum area is p square by 16. Maximum area you can find out using this. Here you can substitute here. A is equal to, we have, no? In this, you substitute. What do you get? A max. A max I'll write here. A max is equal to half r into P is how much? P is 4r, right? Substitute P is equal to 4r here. 4r minus 2r I'm getting. 4r minus 2r. Correct? So what I'm getting is half into r into 4r minus 2r. That is 2r. Oh, I'm getting, I should get in terms of P, no, sorry. I should get in terms of P, not in terms of r. Just a minute. Slightly I made a mistake. I'll substitute for radius. Okay. Half into, what is radius? Radius is p by 4. No, substitute for radius. Don't substitute for p. I'll substitute for radius. Radius is P by 4. Radius is P by 4 into P minus 2R. P minus 2 into P by 4. Radius is P by 4. So 2R is P by 2. Correct? 2R is P by 2. So this is P by 8. 4 2s are 8. P minus P by 2 is P by 2. So I'm getting P square by 16. Maximum area is P square by 16 over. Correct? Move on to the next one. See, this is the questions based on those three results. Learn these three results properly so that you can answer the next coming questions. Here, wire of length 20 cm is bent in the form of a sector of a circle. Just now proved. Sector of a circle is part of a circle. Maximum area that can be enclosed by the wire. So, wire of length 20 cm is bent so that it forms it forms a sector of the circle. Means perimeter of the sector is given. Perimeter of the sector is given as 20. Perimeter of the sector is given to be equal to 20. Correct? 20 centimeter. What is the maximum area that can be enclosed? A max is equal to how much? P square by 16. A max is P square by 16. So 20 square divided by 16, which is 400 divided by 16, which is equal to 25. Maximum area is 25 square centimeter. A max P square by 16 over. Within 10 seconds we can answer. Question asked in 2010, also asked in JEE main, same question in 2018. Okay. P square by 16. P is 20. 20 square is 400. 400 by 16 is 25 square centimeter. Next one here. Perimeter of a sector is constant. If its area is maximum, then the sectorial angle is 2 radians. Just now proved. Maximum area of the sector is possible when theta is equal to 2 radians. Learn this. And maximum area of the sector is possible when radius is 1/4 of perimeter. Maximum area of the sector is P square by 16. Learn all these things properly. Very important. Okay. 2 radians asked in the year 2012. Next question. See, circular sector of perimeter 60 meter with maximum area is to be constructed. Perimeter is given 60 for the sector of a circle. Sector means part of a circle. You have to find the radius of the circular. Maximum area is there. Circular sector of perimeter 60 with maximum area is constructed. For maximum area, radius is how much they are asking. Radius is for maximum area of the sector. We know radius equal to 1/4 of perimeter. For maximum area of the sector, what we have? Radius equal to 1/4 of perimeter. So 1/4 of 60, that is equal to 15. Radius equal to 15. For maximum area, radius should be 1/4 of perimeter. 1/4 of 60 is equal to 15. Option E. Question asked in the year 2006. Learn all the results properly. Here once again, perimeter of a sector is P. The area of the sector is maximum and the radius is P by 4. Proved, no? Radius is P by 4. 1/4 of perimeter. For maximum area of the sector, radius should be 1/4 of perimeter or P by 4. 2002. Same result was applied here also. 1/4 of perimeter. Correct? Already we proved those results here. Correct? All the results are proved here. Radius is 1/4 of perimeter. Correct? Radius is 1/4 of perimeter. Sectorial angle is 2 radians. And maximum area is P square by 16. Learn all the 3 results. Proof is also given here. Okay? Rectangle inscribed in a circle. So maximum area of a rectangle inscribed in a circle. There is a circle of radius A. The maximum area of the rectangle inscribed in the circle is 2A square. Learn this. Maximum area of the rectangle inscribed in a circle of radius A is 2A square. And the dimensions of the rectangle are root 2A, root 2A. Dimensions of the rectangle are going to be how much? Root 2A, root 2A. Root 2A, comma, root 2A. That means length becomes equal to breadth. This is the diameter of the circle, which is also the diagonal of the rectangle, which is 2A here. Learn this result. Same type of result we have even for rectangle inscribed in ellipse. If a rectangle is inscribed in ellipse, maximum area is 2AB there. I have not given here because no questions are asked in this previous year questions. And the dimensions of the rectangle are going to be root 2a, root 2b. Like this. Ellipse is there. Area is maximum for a rectangle. When a rectangle is inscribed in the ellipse equation, we know x square by a square plus y square by b square equal to 1. Maximum area of the rectangle inscribed in the circle is 2a square. Maximum area of rectangle inscribed in the ellipse is 2ab. And dimensions of the rectangle are root 2a comma root 2b. Learn this properly. Here there are some questions. Maximum area of the rectangle that can be inscribed in a circle of radius 2 units. Same question asked in 2008 and 2013. Maximum area of the rectangle inscribed in the circle is 2a square, where a is the radius. So 2 into 2 square. 2 square is 4. 4 into 2, 8. 8 square units. Maximum area of the rectangle inscribed in the circle is 2a square, where a is the radius of the circle. Radius of the circle is 2, so 2 into 2 square. That is the word. Next one, maximum area of rectangle inscribed in the circle. Like this, circle equation is given like this: x minus h the whole square plus y minus k the whole square equal to r square. Radius is 8 here, correct? So a max is equal to 2a square, we know. Maximum area of the rectangle inscribed in the circle is 2a square. A square is 64, correct? A square itself is 64. Because we're comparing with x minus h the whole square plus y minus k the whole square equal to r square. R square is 64. In my notation, radius is a square. So 2 into 64 is 128. This is option C. Question asked in there 2018. So most important result this is because it is found in the NCERT book, correct? We're proving it for 5 marks question, but rarely asked in the board exams, correct? So this is equation of circle they given. Here radius was given directly. From the equation of circle, you have to find the radius. X minus h the whole square plus y minus k the whole square equal to r square. R square is 64. That I am taking as a square. In my notation, instead of r square, I have taken a square. This is your r square. R square is 64. 2 into 64 is 128. Maximum value of a cos x plus b sin x, root of a square plus b square, very important result. Even in trigonometry also this can be covered. Even minimum value is given. Minimum value of a cos x plus b sin x minus root of a square plus b square. Of course, you can interchange cos and sin. Instead of giving a cos x plus b sin x, I can give a sin x plus b cos x also. Okay. Even if you give a sin x plus b cos x, maximum value is same. Root of a square plus b square. Okay. Maximum value is root of a square plus b square, and the minimum value will be minus root of a square plus b square. Even for a cos x plus b sin x, or if it is a sin x plus b cos x, both the same story. Maximum value root of a square plus b square, and the minimum value is minus root of a square plus b square. There are some questions on this. Maximum value of y equal to a cos x plus b sin x. That's not root of a square plus b square. Direct result is given. Proof of that I'll go into do in the synopsis part. Okay. All those things. Maximum value of sin x plus cos x. Here a is 1, b is 1. Sin x plus cos x. We take it as y. Y is equal to sin x plus cos x. Comparing with a sin x plus b cos x. Comparing with a sin x plus b cos x. Compare with a sin x plus b cos x. What do we get? A is 1, b is 1. Correct? Want to find y max. Y max is equal to root of a square plus b square. Maximum value is root of a square plus b square. Root of 1 square plus 1 square, which is root 2. Maximum value is root 2. Question asked in the year 1997. One of the interesting questions asked in 2009. Minimum value of 27 per cos 2x, 81 per sin 2x. Correct? Take this as y. Y is equal to 27 to the power cos 2x into 81 to the power sin 2x. Right? 27 has 3 cube and 81 has 3 power 4. Okay? 27 could be written as 3 cube. 3 cube to the power cos 2x. 81 is 3 power 4 to to the power sine 2x. The powers gets multiplied. Now this becomes 3 power 3 cos 2x. 3 power 4 sine 2x. Correct? Here bases are same, so add the powers. Therefore what we get? Y is equal to 3 to the power, bases are same, so add the powers. 3 cos 2x plus 4 sine 2x. 3 cos 2x plus 4 sine 2x. Now we can find the minimum value of this. Y minimum is equal to, base is constant, in the power there is a variable and both the angles are same, no, 2x 2x. So it does not matter whether x is present or 2x is present. Both the angles should be same. That is important. Of course, both the angles are same. So I am using the result minimum value of a cos x plus b sin x minus root of a square plus b square. Here a is 3 and b is 4. So minimum value of this expression is going to be minus root of 3 square 9, 4 square 16. So this becomes 3 power minus root 25. Root 25 is 5. 3 power minus 5 is 1 by 3 power 5. Which is equal to 1 by 243. Minimum value is 1 by 243. Option C. Want the next one? Here one more result is given to find the maximum value of a sin square x plus b cos square x, which is maximum of a comma b. Directly you can answer. And same way minimum value of a sin square x plus b cos square x is minimum of a and b, means smaller of the two numbers. Okay, suppose I take A and B. Suppose A is 3, B is 4. So one such question is asked here. I'll show the question so that you can understand easily. 2 times the same question is asked here, 2003 and 1995. Want to find maximum value of the function 4 sin square x plus 3 cos square x. If you want to find maximum value, take the maximum value of 4 and 3. What is maximum of 4 and 3? 4. Answer is 4. Over. That's it. 5 seconds enough to crack this question. If that's minimum value of this expression, that is 3. Smaller of the number, 3 and 4 is 3. If that's minimum value, 3. If that's maximum value, 4. Hence the result. Maximum value of a sin square x plus b cos square x is maximum of a and b. The bigger of the two numbers. A and b are there, no? Which is bigger of those two, that is maximum. Of course, a and b are positivatic. And minimum value of a sin square x plus b cos square x. Minimum of a and b, minimum of these two. Okay, so if you want, I can do the method also. Method is, see, if you want to do the actual method, f of x is equal to 4 sin square x, you can write it as sin square x plus 3 sin square x. I'll split this. Sin square x plus 3 sin square x plus 3 cos square x. So this is equal to sin square x plus 3 common here. Sin square plus cos square is 1. Taking 3 common. Sin square x plus cos square x. Terms inside the bracket is 1. So what we get is sin square x plus 3 into 1, that is 3. Correct? We want to find maximum value, f max. F max you want. Maximum value of sin square x is 1. Correct? So maximum value is 1 plus 3 is equal to 4. And minimum value of sin square x is 0. Correct? 0 plus 3 is 3. If you want minimum value, F minimum. If you want minimum value of sin square x is 0. 0 plus 3 is equal to 3. If that's minimum value 3, maximum value is 4. Minimum is smaller of the two numbers. Smaller of 4 and 3 is 3, hence answer is 3. Bigger of the numbers 3 and 4 is 4, so maximum is 4. Over. One more concept, application of AM-GM inequality to find the minimum values of certain expressions. Also it's helpful to find maximum value of certain expressions. Most of the time we find the minimum value only, so that geometric mean becomes independent of variable. In that case you can apply. To find the minimum value of certain expression, one can apply AM-GM inequality. You know, arithmetic mean a plus b by 2 for two numbers a and b, and geometric mean is root of ab for two numbers a and b which are positive. Geometric mean. So a plus b by 2, arithmetic mean greater than or equal to geometric mean. If geometric mean is independent of variable, then we can apply this result to find the minimum value of certain expressions. So arithmetic mean of two numbers a and b is a plus b by 2. A plus b by 2. Geometric mean of two numbers a and b is root of ab. Correct? So one can find the minimum value of a plus b by 2 if geometric mean is independent of variable. One can also find maximum value of ab if a plus b by 2 is independent of variable. That is what I given. If geometric mean is independent of variable, we can find the minimum value of a plus b by 2. Because greater than or equal to means gives minimum value. Some expression, some quantities greater than or equal to means it gives the minimum value. Less than or equal to means gives maximum value. Okay, I can find root AB maximum value. Root AB is less than or equal to a plus b by 2. If a plus b by 2 is independent of variable, arithmetic mean is independent of variable, I can find maximum value of root AB. Hence, maximum value of AB can be found. So quite useful. And one more table is given here for the finding minimum value of certain expressions. One table is given. Okay, this gives many information. You want to find minimum value of x plus 1 by x when x is positive, it's 2. Can use EMZM inequality and get the answer. Also, this concept is useful in sequence and series chapter. There also it can be dealt. Okay, so x plus 1 by x minimum value is 2. X square plus 1 by x square minimum value is 2. A tan square theta plus b cot square theta 2 root ab. If you want to show a few of them, see arithmetic mean greater than or equal to geometric mean, you know, correct? Arithmetic mean greater than or equal to geometric mean. Arithmetic mean is a plus b by 2. Correct? Geometric mean is root of ab. You take a as x and b as 1 by x. A as x, b as 1 by x. X plus 1 by x divided by 2 greater than or equal to root of x into 1 by x. X into 1 by x, x cancels. Correct? X not equal to 0, x is positive. So x plus 1 by x divided by 2 is greater than or equal to 1. So what we get is x plus 1 by x is greater than or equal to 2. Greater than or equal to means minimum value is 2. Equality gives the minimum value. So minimum value of x plus 1 by x is 2. Likewise, many other things are given. And also I can show for this 3 power x plus 3 power 1 minus x. It is found in the NCERT exemplar book. Take a as 3 power x and b as 3 power 1 minus x. I am doing question number that is 6. Okay, this is for the first one. 6th one I am doing here. 6th one, 3 power x plus 3 power 1 minus x. Take a as 3 power x. Okay, b as 3 power 1 minus x. Divided by 2. In place of a put 3 power x. In place of b put 3 power 1 minus x. Greater than or equal to root of 3 power x into 3 power 1 minus x. Correct? So this gives 3 power x plus 3 power 1 minus x divided by 2 is greater than or equal to, here if you multiply means add the powers, correct, root of 3 power x plus 1 minus x, adding the powers because bases are same. Bases are same, so add the powers, x plus 1 minus x, that is 1, cross multiply. So what we get is 3 power x plus 3 power 1 minus x is greater than or equal to 2 root 3. 3 power 1 is 3, root 3, cross multiply. 2 root 3 is the minimum value. One more I'll show. For a tan square theta plus b cot square theta. See, take a as, first number a as a tan square theta. Second number b as b cot square theta. Okay, a is a tan square theta. And b is b cot square theta. Correct? Divided by 2. Arithmetic mean is greater than or equal to root of, geometric mean root of, first number is a tan square theta and second number is b cot square theta. Correct? B cot square theta. Tan square into cot square is 1, right? So root AB it becomes. Cross multiply, I'll get 2 root AB. So a tan square theta plus b cot square theta divided by 2 is greater than or equal to, tan square into cot square is 1. For theta not equal to n pi, theta not equal to n plus 1 pi by 2. This became 1. Correct? This into this is 1. Root AB is left. Cross multiply this, 2 root AB. So 2 root AB is the minimum value for this. A tan square plus b cot square, minimum value is 2 root AB. Cross multiply. Greater than or equal to means gives the minimum value. Minimum value of a tan square theta plus b cot square theta is greater than or equal to 2 root AB. 2 root AB. Also, I've written the synopsis book and KCET books also, okay, for your reference, I'm telling you. And also, modules also are there, KCET modules for both first PU and second PU separately. I've written 7 books already, and this is my YouTube channel, Abhiram's Maths Marathon. I'll be uploading all the videos. I have plans of uploading more than 800 videos in the next 1 year. Okay, NCERT exams that I'll be solving. Each chapter wise I'll be solving. PYQs of JEE Mains, synopsis for JEE Mains, exclusively for JEE Mains I'll be doing, even for KCET and NDA and many other competitive exams. Also KCET PYQs, synopsis and NCERT exercise of both first PU and second PU separately, class 11th and 12th. CBSE papers also I'll be doing one by one. MCQs also for board exams, 20 or 15 MCQs and 5 fill in the blanks are there, no? That also I'll be doing each and every chapter. Okay, model papers, important questions, one shot, all chapters one shot for theory exams, and for many more CET papers also I'll be doing. Even JEE papers, JEE model papers, CET model papers, all will be uploaded one by one after the other. Okay, so minimum value of a tan square plus b cot square is 2 root ab. Likewise, you can prove all these things. Here also you can apply AMG of inequality and get the answer. Sine square plus cosecant square, minimum value is 2. Correct? All those things you can try on your own. Here a secant square plus b cosecant square. Secant square you can write 1 plus tan square. Cosecant square you can write 1 plus cot square. Secant square is 1 plus tan square. Cosecant square is 1 plus cot square. And use AMG of inequality, you'll get the answer. Try all those things. You get root a plus root b the whole square. Some of the interesting things are there. You can take a screenshot if you want. Okay. All much information is there. And there is one question based on this asked in the year 1991. Many years back. So you have to find for all positive values of P, Q, R and S, this expression cannot be less than what? Means greater than or equal to what you have to find out. So greater than or equal to means use AMGM inequality. So write this expression in the proper form as convenient for us. P square plus P plus 1, the first bracket. Second bracket is Q square plus Q plus 1. R square plus R plus 1. Into S square plus S plus 1 divided by PQRS. I'll divide this by P and write. I'll divide this by Q and write. I'll divide this by R and write. I'll divide this by S and write. So this bracket I'll divide by P. There are 3 terms inside this bracket. Each term you divide by P and write. Here there are 3 terms inside this bracket. Each term you divide by Q and write. Same way here. Divide each term by R and write. Divide by S and write. So what do we get? This is equal to P square by P, that is P. Here P by P, 1 plus 1 by P. Here Q square by Q, that is Q, plus Q by Q, 1 plus 1 by Q. Here R square by R is R by R 1 plus 1 by R. This is S square by S, that is S. S by S becomes 1 plus 1 by S. Separating the terms, divide individually. P square by P by P 1 plus 1 by P. Same here, Q plus 1 plus 1 by Q, R plus 1 plus 1 by R, S plus 1 plus 1 by S. We know the minimum value of x plus 1 by x. If x is positive, it's 2. Already we have this expression. X plus 1 by x, for x positive, minimum value is 2. Correct? Minimum value is greater than or equal to. X plus 1 by x is greater than or equal to. I'm using this. X plus 1 by x is greater than or equal to. Correct? So, I can write P plus 1 by P is greater than or equal to 2 plus 1, 3. Q plus 1 by Q is greater than or equal to 2 plus 1, 3. So, likewise, each bracket is greater than or equal to 3. Correct? This is greater than or equal to P plus 1 by P. Minimum value of P plus 1 by P is 2. Correct? P plus 1 by P is greater than or equal to 2. So, 2 plus 1, 3. Q plus 1 by Q is 2. 2 plus 1, 3. 3 into 3 into 3 into 3, which is 3 power 4, which is 81. So it is greater than or equal to 81, means cannot be less than 81. If it is greater than or equal to 81, it cannot be less than 81, correct? So answer is 81. Minimum value is 81, cannot be less than 81. Among all the rectangles of a given perimeter, square has maximum area. This I told earlier also. And among all the rectangles of a given area, square has minimum perimeter. We can prove it. Take a rectangle and prove it. Okay. So one such question is asked here. That is, in what ratio should a given line be divided into two parts so that rectangle contained by them is maximum? Answer is 1:1. So that rectangle becomes a square. In what ratio should a given line be divided in two parts? A given line is there. It should be divided in two parts so that rectangle contained by them is maximum. So this line segment AB is there. No, it is made into a rectangle. It is made into a rectangle. This line segment AB is made into a rectangle like this. PQRS. This line segment AB is made into a rectangle. So rectangle should have maximum area. For this rectangle to maximum area, it should be square. That means length is equal to breadth. That means this should be divided into the ratio 1:1. Correct? So 1:1 is the required answer. Option A. For rectangle, if the perimeter is fixed, area is maximum when the rectangle becomes a square. That means length is equal to breadth. So ratio is 1:1. And absolute maxima and absolute minima. Given a function f of x, if you want to find the maximum and minimum values of the function in the closed interval, then the procedure to be followed is you have to find the critical points. Critical points are the points where derivative becomes 0 or the points where derivative is not defined. So critical points say C1 and C2, C3 are the critical points. Suppose the function is defined in the interval AB, a continuous function. F dash of x equal to 0 or f dash of x is not defined. Okay, you find out the critical points. F dash of x is not defined. F dash of x equal to 0. F dash of x is not defined. Such points are critical points. Let C1, C2, C3 are the critical points. Okay. C1, C2, C3 belongs to the interval AB, be the critical points. I've taken 3 critical points. It can be 4 or 2 or 1 or no, like that. It depends upon the given question. I've taken, let there be 3 critical points, be the critical points of the function. Okay, then you have to find the function value. You have to find the function value at the critical points. You have to find the function value at the end points. At the end points and at the critical points, you have to find the function value. And compare the function values, and the greatest among them is absolute maximum value and the least among them is absolute minimum value. Okay, so the function value to find out at the critical points and at the end points, which are critical points. F of C1, you have to find f of C2 and f of C3. Okay, at the critical points you have to find the function value. At the critical points, find the function value. And also find the function value at the endpoints of the interval. Endpoints of the interval are A and B. Find out f of A and you have to find out f of B. Among this, you compare all the values. This you compare. Greatest among them is absolute maximum and the least among them is absolute minimum. That is what I given the information here. Okay. Step 1. Find all the critical points. That is the points where derivative vanishes. Vanishes means becomes 0. Or the points where f is not differentiable. Then step 2, calculate the value of f at the critical points. Find the function value at the critical points. Next, find the function value at the end points of the interval. Then compare. Greatest value among them is absolute maximum value and the least value among them is absolute minimum value. Hope it's clear. One such question is asked till now in the year 1993 KCET. Given the function y is like this, in the interval 0 to 2, to find absolute maximum value. Take this function and differentiate. Y is equal to x cube minus 3x plus 2. Differentiate this. Dy by dx. Dy by dx. Derivative of x cube is 3x square. Derivative of 3x is 3. Derivative of 2 is 0. Correct? Dy by dx is derivative of x cube is 3x square. Derivative of 3x is 3. Derivative of 2 is 0. Correct? Dy by dx equal to 0 will give the critical points. Correct? 3x square is equal to 3. 3x square is equal to 3 means x square is equal to 1. That means x equal to plus or minus 1. Minus 1 plus 1. These are the critical points. Critical points. But minus 1 does not lie in the interval. Correct? Minus 1 does not lie in this interval 0 to 2. Correct? But x equal to minus 1 does not belong to the interval 0 to 2. Does not lie in the interval 0 to 2. Therefore, x equal to 1 lies. X equal to 1 lies in the interval. So, we take x equal to 1. You have to find the function value at x equal to 1. Put x equal to 1 in this. Also, you have to find the function value at the endpoints of the interval. When x equal to 0, find out y equal to how much? At the endpoints. When x equal to 0. When x equal to 0, y is equal to how much? Y is equal to 0 cube 0 minus 3 into 0 plus 2, that is equal to 2. When x equal to, when x is equal to 2, when x equal to, finding at the right end point, y is equal to how much? Y is equal to, put x equal to 200, 2 cube 8 minus 3 into 2 6 plus 2, correct? 8 minus 6 to 2 plus 2 4, correct? And also to find at the critical point when x equal to 1. When x equal to 1, find out the function value. Y is equal to, put x equal to 1 and write 1 cube 1 minus 3 into 1 plus 2, correct? Put x equal to 1. 1 cube is 1 minus 3 into 1. 1 minus 3 minus 2 plus 2 0. So comparing these function values, the greatest is the absolute maximum value, which is 4. Absolute maximum value of the function is 4, which occurs at the right end point, correct? When you put x equal to 2 cube is 8, 3 into 2 6, 8 minus 6 to 2 plus 2 4, the function value is 4. At x equal to, the function has absolute maximum value and the maximum value is 4. Is that clear? When you put x equal to 0, 0 minus 0 plus 2, that is 2. When you put x equal to 1, 1 cube 1, 3 into 1 3, 1 minus 3 minus 2 plus 2 0. When you put x equal to 2 cube is 8, 3 into 2 6, 8 minus 6 to 2 plus 2 4. So maximum value or the absolute maximum value of this function in the interval 0 to 2 is 4. Question asked in the year 1993. So we have completed all the questions of application of derivatives from the year 1984 till 2025. Okay. Some of the topics were deleted from this chapter, so we could find less number of questions, but still I've explained all the questions in detail, so taken more time for you. Along with the concepts, I've done the problems. Okay, I'll be doing much more videos. Many more videos will be uploaded in the coming days of indefinite integration, definite integration. All the PYQs I'm going to do from 1984 till 2025. Also, I'm covering JEE section also. Those are JEE aspirants also can watch our channel, subscribe to our channel. Okay, videos will be uploaded regularly. Not only NCERT syllabus of first PU and second PU, each exercise wise I'm solving. One video means it will be covering the one entire exercise. For example, if you are doing complex numbers, first PU, there are exercise 3.1, 4.1, 4.2, like that. Exercise trigonometric chapter, if you take 3.1, 3.2, 3.3, there is miscellaneous exercise, like that. 4 videos will be there of trigonometry chapter, like that. I'll be covering one by one. Touch the NCERT syllabus also. NDA, those are NDA aspirants, those writing NDA exam on September 14th, coming Sunday. So I've done the 2025 paper, okay, of April shift. Also, if possible, I try to do NDA of 2024 September shift. Okay, NDA exam has a mathematics paper with 120 questions. Those are preparing for NDA exams. I'll be doing all the PYQs of NDA exams also. Chapter by chapter, I'll be covering all the syllabus of NDA also. Synopsis of all the chapters of both first PU and second PU will be done completely along with examples. NCERT syllabus, both first PU and second PU, exercise wise, I'll be uploading the videos. Synopsis for various competitive exams like CET, NDA, JEE and many other competitive exams will be done along with examples. JEE PYQs also will be done from 2025 going back till 2019. Okay, PYQs of CET also will be done going back from 2025 till 1984. But some of the chapters there are exception because it was not there earlier. For example, 3D geometry was not there before 2014. So 3D geometry I'll do only from 2014 to 2025. That too in planes is deleted. 3D geometry planes topic is deleted. So deleted topics I won't be including. Here also many of the topics like tangent and normal, approximations. Earlier we had subtangent and subnormal, and we had angle between two curves. Correct? All those things are deleted. At present we have only 3 concepts in this. One is derivative as a rate measure, increasing and decreasing function, maxima and minima. Only three concepts are there. So I covered all the PYQs from KCET paper from 1984 till 2025. Whichever topics are there, only such topics I've done. Okay, the deleted topic is not done. Okay, with this I'll conclude my this session. Okay, thank you.